Not because it's my stuff, but because I always think that if somebody's got the desire, the dedication to transcribe the sheet, to cover that, generally they tend to do a good job.
All right, good morning. Get Joeri bounced into here.
Got it here, and we got
Good
our
morning.
first speaker lined up already. Good morning to you. How many hours of sleep was it this day? This time we stayed up late for all this, rocking.
Actually, you know, it's funny. I went to bed early. I was in bed by 3:15, so it was early for me.
It's pretty good.
Yeah,
it's
not
good.
too bad.
It was an exciting day yesterday. Very exciting day.
Sure was.
So Jim, I think for today we got a whole bunch of things lined up, and actually it looks like we may have another extra that we're gonna somehow squeeze in. We'll be a little bit flex on the schedule.
Yeah, we'll squeeze them in.
Excellent. So for those that have just tuned in, Jim Happel will somewhere today spend half an hour talking about his. I think it's called the Magic Projector. They found another great name for a product again. Jim is, of course, world famous thanks to Stupid Patrick's.
Yep.
Commercial offering available. He'll make some links in his channel. We'll set him up with the channel real quick as well. But I think this morning we're going to start with Frank, and Frank is going to tell a little bit about some tools that he's been creating to fill a need that all of us will recognize. When I saw his disc sleeve creator a few weeks ago, I was like, finally someone has picked up something that was 30 years overdue. So
right, yeah. We had some disc sleeve creators in the US back in the day, but you know, it's on the old
Matrix printers indeed. So I'm very pleased about that. He's got some other offerings as well. So I know he's prepped a little bit of a presentation on this. Him and I spoke about it as well. So what we'll probably do is have him just talk through it, and then you and I will come back on camera at the end and maybe do some Q&A.
Okay.
Before we close it. So
yeah, sounds good.
Frank, if you could go back on video and get yourself off mute, then hopefully we can start the day with you. Welcome.
And
we can see you.
There
Frank.
we are.
Hey, good morning.
Welcome.
Yeah, good morning.
Or good evening to you. I think
it's
evening,
about
7:30 in the evening in Germany right now.
Yes. It's 7:30 in the evening here in Germany. So I would like to start right now because just 30 minutes and we are a little bit overdue already.
It's all yours. The floor is yours. We'll put the focus on you. We'll go off on video, and good luck. Thank you very much.
I will try to share my screen. There it is. Presentation. So now you should see my presentation.
Yep, works.
Okay, I'll start with a little bit about me. I'm a software developer and trainer from Germany with over 20 years of professional experience. I'm born in 1978 and I got my first computer, the Commodore C116, when I was 8. So I got it with 2 games on cassettes and a book, the standard book about this computer those days. And I played those games, and a friend across the street had a C64. And so the games he played can't be played on mine because of incompatibility, and 2 games are not much. I were done with them pretty quick. And then I got a magazine, a German magazine with code in it. So I hacked the code into my Commodore and the game works. And so I wanted to understand why. So I read the book about the computer and learned programming and wrote my own program at the age of 8. So from then on, I continue learning, writing small programs, and a few weeks later, I am done with the book. I read everything, I tested everything, and wrote a small app for storing the phone numbers of all my friends and storing them on cassette, but it's cumbersome to rewind the cassette and play again and rewind and play and rewind. And if you have many programs on one cassette, it's not easy to find them. So you have to write on the shelf where on the cassette is what program. And so a year later, I got a C64 from my parents as a Christmas present. And with it, I got a floppy drive. And programming with a rubber keyboard wasn't fun at all. I started programming the C64. It had more RAM, it had more capabilities like sprites, like sit tunes, and other things. And I loved it. I loved it from the first day. Many things I've learned are useless on the C64 because of another basic, but I loved it. And from then on, I looked at over 30 different programming languages on different systems. I tried to write programs on every computer I could get my hands on, Atari, Amiga, Sinclair QL, whatever, CPC, 464, whatever. Later on the PC, later on I go from basic to C, C++, Pascal, Delphi, COBOL, Fortran, you name it. The whole list, up and down. And I want to understand why the person who created these languages created them this way. So I came across many things, many languages, saw many things, but I still prefer my good old C64. Many languages do many things very good. Many languages are good for different things. But if it comes to have fun with programming, have fun with hardware, have fun with games, nothing beats the good old C64. So over the years, I started tinkering with the old hardware, started to clean it, to repair it, to create new hardware for it, new circuits, do everything to preserve them and to expand them. And in the beginning of this year, I think it's January or February, I joined a small group of C64 users on Discord and talked to them, and we discussed things, and I got an idea. Maybe my tools can be helpful for other people. Maybe we can write complete programs on the web in a browser and copy it to the C64 in any way. And on the end of this presentation, I will show you my view, my thoughts, my wish that where this whole project will go. I don't know if I will reach it, but let's first have a look at the tool page I created. It's an online tool, everything's free. You can register, but you don't have to. You can use every tool on it, and I will add more tools, as I will show later. And maybe you need resources for colors, the hex codes. Maybe you need assembler. After years, I wrote the first assembler lines, and I thought there must be an easier way to find the correct commands, the correct opcodes for doing things. And I can't find a handy tool.
Hey, Frank. Frank, can I interrupt you for a second? The screen that we're seeing shared from you is the first page of your presentation in edit mode. I think you may want to share a different screen, otherwise we can't.
Okay. Then I have to share.
You may want to stop sharing and share again. So otherwise it's going to be hard to follow along.
Yes, I'll try new share this one?
Yeah, we can see this.
Oh, okay.
Yeah, a list of assembler instructions with explanations. That's what I'm seeing here.
Yes, that's
okay. Excellent.
the page I wanted to show. So if you write assembler code and you need to know and you forgot the correct code, maybe you want to write something to accumulator. Then you just type accumulator and you get all possible commands to write to the accumulator. And if you want to write immediate, okay, immediate to accumulator, and that's it. So you don't have to read long lists, you don't have to search long, you have it here in a short, handy way. If you want to know from where to where you can send data, you have this diagram, and if you follow the number, for example, if you want to write data from the Y register to the 0 page number 24, it's this. You have here the commands. So this was one of the first tools. Then I added a high-res character set. So with this character set, you can create your, with this character set editor, you can create your own character sets for your own games and download them direct as a D64 image. I have a character set screen editor where you can use your own character set to create screens and also download them as binary data to your local computer to use it in any software you want. Or you can download it as D64 image also. I have sprite tools for, I have a high-res sprite editor that calculates the numbers for you. I have a multicolor sprite editor that calculates the numbers for you. And then I switch to disk tools. I have a D64 hex editor where you can upload your D64 image, you can edit it, you can change things as you want and download it with the changes. Then I came up with a simple disk sleeve editor. I had a Word document to create sleeves and I lost it. And at this point I thought, okay, maybe other people can use this tool too. Maybe other people need a tool like this too, because I can't find anything like that on the internet. So I created a simple tool, but I created it with the complex tool in mind. So if you want to create complex disk sleeves with many images on it, or with just one image, for an example, I have Ghosts and Goblins or Ghostbusters or whatever. I go to the database, enter Ghostbusters, add my screenshots, say okay, say I have 4 images, say I want to get a preview, and that's it. Now I have a complete sleeve for Ghostbusters. You can use it with up to 12 images in different styles. There are many different styles for many images to create your own sleeves. You can upload your own images. And there are some improvements in the pipeline that are coming for this tool. And that wraps up my presentation of the tools page. I rushed a little bit through to have enough time for giving a short overview of things to come. Now I want to switch back to the presentation. Stop share. And now share screen, the presentation again. Why does that don't work? Share. Now you should see my presentation again with planned tools.
Planned tools, just a header.
Okay, that's fine. Next step is a disk label editor. So you don't just get the sleeves, you also get the labels for the disks to print on it, disk 1, disk 2, or maybe an image or two. Then the next step will be a D64 commander. That's a tool that's very important for me personally, because I want to edit D64 images on the fly in a commander-like tool, so that I can upload programs or download programs from an image, or change names, or copy programs from one image to another image. And based on this, I will add a D64 database where you can upload all your images to your private account if you're registered, and then you can search in it. So if you have sleeves, if you have numbers, maybe you numbered your disks from 1 to 20 and uploaded all images, then you can search in the database on which disk is that program. And you can find it, and you can maybe use your own disks to create new D64 images in the commander. So on the one side is an empty disk or a disk with software on it, and on the other side you have your own library of D64 images, and you can copy programs on that disk. So that's a tool I need for me personally the most, and that's the tool that makes the most work in the end. Another improvement to this I will mention later. Then I will add a basic code printer where you can upload your basic program and get an image or a PDF with all PETSCII codes with 80 columns per line, as you know it from the days back when you printed on your printer. Then you had your sheets with lines in different colors, alternating colors, I mean. And I think this can be interesting to show basic programs on the internet as an image, or to download it as a PDF or whatever. After that, I will add a multicolor character set editor and a multicolor character set screen editor. Basically the same as the existing, but for multicolor. And after that, I will add an image converter where you can upload an image, maybe crop it, and then it will be converted into 60 colors for the C64, and you can download it direct as a D64 image with a program that displays the image. So you have a binary file with the image and a short assembly program that loads it and shows it. So when I'm done with that and many things in parallel, there are many planned improvements to this. First of all, size adjustments for the sleeves. It turns out that some printers print the sleeves 4 to 5 millimeters larger than wanted. That's a driver thing. So I will give the user the ability to adjust it before creating the PDF. Then I will add the functionality to also edit the back of the sleeve with the information how to prevent damage. You can exchange it or put your own images on or text on or whatever. Then more functionalities for the high-res character set screen editor and more direct communication. and more functionalities for the two sprite editors. So basically, every function that exists in the character set screen editor, in the character set editor, will be added to the character set screen editor in one or the other way, and more functionalities for the sprite editors as well. Same functionalities where it's where it matches the needs. After that, I will add direct communication from the tools side over the server and the VIC64. That's a LAN module that connects the C64 to the internet to the local 5041. That's one of my main goals, to have a communication directly from the browser over the internet to the local 5041, so that you can upload your images from your disks directly to the tool page, and from there back to your 5041. Maybe you change your image, you can write it back, or you can write a program directly over the internet to your 5041 or whatever. You can insert the disk into your 5041. The program detects the programs on it and creates automatically a sleeve with all programs on the disk for you, full automatically. That's things I plan for the future. So that direct communication, direct storing your images, your screens, your character sets, all you do directly to the C64, to the drive, and loading it directly from there. So you can create complete programs on this tool page and write it there in one step. Maybe a functionality export project or update project on disk or whatever. That's my first main goal I want to reach by next year. And then in the far distant future, I want to create a custom module for the expansion port with built-in Wi-Fi and RAM expansion, so that you can communicate from your computer directly or over the server with your C64 and the RAM in it. So you can write directly to the RAM. You can edit your RAM in the browser. You can edit the registers in the browser. You can create a software, maybe in assembly, maybe a screen, maybe a sprite, and write it directly to the C64 to see it there, to see it running on original hardware. So that's for the far, far, far future my goal. So I think the possibilities are endless when we are there. That's the point where everything is possible. Maybe, and then that wraps up my presentation, maybe we will reach the point where you can create with a tool, small point and click adventure, or a small other game, or a small tool, or whatever, online, write it direct into the RAM of the C64 and use it. That would be really, really great. And that was my idea why I started it online as a website, as a web app, and not as a program for a computer. So stop share. Now you should see me again.
We got you again.
Yes, we do.
Exactly, Frank. Frank, thanks a lot for taking us through your presentation. I've got a couple of questions. First of all, I had not heard of your website until maybe a week ago when we first connected. I'm super happy. I'm actually very happy you went through the different tools. There were a couple of other items I had not even seen yet. I would have invited anybody and everybody that's seeing this, go to Frank's site, try some of these tools already. I really like the fact that You can just, you don't need to download anything. You can just start with this. I liked how you used the example of even a database that has quite a few games in there already. The vast majority of your sleeves in your current diskette box that you'll have will all be old, crappy sleeves that are long faded. This is an ideal way to go forward. I'll tell you, on your long list of projects as well, Frank, I'm doing a +1 vote on the sticker. I've lost every single sticker.
Labels for sure.
Every. Oh, that's beautiful.
I prepared some to show.
That is awesome.
How they could look like when they are ready.
Yeah, this is awesome.
Oh, nice.
We wish we had that back in the day. Yeah, that's awesome. So it's really handy. What I really liked as well, where you showed the command set and kind of the interrelationship between them, where you can do a quick lookup for assembly commands. I think that's really useful. I can't remember having seen that in an interactive way anywhere before. I've got them in books, I've got them in printouts, but doing this in an interactive way is actually a really novel way of doing this. So that's very, very cool. Now, obviously, I've got to ask you, because Americans will be, will be surprised to hear that you started with a C116, a 116.
Yes.
You're going to show one. These are very rare here in the US. Very, very sought after.
So
that was your first machine before you went to the C64.
Yes.
Is it still operational, Frank?
Please, what?
Is it still operational?
Yes, it works.
Wow.
It still works.
You should hold on to that. That is a lot of people will not have seen one of those before. Now, so you kept your original 116. You've got your original C64 as well still. That's fantastic.
That's the one.
That's the one that we see in the background.
Yes, over there.
Compliments on the background, by the way. You worked hard this past week. When we spoke with you, you still had everything set up there.
Original games from back then when I was 8.
Well, it's interesting you put these forward, Frank, because what I didn't see, I was a bit surprised about, given the long list that you had. I didn't see a sleeve editor for the tapes on your list of programs for future.
Maybe. I don't think that the need is as big as for disc sleeves. I also thought about a disc label editor for 3.5-inch discs.
For the 3.5 for the Amiga. Yeah, that's another one. I think it's good. The sprite editor, I saw David was already creating some artwork.
I didn't realize he was an artist.
Yeah, he's making with the high-res sprite editor. He was already making a CRX logo. So this is really, really cool. So this sleeve editor that you've got, it generates a printable file. I know the answer because I tried it out. So it generates something where you can just press print on your and it will output it. It looks really fantastic. It looks exactly like he just shown Jim.
I gotcha. Okay.
A PDF like this.
Yeah.
You can print out, cut out, glue, and you have your new disc sleeve.
I love that you took Ghostbusters today. That's awesome. Yeah, I think this is a very, very cool tool. And it's a cool tool set. It's going to take me a while to go through it. I would highly encourage everybody to try these out. How do people best reach you? Is there a contact form or something where people find bugs or feature requests or anything? How do they best get in contact with you, Frank?
There is a contact form, and I'm also available on the Discord channel I mentioned there.
Okay. And I know you're pretty active on Facebook as well. That's where I found you, indeed.
Not so active, but every now and then, if I have something new, I post it there, and that's it. Okay, that's good. And then, of course, we've opened up a channel here as well for people that have questions. That we invite them to go and see yours. I'll be there. Frank, awesome. Thanks very much for making the time to present to us. I really think that next year we should try and do a checkpoint on where you are with some of the future plans and where the tools are, and kind of see and do an update on this. I agree.
Great.
Okay. Frank, thanks so much. You have a great evening there.
Yes.
Have a great day, and I'll be on Discord for questions.
Thanks
Great.
so much.
Thank you.
See you.
See you.
Bye now. Okay, so Jim, where did we end up with Mr. Happel?
Okay, so what's going to happen is that we move the schedule a little bit, and Jim's going to go at 2 o'clock his time, which
Okay.
is noon our time.
Okay.
So it's the end of my SolidWorks presentation. I will just chop the last part of it off. So I
Yeah.
will go through or chop some of my stuff off. So
Okay.
yeah, so we're good to go. So Jim will go at 12 o'clock our time. If you're looking
Okay.
at our West Coast schedule.
Okay.
And so
that means we've got an hour now on
Yeah.
SolidWorks.
yeah, we can do that hour.
That
SolidWorks
is
fine.
awesome. So Jim, what I propose we do is we'll try a little bit. We'll talk a little bit about first, like why you would even need a tool like SolidWorks, not SolidWorks specifically, because obviously you've used several tools over the past decades to create your products. That market has changed quite a bit. These tools were always very expensive. Then for a little while they became very cheap or free.
Right.
And then once a lot of people got hooked on it, it's like crack almost. People started making them more expensive again, and that's
Sure. And there's more and more competitors, in the industry too. So
Right.
I actually learned from somebody from this Discord that we have that there's another piece of CAD software as well that I looked into just a little bit. And so we add yet another one to the list of things that people have as an option.
Yeah.
But, SolidWorks has been like, there's AutoCAD and there's SolidWorks.
Yeah,
Those are the ones you hear.
for decades.
Yeah,
truly
so
for
those are
decades.
de facto standards in the industry.
Yeah.
And of course, whenever you think of those titles, if anybody that knows anything about them, the first thing they think of is dollar signs because they are
Yeah.
expensive packages.
Yeah.
But rightfully so. They're the professional grade tools.
Right.
And so when Autodesk, they made Fusion 360, and then they made the Maker version of it, which was $360 for a license for a year to go along with Fusion 360. It kind of pushed Dassault, which makes SolidWorks, into looking at they had to do something to compete with it, and so they did. They made what's called SolidWorks for Makers, and it's I wouldn't say dumbed down version because literally it's almost identical to the full, multi-$1,000 package.
Yeah.
There's missing some things that makers wouldn't even use. Like
Right.
there's like Cosmo Flow and things such for doing flow analysis and all the different little plug-in packages that you can get for SolidWorks. They don't exist for this, but there's actually some things in there that are pretty interesting because besides having a standalone application, which is what I use for everything, they also have web-based applications. So you can log in any place in the world, literally, and you can use XDesign and these various things. So I was going to pop up my screen real quick and show you. This is.
So, and I guess so for you, Jim, while you pull this up, have you been on SolidWorks in the past decades, or have you kind of floated between different tools?
So I started with SolidWorks in 2007 or 2008.
Okay.
And before that, I don't remember what I used before then. I used Rhino and I used a few other programs back in the day. I've used Fusion 360. In fact, I used Fusion 360 for quite a bit of the keycap campaign.
Yeah.
And the reason why I did that is because I like the rendering a little better in Fusion 360. Well, I used to. Now the new one SolidWorks is even better. So it's one of those things that they go back and forth.
But and that's the thing, because obviously as a commercial enterprise, you use these programs in the different versions, if you will. Today, we're demonstrating
for my day job, I use the real ones.
Versions.
Right.
But as far as you're concerned, at this moment in time, for makers and most of the people that will be watching this, you say it's got everything and more that you need. Yeah,
this is it. So I've got my screen shared here. So if you go to, I've got a link in the Discord channel as well. And SolidWorks, Dassault has no idea I'm doing this. I'm just doing it because this is what makers need to know.
Right.
So basically, this is, you can see 3D experience for SolidWorks for makers.
Yeah.
And the thing about this is it's $9.99 a month.
Yeah.
If you want a license.
Yeah.
Or $99 a year. You pay one shot.
Yeah.
And the only limitation for this really is that they require that you don't make a bunch of money on it.
Okay.
You know, you make your
a
products.
limited commercial.
Yeah,
use.
they're trying to say that you cannot make any more than $2,000 a year for commercial
Okay.
use, which
Okay.
is, you know, for makers, I mean, realistically,
That's
open
fair.
source projects and all that stuff, it's not really a big concern.
Yeah.
So so that's the website. Actually, you can go
Hey,
and you can look at
because
videos.
I remember, so Jim, I remember with some of the other tools, the restrictions that they've been putting on them were often in the file formats that you could output, and therefore the file format that would come out of it was of no use really anymore.
Right.
for
Yeah. So
3D
Fusion
printing.
did that initially, and that was the big showstopper. They
Right.
said they're going to stop allowing the export of STEP files. Well,
Right.
STEP is like the de facto standard of everybody has for importing their models and stuff. So
Right.
it's actually, because everybody has their own proprietary format really for
Yeah.
sending their data. You know, SolidWorks has XT files and stuff. They're called parasolids, and you know, Fusion has what F3D files, and
Right.
so and basically they're, you know, they're proprietary. So the STEP format and STL format, which people are used to with
Yeah,
3D
yeah,
printers and stuff,
yeah.
those are the things that can be shared among. But STEP is a solid model where you actually get all your features with
Okay.
a STL file that's triangles, and so your resolution is basically whatever you outputted
Okay.
the resolution for, you know, a number of triangles in your STL.
Yeah.
So STEP's the way to go. So yeah, basically it's the SolidWorks for makers. It can export, you know, all of its own formats plus STEP, and so
Okay.
there's
That's
an
fantastic.
STL, and STL is
Yeah.
like the one we really care about for makers because that's the one you're going to send to your 3D printer anyway.
Yeah. Yeah.
So, but yeah, it's a fantastic package, and the online version works really well. It's a little hard to get used to if you're used to the desktop version,
Right.
but it's a lot more simplistic.
Yeah.
But the desktop version is
It's the way
just
to
like
go.
it's
Right.
just like the first the
So
full
and
scale.
so today I presume we're going to use the desktop version
Yeah.
of the desktop Maker Edition version of SolidWorks.
Yep, that's what I'm going to do today, and I will share the screen here. So what we typically want to be using is some kind of, okay, there it is.
Yeah, we got it.
Some kind of software that we can design something in. So, you know, for retro computing, obviously a lot of things are old, a lot of things are brittle, a lot of things break, and we need, like, you know, things to put things in, like enclosures. And so for things like that, you know, a Maker Edition is perfect because
Yeah.
you don't want to spend a bunch of money on, you know, a high-end package just to build a case.
Right.
To build a cartridge case, or like last year we did a real quick synopsis on this whole thing with the SX64 end caps.
Right.
So I
Right.
got a lot of questions about that, and I kind of went over some of how it works. And today I wanted to basically spend a little bit of time explaining how you actually model something.
Okay.
So the gist of what you want to do. So I'm just going to open this up here.
So to put that clear, what today hopefully will bring is a design start to finish. People can just pause, rewind, and kind of.
Yeah, if not the
hopefully-
complete design, then we'll at least get some of it because we got a half
Okay.
hour chopped off for
Sure.
Jim's presentation,
Sure.
so we'll get through this.
Yeah.
So one thing that you have to understand is conceptually how you actually design something, and how things work in a three-dimensional space. Because with a parasolid design tool like what SolidWorks is, that's what you need to do, and needed to know how you go about designing something.
Okay.
So let's take, for example, a cartridge case, okay, for 64. Let's say you want to make a case, and I could flip actually real quick here. I will stop this and I will flip here. So I got a couple different cartridges. This is a clear cartridge case.
Yeah, everybody will recognize that one with a
Sure.
little screw
And this is it in
insert.
white. Yep.
Yeah.
So let's say you wanted to design this yourself for your 3D printer.
Yep.
because we don't have these. This is actually injected molded part.
Yeah.
But if you've got a 3D printer, then you could actually make one yourself.
Yeah.
So there's things about 3D printers that are a lot different than making a part to be injected molded. So in injection mold, you have to get the plastic piece out of the mold when you've done it. Okay, so they squirt hot plastic into the mold, it cools, and then it ejects it out of the mold. And they use what's called ejector pens, which push the plastic out. What would happen, do you think, if you've got plastic where it goes in and it has to come out through this small hole at the bottom? You can't get it out, right? So you have to make sure that whatever you're tooling, you've got a bevel, it's an angle, it's called a draft, where you can actually push the part out and it comes out of the thing. Now on a 3D printer, we have the luxury of doing whatever we want because we don't have to pull it out of a mold. Right. And so you have to think about in terms of what you're building and what your end goal is. So if you're going to be building a 3D injected part, you can see that actually this one, because the edges are, you can see they're beveled.
Yeah.
On both sides here.
Yeah, clearly.
And you have to have even more of a bevel if you have a texture, because the texture sticks to the steel. And so now you really have to push it to get it out. So the more bevel angle, which is a draft, the easier it is for the part to get out. And so for a 3D printer, I mean, you can have straight down, you could have in even if you wanted to. Well, we could never do that with a 3D part. So you need to think about what you're going to design first and what your goals are. And so we're going to think about just 3D printing for what we're doing today. So we don't have to worry so much about our draft angles and that. And then so we have to figure out, when you're designing something like this, we have a second half of it as well. So these have to go together. And so there's some fundamental design rules that you have to follow for something that's going to be usable. So for example, when I put these two pieces together here, what's to prevent me from just simply rotating these and then so that they don't lock in place? So we have what's called a lip. So there's actually a small piece that's extruded out. And then on this side, there'll be a slot to hold that lip. And what that does, it prevents you from, from actually being able to rotate it.
Clearly.
Yeah. Otherwise, I mean, you could do that if you wanted to, and just use, the
it's
fact that you've got
or something. Yeah,
you could use the fact that the screw actually holds it in place tight enough where it won't rotate. But inevitably, when you're pulling your 64 cartridge out, it's going to rotate, and it might get stuck in the case. Can you imagine if it was stuck like this inside your case? Would that be good? So these are the things you want to think about. So with SolidWorks and a lot of the different programs, it's interesting that you design it as one solid block and do everything, and then cut the case in half, which is a possibility using a split function. And then it creates two separate models at that point, at which point you can work on everything. Or do you build this one by itself and this one by itself? Those are the two different ways you can do it. It's faster, sort of, if you do the build it and then split, because if you were to do like if you look at this, these corners are not like 90 degrees, they're rounded.
They're rounded. They're
rounded. And same thing with the sides here. You can see they're rounded as well. They're all rounded, right? But notice here, because this is a 3D injected part, that let's see if I can get this to do here. There's actually it does this. It's got a contour to it.
I do see that.
So it can get out of the mold. Because if you don't have that, then it's nice. But like on a 3D printer, we don't care about that so much.
You can make it nice and square.
You can make it square. You can make the whole thing an exact, rectangular, ugly looking box with no, beauty lines or anything like that if you wanted to. So when you first start designing, the first thing you need to do is pick up whatever it is that you want to build and then look at it and say, okay, how am I going to build this? What's the most feasible way for me to do it? And since we're doing it as a maker space, we don't care about, traps and stuff. So we just need to figure out, are we going to do it as two pieces, as one piece to start with, or how we're going to do this? And, do we want to have like these ribbing lines? Because the ribs are easier to do as one solid piece. You can actually wrap the ribs clear around it and cut them all, and then cut this in half, and then you would have it easier. So we'll do a couple different things today to show you that. So conceptually, when you do a model like this, I'm going to go back to my screen
share. These are fantastic fundamentals, by the way. I'm already thinking like, okay, oh, so that's why these look like they did, and there's no need, like you said, for a 3D printer, there's no need for that. So the target platform of production in mind, keeping that in mind, will help you tremendously to
Yes.
design for the purpose.
Yeah. So for SolidWorks, we're going to pick a part or an assembly or a drawing. I don't ever use drawing. This is nice 2D drawing, so you can do it for your reference. The part is a single part. An assembly is a series of parts that are put together. And
Okay.
so I'll show that as well. So we're just going to do a simple part. And so this is the whole thing of what SolidWorks is, I think, probably the most confusing for everybody that, or actually even just in CAD programs in general, for people that are trying to start out. So we have what's called X, Y, and Z. And so you can see that I have selected, like, this is the front plane, this is the top plane, this is the right plane. And if I turn these on, all of these on, you can see this is our maker space. We have X, Y, and Z. So if you're going to be looking at something from the front side or the right side or the top side, this is how you can design your piece. So when you design something, you say, okay, what is it going to be best for me, the maker, to orient the part so I can get a reference point?
Okay.
Okay, so let's say for an example for a cartridge, this would be something to me, which we'll do today. I'm going to turn these off because it gets confusing otherwise to me. So the front plane, I'm sorry, the top plane. So this is the top view down. So I'm going to design this like I'm looking from the top of the cartridge down. You can design
and
it
I'm
on
already thinking like on the okay, it's laying flat. It's laying flat
Yep.
on the table.
Right. So that's, and then in order to create something, we have to make what's called a sketch. And there's multiple sketches that make up your part. And then once you've made your sketch, then you can perform an action on it, which is called a feature in SolidWorks. So let's do this. Let's just say we're going to make a sketch on this plane.
Okay.
And let's say we want to do just a simple box. Okay. So now we've got a box in this plane. And let's just say that's it. That's all we're going to do.
Yeah.
And so now we've got this. Now we can grab our mouse and we can look at it, and it doesn't look too spectacular. But if we look at like the planes, we can see in reference of where that particular thing is in space.
Yeah.
And so if we select our sketch and then select a feature like extrude, which means to pull apart.
Yeah.
So, and I can literally drag this, and you can see what we've done. We've taken that little box that we made, and we have changed its height. And when we're done here, it'll just make something that's a solid like this.
Okay. Yeah.
Okay. So this is the whole fundamental of SolidWorks, literally. And there's a billion ways to build something. So let's say, for example, you wanted to make a U-shaped box. You could actually draw a U shape in a sketch and then extrude it out.
Yeah.
Or you could draw this piece here, and on top of this, you could put one side and then put another side, and you'd have a U-shaped box.
Okay.
So when you're designing
so
something,
two different approaches with the same result.
Exactly. And well, and there's other ways to do things too, with revolves and stuff for doing circular things. So there's no real wrong way to build a part, I don't think, except for, and later on in SolidWorks, you'll understand when you get really involved into it. If you want to scale something, it's because the scaling works exceptionally well in SolidWorks, but it works from one fundamental standpoint, and that is the center origin. So if you notice here that we have this little origin in the bottom left corner that shows you where the orientation is of your part. Okay, so if you go click on the origin button here, it lights up where the origin of this entire scene is, which is over here.
Yeah.
So if I were to scale this right now, it would not scale proportionally to the origin.
Okay.
It would scale off to the left-hand side because that's where I'm at. So if you wanted to scale something from center out, which is how you want to scale something, you would want to orient this part so that it's over top of the origin. And you can do that. So you can see here's the right plane, and here's the top plane, which we used. And here's the front plane, which is here. So you can see they're not centered.
It's completely off. Yeah.
Yeah. So I always build everything to origin.
Right
Because
in the, okay,
you never know if you're going to have to scale something or move something.
okay.
And I find that replacing parts and stuff, everything just works better because it makes a lot more sense to do it that way.
So, but in this case, you're already off. So what now?
Okay, well, so we can fix that. So what we're going to do is go back to our sketch. And for me, I cheat because this is something I've always done with every CAD program. To move something easily and universally, it's a lot better to find the center of it. Now, there's ways you can find the center, but you can see like a little center dot there.
Yeah.
But this is actually a line called a construction line. And you'll see that it's actually, I don't think it matters if I zoom in. Yeah, it does. Okay. It's actually a dashed line.
Yeah.
It's not a solid line.
Yeah.
So an actual line used is solid, and then a construction line, which is just a reference line, is dashed.
Yeah, it won't appear anywhere. It's only used in your sketch.
Correct. It's for referencing.
Yeah.
So I like doing this. So what I'm doing basically is I am just dividing this.
Yeah.
And
you got
so
the
now,
absolute middle now.
right.
Yeah.
So the reason why is that you can grab this now, and now you can actually move this around. Okay. Which kind of helps for what we're doing here, right? But what we didn't do, we needed to find what the size of our box is going to be anyway. So we know from a cartridge, cartridges for 64 are 63 wide for the standard cartridge, and they're also 87 tall. This is millimeters, by the way, which I rarely use, except for overseas clients. So now that we've got this defined, and what all I did was called a smart dimension. Dassault actually has a patent on the smart dimension feature, which why you're not going to find it in any other program the way they've got it here. You can click on an edge or something like in Fusion, and you can add the dimension. But smart dimension is nice because you can literally go from here to here, get your angle and things like this with it, which is great. But once you've defined this, because you have made this box so that I don't know how to define this. So we define these 4 quadrants here. So now when I grab this, it's going to move. I can get out of this menu there. It's going to move the box there. So now it'll move the box as a whole.
Yeah.
Okay. So in SolidWorks, if you want to move something and pin it to a location for the permanent reference point, I can just simply click the center of the box, and I can hold the shift or the control key, depending on what you're doing, and click the origin. And on the left-hand side here, you're going to see some options. So you can do a horizontal, a vertical, or coincident. And so what horizontal means is that you can see the reference point to this height here. If I say horizontal, it's going to drop this
line up this way
to here, right? So if I don't want to do that, I will get rid of this.
Yeah.
I'll just move this. Actually, it's already pinned to that one. Let me get rid of that there. So, now I messed it up. I can also hit Control Z.
Yeah.
Which is nice because that gets rid of everything.
Yeah.
So I will do what's called coincident, which means it moves that to this particular point.
Okay.
And so now it's moved it to it.
And so now it is exactly at that middle point.
Right. So if I exit the sketch, now we're going to find our box is exactly
in all dimensions.
Right. So the front plane, even though that we can move it like this, and the top plane is where we started.
Yeah.
And then the right plane is dead center as well.
Yeah.
Now notice one thing about the top plane is it's actually on one side.
Right.
So we can adjust that so that it's middle. And how you do that, in fact, I will show you. We're going to go back to we're going to edit the extrude we just did. And so if you do what's called a mid plane, it will actually
it extrudes up and down.
Right. And then you can set the dimension of your extrusion. So we know a cartridge is actually 20 millimeters thick.
Yeah.
Both sides. So this is it. That's the entire shape of a Commodore 64 cartridge.
Well, lessons over, people. This is it.
Yep, this is it. So like I said before, is that if we want to design this so that we split the case after the fact into 2 pieces, it would make it easier. Let's say, for example, we want to round the corner. So we're going to click these 2. We're going to call this the top side of the case because it doesn't matter which side you pick because nothing's been done and set in stone yet.
Right.
So I've highlighted both of these corners.
Yeah, I see that.
And then in the upper part here, there's an option called fillet.
Yeah.
And one thing about the Maker edition that's amazing, the standard version has this a little bit too, but the Maker version, you can see there's actually a definition, a whole entire description of what the function does.
Okay.
So it says fillet creates a rounded internal or external face along one or more edges. So it gives you an idea of exactly what that function does.
Right.
So I click on the fillet, and you can see immediately.
Oh,
it wants-
beautiful. Yeah. Yeah.
Right. So then you can go over to the left-hand side and you can adjust your parameters if you want to do asymmetric or symmetric. Actually, whoops, that was my fault. I hit the escape key. And then you can set your size. So obviously 10 millimeters is pretty big. So 20 millimeters would be really big.
Yeah.
And that's like way too big. So let's see how 5 millimeters looks here. 5 millimeters is not too bad, right?
Yeah, that looks
Too bad.
nice.
So it's a nice preview. And then of course, when you click the OK button, then it gives you that.
Yeah, it's beautiful.
So
Yeah.
touch around corners.
Yeah.
So let's also round these. So you
Okay.
just basically
Yeah,
you
the
click.
top, yeah.
Yeah, if you make it, one thing about this is it's like any software really for the PC. If you
Yeah.
click the wrong thing, you can always do shift control to unselect it. Or you can just control, we'll select each one. And let's go do this side as well. So we'll do
I meanwhile
back.
put a card in front of me to kind of continue to follow along with a real part in my hands as
Yeah.
well.
Okay,
Yeah.
so now we've highlighted these. Obviously, we don't want to round the bottom ones
Right.
because there's no reason to do that for
Yeah.
our cartridge, just the
Yeah.
top side. So we're going to go back to our fillet. And then, well, so that's way too big. That'd be a little
Yeah, that's
ridiculous, I
crazy.
think.
Yeah.
So let's do 2 millimeter. Does that
Yeah.
look better?
Yeah. Maybe.
Okay.
Yeah.
2
Yeah,
millimeter looks pretty
fantastic,
good. So that's rounded. So you notice that in this particular view, I'll zoom in a little bit. You can see that there's like black
Yeah,
edges
these
on
lines,
everything.
yes.
Yeah. So in the pull down menu up here, if you want, you can change the display so you can get rid of those to see what it looks like without it.
What is that view called, Jim?
So if it's called display style,
Okay.
and it's a pull down
And this
menu.
is
at the
really
top.
how the product would come out, if you will.
Right, exactly. So, but this is nice because it shows you definitions
Yeah.
with your eyes where you can see where the
Yeah.
start and the stop of the fillet occurs. So, okay, so we've got
Oh, we got a great outline already here.
yeah, so this is a great
Hey,
outline.
so to this, so
Mm-hmm.
we're using some sizes here now from let's say we're going to 3D print this, because most people that will make this would probably have a 3D printer. Some may have an SLA printer, but the vast majority would probably have a 3D printer.
Yeah, FDM, right? Yep.
Right. Would they, given that the FDM is what, a layer thickness of what is it, 0.2 millimeters or something, does that play a role at all yet in what we're doing here?
Well, it does, and this is like again back in the original design process, what your conception of what you're going to be building when
Yeah.
you're going to be building it for a 3D printer, as you know, Joeri, because we've
Yeah.
both been doing 3D printing for 10
for
plus
a long,
years.
long time indeed. Yeah.
When you go to print something on a 3D printer, you have to figure out how you're going to print it. Is
Yeah.
it going to be printed on the top side, the back side?
Right.
What's going to be the least amount of support material you're going to have to use? What's going to work for bevel? So for example, if you're into 3D printing, let me set this to here. So if we're going to 3D print this and we use this as the bed
Mm-hmm.
and we print it, we have this curvature now to contend with.
Yes.
So will this curvature come out okay as we're actually doing the slicing of the layers? Is
Right.
it enough of an angle that the overhang won't cause a problem where you require support right here in this
Right.
corner?
Right.
You know, is that will be a concern. It's a concern the entire thing when you're doing something like this.
Right.
Or when this is cut in half, do you actually print on the part that's flat? And then when you're finishing the top layer, is this curve going to look nice enough when your 3D printer, depending on the resolution you've got set for, like your 0.02 or whatever? So those are the considerations for an FDM printer. They're the same considerations for a resin printer as well, but they're different because the fact the resin printer is backwards, it's inside out. So, you know, it's
Yeah. Yeah.
resin printer is actually difficult to get a grasp on if you've done FDM printing
Yeah,
for
if
a
you
long
have
time.
done FDM. Yeah, and I
Yeah.
think the vast majority of people here are still on 3D print. So
Sure.
it's
So
probably right, but
the rule of thumb for standard FDM 3D printing is the least amount of supports, the better you are.
Yeah.
because and probably put the supports inside of something on a surface that you don't see,
Right.
because they get broke off. And you know,
Right.
and honestly, on a resin printer, it's the same thing. You want to try to hide them as much as possible,
Yeah.
but it's a lot easier to sand off the resin printer
Right.
than the FDM. Okay, so we've got
So Jim,
this.
just saw a pop up on your screen as well. So this is not saved yet. Eh? Where does this edition save? Because some of those were
Yep.
were forced in the cloud. Is this still local?
So this is both. You can
Okay.
actually, I can save to my 3D experience,
Okay.
or I can save to this PC.
Oh, fantastic.
Right. So what we're going to save actually right now
Yeah.
to here. And I did a test one already just
Yeah.
to play around here. So I'm going to go back to this directory, and I'm just going to say case, because this is what this is just an enclosure
Yeah,
right now.
yeah.
So that's saved. And so we have this design. So do we want to continue working on ribbing on here or not? So in the essence of time here, I'm just going to go split this apart. So remember we did the mid plane split of
Yes.
the extrusion here.
Yes.
And so you can see in our
Yeah,
plane
that's the
here is
middle
right in the
point.
middle.
That one is
That's the
above
middle
the
point.
table, one under. Yeah.
So if you go to top plane and you go to insert, and then you go to features, and then you scroll down, you can see this thing's got a ton of features.
Yeah.
You can do what's called split.
Okay.
And I say cut the part. And then now you can see I can switch between which ones I want
Yeah.
to cut. I'm actually going to cut both. And I'm going to give them a name. I'm going to call this one top. This
Top
will be
to
our
bottom. That makes sense. Yeah.
Yep. And I'm going to call, okay, this one POTTOM. Okay, and then I'm going to go ahead and say cut it. So now it's going to do its magic, and what you get in the end, I will show you in the pull down menu. So now you have the original case we did,
Yeah.
and you have also a top and a
Oh,
bottom.
top and a bottom window. Yeah.
Yep. So I'm going to go ahead to the top, and now you're going to see this is exactly what we just did. We have
Okay.
one half of that. So the case is going to be the same for both of them at this particular
Got it.
time. Okay, so then we pick up our case, our plastic enclosure sample that we've got. So hopefully you've already designed your idea in your head, or you've got a sample to work from. So for example, we've got the case that we showed earlier in the video.
Yeah.
And so we'll work on, let's see, we'll work on the top one. So this is the one that has the label recess for the window.
Right.
So for me, I'm kind of a stickler for some of these things, and let me go and
Do elaborate.
yeah, all right. Yeah, hang on just a second. Let me pull up this. Okay.
I think from a 3D printing, with the top, with the top, you would print it upside down. If you would make a recess in this, is that not going to cause a problem with kind of like the bed not being, you know, how are you going to make that?
So-
Because these beds can make these nice surfaces these days, but if you're going to make a space for a sticky, because you would put a label or something on it.
Right. So that's the thing you have to do in your design consideration. So if we want to put a bunch of ribs on here
Right.
and a recess for a label,
Yeah.
obviously you're not going to want to print it this way with the bed down.
Right. Because that comes out real ugly.
Right, it does. So at that point, you're going to have to print it this way.
Yeah.
So that your last layers being printed are in fact your ribs and your recess. So again, that's part of your initial design, you know, your conception of what you want to build, and then you have to figure out how you want to build it, and then at that point, how you can possibly build it.
Right.
So we know that inside of here has to get all cut out to be hollow, because obviously you can't put a circuit board in
right
here.
now it's a solid piece. Yeah.
It's a solid block, right? And so one thing we also know is that there's a command called the shell command. And I'm going to do a shell command, and I'm going to show you, and you can tell me what the problem is with this. So a shell is really neat. You just simply pick the face that you want to shell out, which is going to be this side.
Yeah.
And then you go to the shell function. And then you can set the preview. And we will set the thickness of the case. So how thick do we want the walls of the case? We want them to be
Is that what, 2 millimeters?
2 millimeters. Yeah, so 2 millimeters. So now I say 2 millimeters, and I say okay, and ta-da! So it's now hollow. Oh, but
Yeah.
wait a minute. There's a problem here.
Oh yeah, but this is all enclosed again.
Exactly. So the bottom, we can't exactly plug this into our 64 because there's a
Right.
wall here.
Right.
So what the shell does, it actually shells out the wall thickness that you specify. So we're like, okay, well, that's not going to work. So we're going to have to think of a different plan of how to get rid of this. So again, like everything in SolidWorks, there's 50 different ways to do this.
Yeah.
What you could do is you could actually make another sketch on top of this that cuts this all the way down flush with the face here.
Okay.
And that would open up this wall.
Yeah.
And then you have to contend with the of putting in a fillet in here if you want to make it nice and smooth in here as well. So what I tend to do is I like doing the shell after any kind of cutouts.
Okay, so we're going to take one step back. We're done, and we're back to the solid piece.
Right. So what I know that in the cartridge that we showed earlier, there is a wall in there.
There is, yes, to
yes,
make sure it won't flex.
Right, and also
it also is a little bit lower, so it holds the PCB.
Right. So there, right, exactly. The PCB rests on top of the wall.
Yes.
So if we measure that on our example, we know that it's about 10.5 millimeters from the base of the cartridge up to where that wall goes.
Right.
So let's do that. Let's just take this surface we're going to do, and we're going to put a sketch on it. It rotates it around. Let's go this side. And what we're going to do, we're just going to make an arbitrary sketch like this.
Yeah.
And then we know that our wall thickness we want needs to be 2 millimeters thick.
Yes.
So let's go to our smart dimension, and we're going to say from here, and then when it gets highlighted, I'm going to click it to here.
Mine is a 2 millimeter gap.
Right. So it says 4.39 now roughly. So I'm going to set this at 2.
Yeah.
And so this is
so
the thing
I heard,
about,
and by the way, I'm gonna, because there's good conversation on the Discord going on as well.
oh, okay.
You can mix and match millimeters and inches in a specific design that you would have. You can just identify, you could just type 2 mm versus.
Correct. Yeah, you can also
0.28.
do mathematical formulas too.
Yeah, which is fantastic. If you think, because in this
And
case,
you can also add labels. So if you want to have a reference point to say, you know, this is like 64 wall thickness, you can literally call it that if you wanted to. And then instead of entering a value, you enter that name as a label, and it would automatically assign it to it.
Right.
So let's say, for example, here, like this is 6.6, I could say 2 plus 2 plus 4 divided by 2.
Yeah.
And it'll actually calculate, and you can see what you were saying earlier, that here's all your different things it'll support. So centimeters, feet, inches, micrometers.
Oh, micrometers, you know, you can, we're not gonna need that for our beloved machine.
Probably not that accuracy required. So I'll just do 2. Anyway, so there's 2. And then, so we know that from this line here, which is where that wall is going to start, to the edge of our cartridge, which is basically the base that you plug in, we need to make that to be 10.5 millimeters.
Okay, 10.5 millimeters for that. Okay.
Now, so when we cut this out, we don't really care where this line is, as long as it's not like in the part of the cartridge.
So it can cut in air, no problem. It's completely irrelevant as long as it's outside.
If you're really a stickler, and one thing that's nice about this with SolidWorks is that if you were to make, like, you click on this and you shift click this, our left hand side over here again, there's an option that's called collinear, and what collinear does is it fixes it to the edge. The reason why you would want to use this is that if you were to extend the length of the cartridge, let's say later on you go, oh man, it needed to be 88 millimeters, not 87. Right. It will automatically fix everything for you.
Fantastic.
Whereas
so
if
this
you
kind of comes back to your considerations of sizing and resizing, not just from a center point, but also where you have spaced all, or where you have connected all components in such a way that these changes will actually have no effect to everything else that you.
Correct. They're automated changes.
Automated,
so if you were to have, let's say you wanted to make this from 87 to 95, and you didn't have the line far enough, well, what you're going to get is you're going to get a section of it cut out in the middle of it, not the entire thing. Right. Which we don't do. So that's our sketch for this, and we'll exit our sketch. And so we can see that's basically we've drawn on top of this. And so now we use a feature called extrude cut. And now you can see this was going to cut And there's a lot of different things you can use for this. So this is the blind mode right now,
Right.
and it's set for 10 millimeters. And if we were to use that, it's got to cut clear through the cartridge,
Right.
which is not good. So what I'm going to use is I'm going to say, instead of being blind, there's a lot of options here. I'm going to say offset from surface, and I'm
Okay.
going to pick this surface, which is the top,
Rich. Yeah.
and I'm going to say 2 millimeters.
That's also 2 millimeters then.
Because
again. Yeah.
we know
Yeah,
that's how
makes sense.
thick we want our
Yeah.
case to be. And then I say, okay. And
Oh, there we go. Yeah.
we are left with a
Yeah,
piece that's
totally.
extruded.
Totally.
Okay, so now knowing this, I now can shell this. And so I go select the shell again, and it's already set for 2 millimeters because SolidWorks remembers everything you did
Right.
last. And I say this, and now we have our 2 millimeter thick
magic.
wall with, yeah, it is magical. So
hey, Jim, I know
Yeah.
we've got about 15 minutes left
Yeah.
here. Here's what I propose we do. We have a 3D print slot later on.
Mhm.
Why don't we, because we're mixing in the 3D print as the target platform here anyways.
right.
Why don't we continue this and then in the afternoon we'll pick it up here as well and just continue to blend in the 3D print. How does that work for you?
That's fine. We've got what, about 20 minutes left before?
Yeah. So
Jim
we
Happel
could just, but in that way we just create a natural pause point and we'll pick it again up in the afternoon as well, because I think it'd be great if we maybe can even come to a complete.
So what are we gonna do for 20 minutes?
Yeah, of 20 minutes we're going to continue.
Okay, gotcha. Okay, yeah. So basically, if you look at the top half of the case, the wall is solid all the way across.
Right.
On
Even at that little ledge that needs to be created for the PCB to lay
Right.
on.
Now, on the bottom part of the case, if you look at the bottom half of the case, this wall is actually cut down so the PCB can pass through here.
Right. Yeah.
it's
That normally
different.
is a shorter wall.
Right. It's a shorter wall. So you have to think, how would you actually do that? And so I'll do it real quick. Basically, with SolidWorks, when you're going to sketch on something, you select the surface you want to sketch on. So for example, on that last thing we just did, we sketched on this surface here,
Right.
which is the entire thing. We've cut out this entire area.
Right.
So if you want to cut this wall down, you would sketch on top of this because this is the part. Well,
Right.
this is the easiest way to do it. You can sketch from anywhere and cut anything, any place you want to, but this is the easiest thing to do.
Okay, so you would basically do the same thing as we just did.
Yep.
Just
So
make
same
a
thing we
sketch on
just
that.
did. And then
Okay.
I'm going to do another.
I like the consistency of kind of like what we're doing here. Kind of.
So I'm drawing another sketch like this.
Way oversized again.
Yep, again. And
Would
then
do
what
the
I'm
2 millimeter trick, I guess. I'm starting to guess now because I'm following along. So I'm
sure. So
we'll
what we
hear
can,
if I learned or not.
what we can do if you want is that there's a lot of different ways to do things, like, of course. So what we can go to our smart dimension and we can click here to here.
Oh,
and
in this case, we don't even have to do the other
right.
one because
So
it just snaps to it.
yeah, we want it to snap to it. If I can get it to snap. Wow. Okay. There's our little menu. So I can do collinear.
Yeah.
And then here I can do collinear. So now it's snapped to it. So now
That's
if we wanted to change the width of this cartridge, this would
Right.
automatically adjust to it.
Yes. Makes
Now,
perfect sense.
same thing
Instead
here.
of 2 millimeter, 2.5, it would just go and change.
It'll match whatever this is. So same thing here too. If we want to cut this, we don't care as long as it's over. But if you wanted to make sure that if you changed anything someday for whatever reason, we're just going to make these collinear as well. And so what we end up really with is over top of it a sketch that looks like that. Just basically it copies the top of our bar. So now if we go back to our features, we're going to do extrude cut. And now we can do blind because we know that it's going to be blind. Let me rotate this so it's easier to see. So we can either grab this or we can go over here and say, it's 1.6 millimeters is the thickness of a circuit
Yeah,
board.
it's standard PCB, yeah, for
Yep.
those. that
And then
upgraded
now you can
PCBs
see
will
we've cut
recognize.
this down. Of course, this is the wrong side of the case to do this with, but I just did it as an example. That's how easy it is to cut down the case.
Oh,
So
that's true, yes, because the other side, that's actually, you bring a good point.
yeah,
and
so it's
those-
not on this side, it's the other side, but to give you an idea how quickly you can do it. So one thing that I always recommend people to do is that on the left-hand side here, you notice that we've got a couple different entries in here, and these are
Right.
the steps that we did. So this is the actual case that we split in half that we start with. And this is
Yes.
the extrude cut that we did for the piece down here.
Right,
And this is the shelling that we did to hollow the whole thing out here.
yeah,
And then this one is your cut down for we just did. So let's say 6 months from now, you go back to make it a modification and you're like, okay, this is called a tree. And
okay,
so I look on the tree and go, what's what? So I always recommend that you label what this actually is. You can put in you want. So I could say bottom cutout,
right,
and then the shell, which is the shell. And then this is going to be like PCB lowering or whatever you want to call it, you know. So you got a reference point later on in life. If you want to hide something, you can right click on it and then you can click the hide button and then you
Mhm.
won't see it. If you want to suppress it so it never appears in your final data, let's say you've got like 15 different revisions of height you want to test, you can make a whole bunch of these and you can simply suppress it and then it's ghosted out and
Yeah.
then we're back to where we were.
Yeah. So in
And
this case, we actually want that because this is the side that doesn't need
correct.
the lower ridge.
Okay, so then we look at, okay, we've got on the top side of the case.
So in this case though, so
Yeah.
now you've hidden it.
Yeah.
There's no need to delete it, is what you're saying.
Yeah, no, if you can delete if you want to.
Okay, but there's no functional reason other than
Right. Maybe someday you're going to find something where the circuit board's thicker and you need to actually trim maybe, you know,
yeah,
0.2 millimeters like that.
Yeah, got
It'd
it.
be a little easier to do it there than it is to have to go back and insert it in here somewhere. And so we look at our design now and we have a screw hole in here.
Yes.
And so we're like, okay, it's a peg. So we look at this particular one and the front side of it has a post that the screw actually
Yeah.
screws into,
Yeah.
but it doesn't pass through the whole case. So the screw goes down to a certain point and stops. So it doesn't actually
Right.
penetrate the case. So we need to make a circle on here and then make a post. And that's basically what we do. We simply select the face we wanted to sketch on. And then we will say sketch.
Circle.
And then we will go up here and we will grab a circle. And I always just grab a circle and just arbitrarily make a size.
Yeah.
And then you go to our smart dimension and you can click on it. And then you can say, okay, we know this is going to be 6 millimeters because that's
Okay.
what it measures out to be the one. So then where do we put this? Well,
Right.
we just so happen to know that the cartridge is fully symmetrical, which
Yeah.
means that the hole is in the middle, dead center of the cartridge. So from this direction to this direction, the peg is the middle. Well, it just so happens that we were smart enough to design this where the origin is also in the middle.
Right.
So you can see
So
another
we
reason
can just
why.
we can just center it to the middle.
So we just say we click, and we go over here to here and we say coincident. And
Awesome.
now and then we exit our sketch. And so now we've got this little circle in here. So if we extrude this by going over to our extrude, and you can see now it's already started to pop up.
Yeah.
And so we can actually drag this or what,
Yeah.
or set a dimension. So if we look at the dimension on this, we know the fact that this actually is the same height as the edge of the case because it sits flush against this, just like it sits flush against this. So the best way to do that, instead of doing blind and trying to figure this out height-wise, because remember, this is a 2 millimeter thick case,
Yeah.
and it's a 10 millimeter total height. So we
Right.
know we could say 8 millimeters, so that would be correct. But what if you were to change the thickness of your case?
So you're gonna make it collinear again.
Basically what I'm gonna do, I'm gonna say up to a surface, and I'm gonna pick the surface as being the edge of our case.
Yeah.
And I'll say, okay. So if we ever change the thickness of our case now, this post will actually change its height to match that,
Strategy.
which is great.
So let's pause here for a second. When we look at Target Platform as a 3D printer, have we decided yet on which way up it's going to be printed?
Well, that's the thing, is that you know, you know 3D printing as well. So are we better off trying to print it with the bed flat against this and then hope our curves come out okay? Or are we better off printing it this way so that the curves come out okay over here, which will be our final layer? Now, keep in mind, if we're going to put ribs in here and stuff, we're definitely going to want to print it this direction. So this is the bed here.
I think the ribs is obviously that's a nice one to have, and given that we got some time, maybe we can do that. So if this is going to be the way we print it, one of the things I've noticed with these posts, the post that you've just made in 3D printing, obviously that's where the screw is going to go in. So it's going to need to get a little hole, target hole as well.
Right. So we're going to go ahead.
If I look at the base of this, 3D printing in the way you do it here, makes it a very easy to break part. The connection between the bottom of the case and this little what do you call this, post, if you will. I've seen that if you kind of smooth that a little bit. Oh,
I put a fillet in it, you mean?
Yeah, where it kind of goes out like this.
Here, right there. Okay.
Right. Yeah.
So let's do this. We can put a fillet in here, and then, well, of course, that's a big
like
fillet.
that, exactly like that.
Yeah,
so
that's
hold on. You're gonna now you went way too fast,
Okay. So if you want to do a contour, it's called a fillet, which is just like what we did here to make our nice rounded edges here. It's called a fillet. You can also do what's called a chamfer, which is a straight line instead of being a rounded, contoured line.
Right.
So we're going to do a fillet here. If you want to do a 2 millimeter radius fillet, and then say, okay. So now you're looking at something that won't break off so easily.
Yeah, from a mechanical point of view, this is going to be a much stronger connection for a 3D printer.
For sure. So we can do our little fillet just like that.
Oh, that was super easy.
It's super easy. Then if we want to do our hole, we're going to sketch on whatever we want to be working with. So we're going to sketch on the top of this post, and we're going to say sketch. You right click and then beyond. And then, so we want a circle. And again, I just simply move a circle over here, and I will go to Smart Dimension, and we need to figure out what the hole size is. And I think the hole size for this one, this is a pass-through screw. So
I typically use M3 times 16.
Okay, so this is the receptacle side, so it has to be smaller because it has to have something for the threads to bite into. So if we did like a 2.75 or something like that,
that would probably be good.
Is the correct thing. Solidworks has the full version, which is obviously different from this. It actually has a toolbox that will give you references for screws.
Wow.
So it'll actually create everything for you, the threads, the whole 9 yards. So that's one thing about the full version that's a lot different. So we're going to go and so we're going to select this, and we're going to control click this and go back to over here to coincident. And now we have that dead center of our hole. But we don't have anything done with this. It's not cut into it yet. So we'll go select our sketch and then make a feature, which is extrude cut. And then we need to figure out how deep we want this to go, because we don't want it to go clear through the body.
Right.
But do we want it to go up to the surface of here? Or do we want to go,
maybe
3 millimeters?
Maybe even a little less.
I think so too. So let's go back to our blind. And we know that that this top here is going to be a certain size. Now, here's one thing that you can use in SolidWorks that's a godsend. Say, for example, like, oh man, I don't remember what my dimension is from here to here. I don't remember what it is. Well, if you select 2 different surfaces or 2 different lines, then you can go up to the pull down menu, and upper left hand corner here, I've got set to measure, and you can see a little cartoon pull down. It shows you. So that's the measurement, and it tells you like every dimensional measurement there is for it. Awesome. So I know that.
How did you select the 2? Via shift or control, or?
I selected that the first surface, and I do control to select the second one. And then I selected the little measuring tool here.
Got it.
And then it shows you like from every possible dimension. So we know that this is 8 millimeters is the height of this post to the bed of the surface. So, okay, so we don't want it to be 8 millimeters deep. We want it to be probably maybe 6. So let's go with 6 millimeters. Whoop, that's the wrong direction, huh? So actually,
So what is it, negative then?
yeah, well, it's actually, you can do what's called flip the side. Let me go back to
Okay.
here. I hit the escape button. So if you do like you can do this direction over here, there's a direction you can actually extrude in. So on this
Oh,
left-hand
got it.
side.
Yeah, yeah, that little icon. Okay,
yeah,
got
the
it.
icon here. So
Yeah.
we select the correct one, and now we've got a hole. Now, this is one case where it might be nice to use a draft, even with a 3D printer. So remember what a draft does, it gives you a beveled angle.
Yeah.
And so you can release something. In our case, it'd be nice to be able to actually have it a little bit wider at the top and a little bit narrower at the bottom, so that the
Okay.
screws will bite in.
Yeah.
So if we go into this extrude feature again, I'll just edit the extrude feature. There's a little icon here, and this is the drafting. I'm going to make this really large, so it's really obvious what's going on here.
Yeah.
So
Yeah.
you can see
Yeah.
we've actually narrowed this down a ton.
Yeah.
And so that's probably a lot. And you can also change the which side is being drafted. So if I say draft outward, I can go the opposite direction, so that now we're going the wrong way.
Right.
And so what I will do, we usually use between 1 and 2 degree draft. And so now when I look down this hole, we're going to see.
Yeah, you can see it goes inwards.
It's tapered inward, right?
Yeah.
And so this will be great, because as our screw gets further and further down here,
Yeah.
it'll actually start biting harder into the plastic.
Yeah. Makes perfect sense.
Yep. So literally, this is the top half of the case, minus our ribbing, and so.
So
and
I think indeed that's where we should pick it up. So from a design point of view, let's put it on pause for a second. We've got a few more minutes. So what we essentially have now is the base for a top. Obviously, what we haven't done yet is the ribboning that you spoke of. Obviously, the way that kind of these shells fit together, that they don't wobble. We need to figure out something.
We have to put lips in here.
Yeah, the lip, we need to figure something out.
Yep.
As well. We've taken care of putting in an enforcement for 3D printing, because we know that that's a weak point in many of these designs that we download from Thingiverse and wherever else.
So you got to remember, when you're doing things like this and reinforcement like this, in this particular case, it's fine. But some cases where if you have to slip something over top of this post, you got to make sure that the diameter of this and the size of this isn't so much that it intrudes upon getting that piece flat.
Right.
So it doesn't sink into it. So again, it's your design considerations all up front in the very beginning.
Right, and I like how we kind of discussed that through this as well. There's been quite a few discussion on the Discord as well. Shago came up with a good point on these black lines that you see everywhere, and he said these black lines basically are the definition of any sharp edge.
Right.
So
it's a discontinuation and a continuation of the next edge.
Right.
Yeah.
Right. So okay. So let's pause it here. We'll pick it up in the next session later this afternoon. I think it's very interesting. And let's go to
Jim Happel.
He's still connecting to audio.
Yep. I let him in the room, and he's there and muted.
To unmute himself and get his video on, and then he should be okay.
Hey guys,
Jim, we can hear you but not see you.
Yeah, let me turn on the
Chicago internet has been turned on.
Now you can see my computer, right?
Absolutely.
Okay, can you hear me okay?
Yes.
Super.
Awesome. Well, the show's been going really well. Congratulations, guys.
Oh, thanks, man. I'm glad you're part of it. I was a little bit bummed at first, and then I'm so thrilled today that you actually were able to join us.
Well, yeah, I'm the problem with Saturday morning start, right? I screwed up your schedule, so sorry about that.
No, we're good. It was all good.
So if we're ready to go, I was going to share my screen real quick, and then we'll come back to live if that's okay.
Yeah, Jim, the floor is yours.
All right. Can you see that?
Yes.
Okay, so this is what I'm going to talk about today. It's the Magic Projector module for the Commodore 64. I wanted to show you guys an image of it first, and then we'll go into demoing it, and then we can kind of talk about how it actually works and stuff like that. All right, are we back to live?
We can see your video and then we see your insert, so we can see you.
Okay, we're back to the C64.
Yes.
Correct.
Okay, so I got it hooked up here, and hopefully you can kind of see the screen. And I set this up at Vintage Computer Festival Midwest, and we had a lot of fun with it. I've got 11 videos here that we set up an interactive kind of kiosk situation where people could go up and play these videos based on the Commodore 64. So I'll show you how it works right here. Number 2 is the TV ad, I adore my 64. So I'm gonna press number 2 on the keyboard. You have to wait about 5 seconds.
$64K memory at a price that will put a computer in every home, business, and school years before anyone ever dreamed. I know my 64, my Commodore 64.
Okay, could you guys kind of hear that too?
Yeah.
So I basically loaded this up with a bunch of the old ads from the Commodore 64. And really the theme of our presentation at VCF Midwest was 40-year anniversary of the C64. So we kind of focused on some of the early TV ads. And really the whole impetus for this was this exploring a silver label C64 that Dave McMurtry put out there. So I'll play that and show you guys a few moments of this.
Commodore 64 computer was sold from August 1982 through June 1990.
It looks like it's getting a little washed out in the video feed, but it's an amazing video quality here, and it was really cool to see full screen videos on the 1702 monitor. And that was kind of my my goal for the show, was to show cool videos for the Commodore 64 on the 1702 monitor. And it was kind of fun to see these old ads again and see these videos on a 1702 CRT screen. It was just really cool to see live video again on CRTs in reality. So I'll push F1 or the back arrow. That will get us back to the menu. And that, so since VCF Midwest, I tried to add a few features, and that was one of them that I added, where you could actually break the video and go back to the main menu. And of course, as I was doing that, I got it all screwed up, and past Wednesday night, it wasn't working at all. Well, then I got it working Wednesday night, and then Thursday it broke again. So that was why we had so much problems with scheduling this. I'll show you, we have Saj's video here, but that's the prior version. And I'll show you this music video. This is Always, who does music under the name Nick Vivid. And he's pretty much kept his music in his Commodore hobby separate, but this is one crossover piece he has. So this is some old video game, right? From like a music video game where you're a music guy. Okay. Looks like the video might have been a little bit washed out, so I apologize for that. But that one's fun because it looks just like C64 video game, but it's got this modern, you know, tune to it, and the words scrolling across the bottom of the screen. So that is the demo of the project. A lot of these original TV ads for the Commodore 64, I hadn't really watched them or thought about them that much in the last, 40 years, 35 years, but they're really, really snarky and funny. So I'll play you my favorite one. This one here, number 4, this which has the Bach music as a background.
IBM calls this a personal computer and says a person can afford it, yet it's over $1,500. Happel says computing is a revolution that can't be missed, but at $1,530 you could miss it. Atari says computers are now within reach. Well, the Commodore 64 has more built-in memory than the others, and it's under $600. So, while everyone else talks about the revolution that's coming, you can experience the revolution that's here.
That's great.
Yeah, I love how they, what did they say? You know, at $1,500, you could miss it.
Yeah.
All right, well, that's the demo of the system here, and I thought I'd maybe transition to how this thing works and what I did here. And I'm no expert at all of this. It's pretty hacked together, and maybe others will have some ideas of how I could refine it even further.
Cool.
Any other questions on how I'm demoing it and how it works?
Now, I'm sure once you explain how it works, there'll be questions.
Yeah, okay. Let me go back to the PowerPoint. So instead of opening up live, I am going to, okay, we did the demo. So here's what it looks like on the inside. So here's the secret. It is a module that plugs into the Commodore 64, a smart module. It is controlled by the Commodore 64, but I got a little Raspberry Pi Zero in there. And so I'm talking to the Raspberry Pi Zero over the user port, and the Raspberry Pi Zero is really driving all the videos, of course. And then here's the back side, kind of ugly, but I put a little level shifter in there so it goes between the 5 volts and the 3.3 volts, and just talks over the transmit and receive lines on the user port. And this darn requirement to short these 2 pins together to get communication going befuddled me for quite a while. So I'm going to go back to live and I'll show you starting this up. Okay, we should be back to live.
Yeah, you're back live.
Okay, let me turn this other light on and see if that helps.
Yes.
I was washing out the screen, but I think it's better for this.
Yeah, it's good now.
So I am gonna, so I cleared the memory. I'm gonna load the program off the floppy. Yeah, it's version 7. Been working on this a while. And the thing about this, I wanted this to be just a pretty simple, basic program that controls the whole thing. And I was able to do that, make it a really simple, basic program that controls this module. You run this, and it takes a few moments to connect. I don't know if you can read that or not.
No, not really.
Connect to the module, and then it gives you this message. Is that washed out?
Yeah, it's washed out. Maybe you turn down the brightness or something on the monitor. I'm not sure.
Yeah.
Change the contrast or something. Oh, that's way better. Yeah, there you go. That's better.
All right, I should have done that for the video. Sorry about that.
That's okay.
So it's saying here, switch the front input to the front input. And that's the secret behind this. You know, the Commodore 64 is hooked up to the back input of the 1702 monitor, but I've got a cable from the Raspberry Pi going into the front inputs. So you flip the switch, and now we're looking at actually the Raspberry Pi output. There.
That's good. Yeah.
And so this menu here that you see here is actually the background screen of the Raspberry Pi. So it's a little bit of sneakery, a little bit of trickery here, but that allows all the interactions here to look like you're controlling a C64, and but the videos come onto this video feed, but you are still controlling it via the C64 sitting right in front of it.
That's pretty clever.
It was fun at the show. I had really smart people who completely understand this stuff coming up, like scratching their heads. Now, wait a minute. Tell me what you're doing here. They knew the C64 wasn't driving this video itself, and they knew there was something smart in the module. But I think this screen really kind of confused them, because I took a snapshot out of Vice for the menu. So in the beginning, when I first set this up, I had to go into a terminal program and log into the Raspberry Pi to get the serial port open. This week, I was able to incorporate that into the basic script. So the basic script actually logs in. And so I don't have to do that part of it. But I do, when I reset the Raspberry Pi, here's one of my ugly hacks. Let me show you guys if you can see it here. And now you can see the Raspberry Pi cursor.
Yeah. Yep. Yep, we can see that. Oh, you got the. Oh, I see. Yeah, you're in the terminal now.
Right, because obviously, this is the output of the Raspberry Pi. So
Sure.
When I first log in, and this is one of the ugly hacks that I'm going to try to get around here eventually, I have to do, wow, I can hardly read that. Let me play with that contrast brightness again. Let me make it much bigger. I don't know if you can read that or not.
Yeah, it says, well, it's the Raspberry Pi login. You could do sudo something, right?
Yeah. So I have to do STTY dash capital F dash dev dash TTY S0, which is a serial port. And when I first log in, this is at like a super high speed. And so I can set it to 1200 baud. So now I can use the kernel routines to talk to it without doing anything fancy on the C64 for, open an RS-232 type connection. And you can see here, if you do this, it does say the speed is 1200 baud. But when I originally would do this, it would communicate one line and then bomb out. And then I go back into the terminal and it was at a different speed. So somehow I stumbled on, if I do process kill on it, which is a totally ugly hack, on the TTY S0, it will kill the process. It will rebuild the process, but now it'll stick at 1200 baud. So I'm going to try to iron out that ugliness going forward. But right now I do have to, when I first boot up the Pi, go in here and do these commands. And then I just X that out and get the mouse pointer off the screen and ready to go. All right, any questions on that?
Yeah, I have a question. So you're using composite video output out of the RPi, huh?
Yeah, I bought a cable that takes HDMI and converts it to composite and audio input. It also has a S video output also, but composite and audio is fine for this application or for this thing here.
So this is a converter box you have, not actually the Pi doing composite directly?
Yeah, let me see if I can.
Because the Pis will actually output composite directly if you want.
Yeah, so it's it's a HDMI in and composite and audio and S video out.
Gotcha. Okay.
But you were correct. Raspberry Pi Zero will do composite out, but it will not do audio out natively. And they don't have any real provisions to do it. So there's hacks online to repurpose one of the output lines.
Yeah, I've seen PWM with the output. Yeah, exactly. Yeah.
So that would be another refinement to the project to, make it more directly controlled without having to have that special cable. Yeah.
Mm-hmm. So the sketch on the Raspberry Pi side, what are you using for software on that to do all this?
Oh, that's a good point. I can show you real quick.
Because obviously the Raspberry Pi doesn't pop up and start doing this by itself.
Right. I'm going to find the terminal program that's. So this is another thing I did is I buried the toolbar on the bottom of the screen. And it's covered by the plastic bezel of the 1702. Okay, I'm trying to get this at a brightness you guys can see it, if possible. So I have let me just pull this up.
Yeah, I'm not sure how it's done on the Raspberry Pi side. I don't have a lot of experience with those, if it's a sketch or if it's a application that you're running or how it's done.
Yeah, what I've done is I've written a bash script.
Oh, okay.
Which is just a command line to play the video, and I've called them all. I don't know if you can see this or not. mp-bach-howold.sh.
Okay.
And so it's a real, terse definition of what it is. And you can see here I used all capitals for these. And the reason for that is now I don't have to do any PETSCII to ASCII conversion in the commands over the serial port. I can just send, mp-bach-howold.sh.
Okay. So I understand there's actually no app at all. You're actually communicating with the Pi directly from serial and sending everything that you've been typing basically via serial.
You're correct. So, right. The C64 is sending it quote unquote commands. Right. It's, it's finding a little script here that has been made an executable and executing that script. And that script, we can look at one of these real quick.
So people that use Raspberry Pi in the past, this is equivalent to doing SSH into your Pi remotely.
Yeah, I think it's real equivalent to that. Yeah. Obviously, for the C64, we're going over a serial port, and there's no security. It's just
right.
There is a login at the beginning. So if I do mp-nic.sh. So you cannot see that at all. I can't see it at all.
Well, you see it. It's a little blurry anyway, but maybe you can do some screenshots and pop into the Discord or something.
Yeah.
Well, that's
So it's-
better. That's way
yeah.
better too.
It's just these commands, and you could just type this onto the command line, of course, and execute this. But now it's in this little script file. It's one line,
Right.
and then I'm use the ampersand. Is that what it's called at the end to? That was a refinement since VCF Midwest, so that it runs at a different instance. And so then I have another command to kill VLC.
Gotcha.
To actually stop the video. And that was a big problem at the show, is like people would come up and hit like 10 keys.
Oh, right.
Have this buffer of 10 videos that was going to play. And then you want to show it to somebody and you're like, I can't wait through all this.
That's pretty ingenious, that's for sure.
It was like kind of a silly little project, and it was fun. It started with, hey, I want to show Dave's video in the exhibit. And then I was like, oh, it'd be fun to show it on the 1702. And so I bought the cable, and I had a laptop hooked up, and it looked like so much fun. And then I was like, wouldn't it be fun if the C64 could control it? And it just snowballed into like, I'm going to make a module that looks like an old Commodore product that actually is controlled by the C64.
Yeah, very cool.
I barely got it done for that show, and then I fiddled with it and barely got it reworking for today's show.
Yeah, I'm glad you got to share that. That's neat. It's a neat idea that you're basically just remoting into your Pi and controlling it through the 64. And what you've done here, as far as the trickery goes, I mean, that's you. That's cool.
Yeah, thank you.
Where's
Yeah,
Master Joeri at? Joeri has to say something about this. Is he here? No, I guess not. You must have stepped out.
It was fun to share this at the show. And then I, our buddy Robin from 8-Bit Show and Tell was there. So I had a Easter egg buried in here of one of his videos. And I had an Easter egg buried in here of Taylor and Amy's show. And so when these, people came up and talked to us, it was fun to like show them some Easter egg videos and stuff too.
Right. So barring the fact that the Raspberry Pis are $1 million a piece now and hard to find, this is something that anybody can actually build if they've got one right now, where it's just a user port interface, right?
Yeah, and it's there was all kinds of trip points I had because I'm not great at any of this, and I really have not spent a lot of time on Linux or Raspberry Pi, controlling it and stuff. And it's funny because I remember some of these commands from college when I was on the VAX machine, running Unix.
Right.
So it was a learning lesson for me too, which is always cool with a project.
Yeah, I said I don't have much experience with a Raspberry Pi, so all this stuff to me was kind of strange at first. Like, what is sudo? Why do I have to keep typing sudo for everything? And what does this do? And so, yeah, it's a neat little unit, and I just really shocked that whole thing is done remotely through the 64. That's a great idea. Because you can control a super powerful little computer through that thing, and it's tiny. I mean, you fit in that cartridge case. Yeah, look at there.
Yeah, and I mean the basic program's pretty simple.
I
go to 100. I just use go-tos instead of go subs, so I could break out of it whenever I wanted to.
Sure.
And really to piss off the the professional programmers who hate go-tos.
I use go-to, so.
Yeah, I know. Once you start doing any assembly language, you're like, go-to is fine.
That's right.
I just open a channel using the regular kernel routines.
Oh, right. Yeah, 1200 baud connection. Yep.
And then the secret login on this instance is M for the username and M for the password. So I just sit here and 20 times throw an M at it just to make sure I get logged in.
Gotcha. Okay.
And I have some delay loops in there. And then I tell you to switch to the front panel, and then it jumps back. And then it's just like a big stupid list. You know, get a string. If a string equals 1, then the file string equals mpsilver.sh. If
Right.
it's 2, it's mp-adore.sh. And then
So how do you invoke the screen that pops up initially on the fake screen? You
The
displaying a
fake screen?
picture? Yeah, you display a picture through the Raspberry Pi.
Oh, I just set that as the background of the Raspberry Pi.
Oh, gotcha. Okay. Okay, that makes sense.
It's my projects are never rocket science. They're like, how can I get this done as easily as possible?
Oh, that's cool. Yeah, that's a good idea.
And then when to launch the videos, just print that FS string. And then I print it to the screen also. I print it to the number 6 and I print it to the screen also. I clear out the keyboard buffer just in case.
Mhm.
And then, yeah, and this is if you're going to exit. Oh, yeah, right out here at 2490, I go back to 30, I go back to the main loop. So all I'm doing is printing it and going back. So I probably could have just done that inline. I didn't really need a subroutine to do that, but when I was writing it, I wasn't sure how complex this was going to be.
Sure. Well, that's cool. Very simple, and but effective. That's for sure.
Yeah, and I think it would be cool to, as a future refinement, have a script on the Raspberry Pi that interrogates the directory and actually builds the menu, right?
Mhm.
And you could just throw, you know, your .mov files in that directory, and it would build that image that it's using,
Mhm.
which would be a, you know, a bigger refinement to the project too.
Sure.
And then I think on this, and then I think it would be cool to have, instead of creating all those little script files for each video, have like build a script file that looks at the next input. So you could say, you know, mp play space and then file name. And so you wouldn't have to build a script file each time. You just are providing the file name at the time you're invoking it.
Okay, so here's a suggestion I got as well. While you're doing this in your little basic program here, you could do a fake loading of video, and where it goes out to the disk drive, the real Commodore disk drive, and does like open 15,8, 15,I to initialize, where it simply just turns the drive on for a few seconds and off.
Yeah.
You could fake the fact that you've loaded the video.
Yeah, and you're right. And I would like to give some user feedback when somebody presses the key, because it does take like 5 seconds to respond, right?
Mhm.
But I'm on the Raspberry Pi side for the display. And the Raspberry Pi yet doesn't know that it's being commanded to play that video. You know, it's the 1200 baud connection and things. And but it does take a while for a VLC to spin up on a little Pi.
Sure.
But yeah, that would be fun. You could give some user feedback on the floppy drive that you're
Right.
doing something immediately.
Doing that while the VLC is loading up.
Right.
Yeah. So that'd be cool. Well, thank you for sharing this project. That's cool. I'm glad you got the chance to do this. And so
Yeah,
you got is information on how to build this if you want to build one, or how are you going to do this?
I'll probably put some information out there soon, and for the rest of the world, you know, I have no, you know, there's nothing proprietary or nothing too unique I've done here. I've just gathered bits and pieces together. So, but I don't have anything out there yet. I've just been trying to get this thing to kind of work to bring to these shows.
Oh, it's cool. Yeah, well, again, thanks for sharing. We're glad you got to squeeze you into this. That's for sure.
Awesome.
So I think it is now 12:30. We're at lunchtime until 1 o'clock, and we're going to come back with Radolfo, I believe. And so I think we're going to switch over to our Slate Radio. Bye, Jim.
See ya. Bye.
See ya. We're gonna switch over to Slay Radio and we'll take a lunch break. So be back in a half hour or so.
This is Slade Radio. This is Hannah Kaplin, and I just love this station. This is the place to be.
And we're back.
We're back. Hey, that intro is by Rodolfo, who we actually have as the next guy up for.
That is awesome.
Yeah.
And Rodolfo is going to wing it. I've been promised. And that's how we like it best.
Try. We're gonna wing it. So Rodolfo, chime yourself in, buddy.
Yeah, video and audio, Rodolfo.
Don't be afraid. Okay, I guess he's afraid.
He's got the whole family there as well. He said that might be, one of the additional bonuses.
Right, maybe he's chasing the children
get-
around the living
Exactly.
room right now. So anyway, in the interim, let's chat about the auctions, Joeri. The auctions ended.
Oh my goodness! It's I made some screen prints because I wanted to make sure that I at least had captured what was going on.
So,
Incredible.
Yeah, I looked briefly. I didn't get a chance to eat. I went and grabbed lunch, so I saw them that they all had finished, and they all went for. You know what shocked me the most? The disc notcher. I thought it would go for a lot higher than that because they typically do, but
Okay.
it was a 1-day auction, so it is what it is. So it was $35 for a disc notcher, which is a little
I
crazy.
think it's great. Well, no, even higher, $41.
Oh, it did. Oh, I thought it was
41
$35.
bucks is what it closed at. 11 bits, $41. Let's be real. These things used to be given away.
Right. Which we did. These were giveaways.
That's what you would have a promo on it, an address or something. Here, $41. $41. It's incredible. And then the keycaps, $102.50.
Wow.
That's
Hey,
crazy.
Rodolfo.
Hey, yeah, no, sorry about that. It's for some reason I joined earlier. It said the host is not allowing
All good.
for participants to
Rodolfo.
unmute. So then I just
All
left
good.
and rejoined.
Yeah, that's good.
Or
So
Yeah.
real quick, let's run down the rest of the auctions before we get started.
Mule,
Okay.
$178.50.
That's a good deal. Still in this day, that's a good deal.
I hear you, and I think it's still crazy. That is just crazy.
It is.
And then someone is really, really lucky because someone was able to snag for $37 a signed version of the
Yeah.
ship cartridge.
So it's funny is I think I had 22 of them in total, and I have 12 left. I actually sell that for $75 on my website right now.
Well, someone has got the deal of a century.
Yeah, so that's a good deal.
That's and with signature,
Right.
no less.
Yep.
Yeah, so that's awesome. And then of course, look at this, the one of a kind Commodore 64. So unique case, the first proto keyboard that was sent.
Yep.
It's got the ICS board number 1 in it. Now, how about that for Envy? I've got number 2 here. This person is going to get number 1, $905.
Wow.
I think it's worthy. I think this person got an absolute piece of history. This is one of those that you can absolutely showcase. It's got a lot of history there. So yeah, fantastic. Great job.
So Rodolfo, you got
Great job.
crickets going on in the background there, or what? What's the deal?
Yeah, I was gonna ask you you guys hear those crickets back there? Yeah, the garage has a couple. They migrated in here.
That is amazing.
My jokes aren't bad. They're just that's awesome. But yeah, it's
Rodolfo,
not
that's awesome, man. These things are loud. Are they? What do they sleep at night, or do they keep you up all night long?
Well, you can't really hear it in the house. It's just when you're out here is when they're noticeable. But there's been one that actually was a couple weeks ago, made it inside, and yeah, I had to hunt it down because if I didn't hunt it down, it'd probably wake up the baby or something.
I
Right.
think even the crickets are Commodore fans.
Yep. Oh yeah, they want to
Yeah.
hang out for sure.
Yeah.
That's it.
So Rodolfo, you're going to talk to us about what today?
Yeah, I was gonna say name here, Rodolfo, just kind of been an Amiga fan / or I guess it's been a love-hate relationship over the years, but I think recently it's kind of entered the old bloodstream recently just to get the Amiga back up and running. I think the more I thought about it, I just missed it. But yeah, I recently acquired an Amiga 2000 and I just needed a solution, so to speak, on how to kind of get it going, to get it up to speed. So there was only one solution to that, and that's what I'll kind of be doing a review over, is the PiStorm. Man, that thing, it's it's funny because not even handful of years ago, I think 2015, someone mentioned the idea, hey, let's use a Raspberry Pi for an Amiga accelerator, and only to be, I guess, I don't know, I can't say shot down, but just to be, booed and off the stage, and it ain't gonna happen. It's not reality. So here we are today. Fast forward, excuse me, that many years, and we have a PiStorm, and guess what? Powered by a Raspberry Pi.
That's amazing.
Yeah.
That's
So-
awesome. So, Rodolfo, how do you want to do this? Are you going to show something live, and
Yes.
we'll mute and we'll let you do your thing? Of course, you.
Yeah, definitely.
Okay. A few years ago, you did the bare metal Compute 64 demo.
Mhm.
I'm selling quite a few of those PCBs as a result of
Yeah.
that every time. So every time
I still need to get
run
one.
out, I curse at you.
Yeah.
But that's a fantastic product. PiStorm,
Oh yeah,
it's amazing.
it does well.
We've gotten.
So
So
yeah, for sure.
All right, we'll
Yeah.
take it away.
All right, yeah, sounds good. We'll flip this camera around so you guys don't have to see me this entire presentation, but hopefully we can get it to swap. Here we go, swap with the magic of video, maybe. Oh no, but guess what? There's that filter that's on, isn't it? And then it does everything. Oh my goodness. See, I knew this was gonna happen. It's like no background and effects. None. There we go.
Oh, gotcha. Yeah.
Yeah, it's just because for the front face camera, I just figured it would sense it. But anywho, we're just gonna have a basic setup. Apologies for just using a flat screen LCD. My 1084S, after about 15 minutes of use, started to do some funny sounds inside the monitor, and I think a little bit of magic smoke came out of it. It still
Oh.
works. Yeah, it still works amazingly, but I probably should recap because it sounded like a high voltage cap was starting to kick the bucket there. So, but yeah, we'll just kind of give you a quick rundown, kind of the inside of the Amiga 2000, which hopefully most of you are familiar with. Just kept the case off because it'll be a lot easier to kind of show the inner workings of what must happen for the Raspberry Pi. So within, as you see, there's a Raspberry Pi 3B Plus, and with this particular PiStorm board, which is in the middle there, I don't want to touch it while it's live, but sandwiched in there is the PiStorm board. And of course, I'm just kind of piggybacking off the CPU slot of the Amiga 2000. Just kind of a quick reminder. Yes, your processor in the 68K CPU slot on board does have to be removed otherwise. So, and without doing too much of a hack job, if you're trying to want to get the PiStorm and maybe the 3A Plus, which is a lot smaller than this one, you may be able to get it in there, but I don't have a 3A board to kind of test that theory out. So, but otherwise, to get it to use to a 3B Plus, there is a clearance issue with the small board and the Raspberry Pi 3B Plus. So you just get a little 40-pin little extenders. I think I bought mine's off of Amazon. Thanks to Joeri, he provided the link there, and I bought myself, I think, a pack of 5. It came, I think, for around $8 or $9 or something shipped to the door. So it came in pretty quick, and that was a solution to get the Raspberry Pi itself interfaced with the Amiga 2000. And there is many tutorials on YouTube to kind of get you started as far as getting this, I think the CPLD of the PiStorm board there updated to the latest and greatest. There is a particular version for the Amiga 2000, something about there's some wait states, or like it holds some signals a little bit longer than usual. I guess many of the Amiga 2000 boards have an issue, and you'll want to flash that CPLD instead. So hopefully it won't give you any problems or issues that you might be running into. So that's just something to just probably just go ahead and do. I mean, you can try the original, and if you're just having problems with it, just think about that you might have to flash that other one instead. But that's just to get it. And of course, like I mentioned earlier, there's just many tutorials online where you can get the PiStorm started, get your Linux installed. The first one that I tried out was Musashi cores of the PiStorm emulator, and I had a couple of days with it, just kind of set stuff the way I wanted to. And my belief was that Mr. Jim Drew actually mentioned, hey, there is a EMU 68 which we'll get to that one specifically or here shortly. But I'm just going to demonstrate that. Okay, well, yes, it's using the help of a Raspberry Pi. We'll power down just to kind of show you. Well, once everything's powered down, we're going to go ahead and power back up, and you just kind of have to wait here. And yes, the kind of a disadvantage is since the Musashi core relies on Linux, it's loading Linux as we're talking. So a rough estimate, I kind of was like timing it. Obviously, I don't have a bunch of programs or patches installed. I'm just running a bare install of a Workbench 3.1, and it takes about 30 seconds, give or take. We'll just say 30 seconds to be safe. See, screen flashes, and there you go. And we're kind of up and running. It does make use of HDF files. So if you're familiar with WinUAE and the likes of, you can use your HDFs and transfer them over. The beauty of this particular setup is that since it's connected via Wi-Fi, you're able to work with the files on your SD card through the network. So use something like WinSCP, and then that's where you can update your HDF files. It's got to get them pre-installed. And there's just so I just like to think the Musashi core offers just a little bit, couple more features for the time being. But with those features and then it having to rely on Linux, well, you do have to sacrifice just a little bit of speed. Well, I say a little bit, it's kind of a lot, but so just a couple of things, or at least to bench test. I did copy the latest sysinfo, I believe, just this morning because I just forgot. Like, oh my goodness, I didn't even copy sysinfo. So we'll run it and just to see what we can get. Yes, again, it is in black and white because I'm just using composite out. I just didn't have my 1084S because of what it did to me the other day. Well, I mean, just goes to show you, a familiar screen when you're benchmarking your Amiga and what have you. Yeah, we'll speed test it just to see what we get for speed on the Musashi core on the Raspberry Pi. So it did kind of spit out a number down there just to see where you're at versus the other Amiga platforms. So at the end of the day, yeah, you're just kind of a little bit ahead of an 040 25 megahertz. Whether you're just maybe like at an 040 40 megahertz or something, maybe in the ballpark, we'll see. Just depending how many MIPS those can hammer out. But memory wise, it does give you, it gives you a healthy 128 megs of RAM, which is, more than plenty for just depending if you're just kind of, or I just like to think myself more of a 68K classic. I've never got into the RTG stuff or like we'll say the later years of the Amiga. So it was just a basic at the time Amiga 1200 that I kind of grew up with eventually. So, but yeah, there you have it. So, a good 23.89 out of the Musashi core's speed. So, for the most part, it's like it's bearable, it's quick, it's fast. I mean, it's not like it takes a lot. Workbench, yeah, it's not all prettied up. It's not, higher resolutions and stuff, but it does load up fairly okay. I mean, it just does what it needs to do. But and back in the day, I'm always associated, or my brother used Octomid version 4 for the longest time. I know a lot of you probably use Pro Tracker and what have you, or maybe the newer Octomid Sound Studio, but it does seem to load okay. I mean, it's fast, it's quick, it's not like there's a lag or much of a delay. So we'll see. I mean, I'm not going to get too crazy on like songs or playing it. I just want to go that it loads okay, it's fast, it's quick, or what have you. So we just kind of stick with that. That was all right. Again, this was just more of a quick test setup. It's not my finalized version of the Amiga. Of course, I'm going to have Magic Workbench because I've always just used in the early days Magic Workbench, maybe Tools Daemon for little pull down menus, because I was always used to that when my brother set it up. You had your extra menus, but that'll be for another time and day. So yeah, so from the get-go, I was gonna say your other Amiga. So this, I do have the Mega chip somewhere barricaded in there, and of course, so yeah, don't be alarmed that hey, wait a minute, it's an Amiga 2000. Well, yes, but I got the Mega chip in, so I do have 2 meg was a chip RAM, and for some was it first for some games they do want that 2 meg chip. So I was lucky enough when I got this in a trade a couple of years ago that he left a mega chip, but of course he took his took everything, his accelerators. I think he had an RTG card, you know, your SCSI cards, all that stuff. But that's all right. But this is what led me to the path of, well, get a Raspberry, what is it, the PiStorm, and that was my all-in-one solution. So we'll skip on to the next core. Just kind of a quick thing. Do you have to properly shut down? Yes, it's running Linux. Well, it's not doing much else in the background. As long as it's not writing to the Amiga or anything like that, and the access light really isn't going, just turn it off, walk away. You know, even the developers mentioned where they've, you know, haven't really had a hard drive failure or SD card failure within time, or, you know, as many times as they power up and down. So, but now we're putting this next one, the EMU 68K, which is a bare metal implementation of the 68K processor. So, as you've seen earlier, it took about, I mean, you know, ballpark estimate 30 seconds from when you flip that power switch on for the Amiga to start up. Let's see how fast the EMU 68 does it. And go. 1, 2, 3, 4, 5, 6, 7, and, you know, 7, 8 seconds, somewhere around there. I'm going to be counted wrong. I think go 1, 1,000, 2, 1,000. That's fine. Well, perfect. It was quick. That's snappy. Actually, here we'll see what else we can do. So again, it is a bare install, but if you look up here, is that correct? Oh my goodness, over 800 megs plus 900 megs, whatever, of usable memory. That is amazing. So I kind of got tickled pink when I saw that. I'm like, will I ever need almost a gigabyte of RAM on the Amiga? Nope, not today. It's nice it's there, but I'm not gonna need it. So we'll do a sysinfo just to see what kind of speeds we can get out of this bad boy with the EMU 68. We'll do a speed and we'll see how fast you can do it. Come on, big money, big money. We're getting it. Oh, is that correct? No way, 887. Well, there you have it. You're pretty much burning the Amiga up with this, and I was amazed at, and not only the loading speed of when you fire up your Amiga, but that speaks loudly. That speaks loudly. And the beauty of it is the cost of this PiStorm that I got. There's a gentleman out of Poland, and he ships fast when I placed the order. And I did buy the actual extra CPU card so I could just mount the PiStorm card in there. And the last time I checked eBay, I believe they were selling for $29 for the PiStorm board itself. There is some that are listed for $80+, different versions of it, et cetera, but even this $29 version. And I was kind of baffled, or at least first I was like, something ain't right. How come the rest of them are almost $100 when this gentleman has them for $30? So of course I had to place my order. Came into my doorstep. Oh man, mine's shipped fast, but you just never know how shipping companies are lately as of, but I got mine. And the sad thing is, once I was testing all this out, I just wish I did it a lot sooner, because I could have got a lot more programs, prettied up everything, just kind of get it more readily available. And we'll check out the memory just to see what it offers. The EMU 68, you got 748 megs. And that memory bank will go next. You got an additional 112 megs. Man, oh man, this is just quick. Of course, your chip RAM from that DKB memory chip, but impressive. You know, that much megs of RAM. If we could have had that back in the day, the Pi could have done a lot better renderings, and having this speed, you could have got all that work done a lot faster anyway. So, and someday I might test it out with like Lightwave 3D. We can, or I guess can get to some maybe possible disadvantages. As with anything, it's not perfected yet. It's not, there might be things here and there that upsets the card and the software just simply doesn't work. let's say if you want to boot up one of your favorite Psygnosis games or something, maybe Shadow of the Beast 3, the problem is it actually doesn't work correctly when you're booting off of the disk drive. Let's say if you're loading up Workbench, it works. Yes, it'll bring you up to it, but for some reason, as of now, it just doesn't work 100% booting off disk. But that's fine. That's why you use WHD load or something, or the likes of, where you can just double click your file and just instantly loads like that for you. So, but you know, just for me, I just wanted to do like simple tests. You know, does Octomid 4 work? Does Deluxe Galaga? Oh, love that game. And you know, rest his soul that he passed a handful of years ago. And Deluxe Pac-Man's another great one. We'll see if this works or not. D-Paint 3, yes, there's probably D-Paint 4 and better packages, but this was the one that we had on the Amiga 600. So I just find it fun anymore to use. And I think Brilliance was the other package, and I think I got Brilliance to work on this too. So what is it, rudimentary, just because I just was messing with it just to see how much faster the fill options will be, or all that stuff. But man, it's been so many years since I've used the D-Paint, but it's been fun. You just kind of paint around, make it look pretty otherwise. Oh, I probably should have cycled further on down. I think it's probably within the first ones that'll do those effects. Fun times with D-Paint, and of course you can sit there and do all the craziness stuff with it, all the fill effects. But you know, D-Paint works, and it didn't freeze up on me. Didn't do anything of that caliber. No, we're not going to say the changes. We'll leave the file intact. But so another, or I can't say disadvantage. So this being a bare metal implementation, the EMU68, you really don't have your USB devices available for, like, let's say the mouse and keyboard, like the Musashi Core does, which is fine. It's just right property to use your Amiga mouse. Sadly, I don't have my Amiga 2000 keyboard because I left it in Nevada, or I now reside in Kansas. So I'm probably not going to see that Amiga keyboard till about March of next year when we go to visit. Sad days, just because I really want to just stick to the EMU68. The EMU68 bare metal emulator, because it's fast, it's quick, and I think it fits for what I'm wanting to do with it. So, but yeah, just other programs. Eagle Player was always a fun one. See, and this is the old install that we probably had 20 years ago. So I was happy that it can just load up without much issues and stuff. Oh, fun stuff. No, I don't have any works. That's pretty good. Fun. Will it even play my brother's old music? Sure it will. Maybe not. Nope, it doesn't do his for some reason. But then it does the other one. That's hilarious. So yeah. Again, it's in crusty black and white because our composite connection. No, that's all right. So, you know, it plays mods, and, you know, Eagle Player works a treat. Again, this is, I think, a viable solution to many of those who have, let's say, even your Amiga 500, the Amiga 1000, 2000 here. I believe there's boards for the Amiga 600, and I'm not sure how that progressed or how well it is, but I did see that they were selling boards on eBay that you can pick up and make use of that. So that'd be pretty neat. For sure, you would need that 3.8 plus board. Unfortunate thing is, right now they are selling for a premium if you can find them anywhere. And luckily enough, let's say I had our friend Chris with the K, hello out there. He was kind enough to kind of pass on the deal for the PiStorm 3B Plus, in which I kind of made use for this project. So thank you again. Really appreciate that there. So yeah, I mean, there's kind of how you have it. I just wanted, acquired the Amiga 2000, and let's be real, hundreds of dollars for the accelerator, hundreds of dollars for an RTG card if I want to go that route. With this particular setup and the way I was on the Amiga back in the 90s, I just never jumped into RTG, so I'm probably just gonna, roll with the. There's a card that makes use of a Pi Zero, and you can use the RGB coming out of the Amiga and then output it to HDMI. So I may do that card in the future, but there's that option so that you can use the HDMI connection and you have color and all of its glory, more or less. So yeah, pretty neat stuff what all the Raspberry Pis can do, and it's just amazing. Again, if you're considering it, you're curious, please pick one up. It's just that amazing. There's many of them getting sold on eBay, but the one I particularly bought from was a gentleman out of Poland. And again, the last time I checked, the thing was about what is it, $30, $30 US. I mean, that's just almost cheap as chips, you know.
Hey, Rodolfo.
Yeah.
I presume you'll be able to link that in
Yes.
the chat,
Yes. I will provide them afterwards. Yes.
Hey, so Rodolfo, a few quick questions, eh?
Yep.
You now basically use two different call it firmwares for the RPI that you switched between. Are both of them emulating like processor speed, or what's the material difference between
Yes. Yes. Okay.
So much faster than the other.
Okay, so EMU68 is a bare metal implementation, meaning there's no Linux in between.
Okay.
It's just when it starts up, it's there like that fast. So it's kind of like a BMC 64. Why is that so fast? Why is it so great? Well, guess what? Because it's a bare metal implementation of it. It doesn't have to rely on Linux. So that's why it's able to provide that speed that much faster.
That's the boot up time speed difference. The difference in the cores themselves, though, is that the EMU68 is actually a JIT core, if you're familiar with WinUAE.
Yeah.
So it does actual recompilation of code in real time. And whereas the Masashi code is a interpretive instruction emulation.
Right.
And in fact, the Masashi comes from MAME. So
Wow.
it's
oh, nice.
And what kind of RPI is connected to this thing?
Yeah, it's the Pi 3B plus.
So in his
plus,
case, he's lucky because on a 2000, you can put that standoff in there and everything's fine. You could not put that setup in a Amiga 500 because the case won't close. It's too tall.
Yeah.
Okay.
Yep, too tall.
So you have to use a 3A plus or the newer ones. You can also use a Pi W0 or Pi W02, the newer version of it. All those will also work.
But I presume that the speed then will be significantly lower.
No, not significantly. It's so I tried a couple different ones. I've got the setup as well. In fact, I've never gotten the first version that Rodolfo showed to actually install and work. I've been using EMU68 because I wrote Fusion for the Amiga. It was a Mac emulation, and there's some issues with JIT in general. Does not play well with things that clear the caches constantly. So I've been actually working on that. So if you're familiar with WinUAE, that's a godsend because you can actually set this whole thing up with WinUAE.
And then basically just transfer it over.
Yeah, test everything and just transfer it over. That's what I do all the time when I'm doing development work under the EMU68 setup. And it's fabulous.
This is just simply incredible. If you think about it, I remember going to the German to the Hanover Messe, where they would show all of the latest and greatest on Amiga, and you had literally $10,000 worth of equipment that you could hack into this. You would not 46 times the 64, the 68/04025. That's just. And how much have you got in this? $50 now, maybe $60, $70?
I think so. Yeah. Excluding the cost of the Raspberry Pi itself. Yeah, just about under
all these vampire
under
cards and all of that everybody's got now. I presume that's going to be eBay stuff because that's
So the vampire cards are about what 150 bits or something like that.
Yeah, I think so. 100 and actually, they do over 1,000. I thought. Yeah. No,
not of the vampire.
You think so?
Oh no, I have them all. So I
okay. I just thought like when they benchmarked it, or what is it? They benchmarked it.
No,
my friend got over. Yeah,
they're FPGA based. So they don't have the speed that you can do with the Raspberry Pi.
Okay. Then there you go. So so then that's why I was telling my friend, I vote you take that vampire out, sell it, get rid of it. Get rid of it.
Fantastic.
Yeah.
All right. Well, thanks, Rodolfo. We really appreciate you doing the review and the. I guess we have to move along. Do we have?
Has Chuck dialed in yet?
Well, if he did, I'm probably Okay, he's in. I just let him in.
All right.
Thanks, Radolfo.
All right. Well, take care. Thank you very much. Yeah.
Bet you we appreciate it.
See you, Chuck.
We appreciate the intros too.
Awesome. Nope, not a problem. We'll have more for next year. Don't worry.
Okay, sounds
Thanks.
good.
All right. See you, Chuck and Jim and Mr.
Yuri.
Yuri. Later. Later.
All right, let's see if we can get Chuck in.
Well, the crickets went away.
Wow, those are some loud crickets. And he had spoken about it previously, but it seems like he invited the whole family in now as well.
I think so.
All right, let's see if we can get Chuck, if he can get his video.
He's in. Oh, there we go. He's
Yes.
unmuted.
There he is.
And there's Chuck.
There I am.
Hey.
Hey guys.
How's it going, Chuck? Oh, I love the shirt.
I love my
Fantastic.
pet.
It's a replica.
That's good. So Chuck, welcome back, first of all, because you've done CRX before. And I guess you're going to show us an interesting collection of Commodore goodies. Is that correct?
Yeah. A couple years ago, some of you may know who John Feagans is, and if you don't, he's the guy who worked at Commodore who wrote most of what's in the ROMs inside the PET. But he also wrote a lot of other software for Commodore back in the day. And when Trammell left Commodore in '84, he left and went to Atari as well. So he was moving out of his house in Santa Cruz last year before. And he contacted me on Facebook and asked if I knew anybody or if I could contact some collectors in the area who might want some of his stuff. And so I said, me please. And then I drove down to Santa Cruz and picked it up. So I don't know.
You got a
I'm
screen
looking
share?
at the, yeah, I guess I'm not, what I'm looking at here is not what's going out on YouTube. So I'm just going to get that out of the way.
Yeah, don't do that. That's got a long delay. Yeah, just
Yeah,
And I am going to,
we'll focus you. We'll focus your screen, and we'll.
There we go. Yep.
and I will show you. This is what I came home with. Are you seeing this?
yes.
Okay. A PET 2001, which is right behind me there. And a, oh, we don't want to see that. I didn't know if my camera was overlaid there. And a 402 adding machine and a box of miscellaneous stuff. And the stuff in this box is probably the most interesting. Here we have the photos that John sent me of the different stuff. And then I drove out there and met John. That's John there behind me. And I brought this stuff home and went through the box. And there were a few interesting things in there. So let me show you one of those interesting things. I'm going to go through these sort of in the order of the most interesting items. There was a lot of things. Some of them are pretty common, so they won't be that interesting. But here's one thing that was interesting. You should be seeing my document camera now.
That's correct.
This little cartridge right here, which is not labeled or marked. It has some things written on here, 0+1, 2+3, and 4+5. The dates on there, if you can read them, say 4/30 of 1984. And that is literally weeks before John Feagans left Commodore to go over to Atari. So I thought to myself, I wonder what this is. And I plugged it in, and it looked just like a regular old Magic Desk cartridge. So I say, okay, this is just Magic Desk, but these are EEPROMs. And John Feagans is the guy who wrote Magic Desk. So I wonder if these are any different. So let me pop this in here and switch cameras. And you'll see here, we have the Commodore Magic Voice cartridge here. Took me a while to figure this out, but if we turn this cartridge on with the Magic Voice.
Welcome to the Magic Desk.
It talks. And if anybody's familiar with Magic Desk, you'll know that the original didn't talk. I got a clue by the fact that this looks different. It doesn't give Magic Desk 1, it just says the Magic Desk.
Move the joystick to move my hand.
So it turns out Commodore had a
If
whole
you
series
need
of these
help,
planned.
press the Commodore key.
You can hear that talking, right?
Yeah, absolutely.
Commodore had a whole series of these talking cartridges planned. The Magic Desk, they had one in the works called Magic House, which was going to use X10, an X10 control cartridge to control the lights and other things in your house back in those days. So this thing talks. We can do 789. Should be able to type numbers here. The keyboard.
Equal 0. Equal 0.
The numbers aren't working here for some reason.
0.
You've got the typewriter, which makes noise but doesn't really talk much. And if I had a disk drive connected, you'd
Please check that your disk drive is turned on. To escape, move the joystick. To continue, push the fire button.
So that is the talking Magic Desk. And as many of you might know, there are very few Magic Desk or Magic Voice compatible cartridges. And so this just sort of added to the total. This was never released. John was working on this at the time he left Commodore, and Commodore just shelved it and never released it.
That's awesome. Were you ever able to ask him a question about it as well? Did he have any recollection on this? Or?
Yeah, he remembered it clearly, and he was quite glad that we were able to dump these ROMs. So I dumped these ROMs, I put them up online. You can find this on Zimmer's and other places now.
Yeah.
But yeah, he was quite pleased that I was able to dump these ROMs and get the cartridge working and get it out there for people to actually use.
So did he also give you the context then about this whole home piece and all of that? Did they see it as an added as a gimmick or true like strategic path to continue to start using more voice in their products?
Well, yeah, I think that was the plan, but like I said, it got shelved. Probably didn't have anybody else to work on it when he left, and then Commodore sort of shifted directions with the Amiga around that time, right?
Right.
So that was one little mystery that turned out to be a surprise.
And he left, huh? So Chuck, this is literally weeks before he left, huh?
I believe so. I don't know exactly when he left. Trammell left, right, and then he stayed on for a little while. But it was months later before the Trammell family acquired Atari, and then invited people to come over and join Atari.
Right. Pretty awesome. Great.
So it was a bit of a mystery that didn't take too long to figure out, and it's a nice little piece of Commodore history that was never released before. So in addition to that, there were a few other odds and ends. Pull this out real quick. Sorry for the noise.
Wow.
Wow. King
Yeah.
one.
So you can see it's got his name up here in the top, and it has a nice big rejected written on it right there.
Yeah.
So this was produced in Santa Clara in October of '77, which incidentally is the same month they started doing the first production run of the PET.
Mhm.
According to John, this went under the wave solder machine. And I don't know exactly what that means. I don't know if the wave went over the top or if it just fell off the end and went underneath the machine, but it was rejected. He took it home and got it working, but it is in pretty rough shape, and it doesn't work now. I suspect probably a bad RAM chip somewhere. And because of the provenance on this one, I decided I didn't really want to try and repair it.
Yeah.
Replace any parts or anything, just because just an interesting little piece of history since it says rejected. The serial number doesn't quite match anything else. So the theory is that this was from a special production run for a school or something like that. On the back side, there's not much special. And in addition to this board, There's this one.
Oh, blank.
Populated.
Yeah, blank board.
Blank, yeah. So I thought maybe I'll build a Kim one out of that if I can find a proper riot chip. But there are people out there that collect unpopulated boards. So that was one little oddity. The Kim one itself is not particularly rare, but to see one rejected like that is pretty unusual. Here's another interesting bit. Since I'm all the way zoomed out, let me bring this up a little bit more.
You can see it.
Yeah, it's the source code to the pet.
Now, this was interesting for a few reasons. Not only is it source code for the pet, this is the source code for the
V4.
kernel.
Yeah.
No, this is basic, sorry. But this has got, if I've got the right one here, there it is. This has got John's handwritten notes in it.
Oh.
The corrections and revisions that would have been or eventually were added. One of the interesting things about this is that it has the listing date and a list of revisions. So version 1 of basic, August 1977. Version 2, August 1978. Version 3, May 1979. This is the one that came out with the 2001-N. And then version 4 in July 1979, which didn't come out until 1980.
Yeah, quite a bit later.
Yeah, the listing date on this is 2/29/1980. So that was before version 4 of basic ever was released. Didn't come out until the 8032 in May of 1980.
So Chuck, has this been OCR'd or what's the state of this?
I have all this. In fact, I have let me come in here. Let me share, switch to here. So this is my my drive here, but you can see the V4 source. This has been scanned into PDF, which is searchable.
Okay.
And there's also another one. That was the basic Commodore PET Basic 4.0. And over here we have the, so this was the basic and this is the kernel. And if I do a quick switch here, you'll see the other one. This is PET 2001 operating system. So this is the kernel. Also, the version dates are on here for each one, and the listing date for this one is October of 79, before 4.0 came out. And I believe one of these lists or shows it as being version 4.1.
Your last one you showed, I think, was 4.1 on one of the
You could say
in one of the lines.
somewhere it says 4.1 on this one or the prior one.
I think it was the previous one. It had a line that showed 4.1.
Yeah, listing date, right next to the listing date says
Yeah.
V4.1.
Yeah.
So that was the last version of version 4, but it's odd that the listing date is before anything shipped. It must have had ROMs that were made before that. So we've got two of these, one for basic and one for.
What's interesting to me is with the original PET, if you look at those dates of version 1, version 2, that, I mean, August 77 wasn't long before the machines, the first batch got shipped. So
Right.
it was pretty quick.
One of the other things that we found in the box is the 1977 annual report. Prior to this, nobody had been able to find a copy of this. And
Yeah.
this is interesting because it mentions the Commodore Office Furniture Factory in Canada that made filing cabinets. It mentions them producing the shells for the PET. We have a picture of one of the early PETs right here. And the Kim one. And this got scanned. This is up on archive.org as well.
Hey, Chuck, about that listing still, did anybody ever try and compile that back into a usable ROM?
Not that I'm aware of. I talked with Michael Style about it initially when we found it.
Yeah, what's because I was indeed thinking about Michael indeed. So is that still on his list, or did he forget about it, or?
I haven't talked to him since then. I think he's got a copy of them. I know I gave him copies of them, and he might have put them up on his website, but I don't know.
Right.
For sure.
Well, we're going to put that on his to-do list, because obviously we want to see if the actual compiled version yields any differences between what got released. Because I just wonder, given the late date of print for this version 4, whether or not there's any differences there. It shows the July 25, 1979, but the print was later. Eh? The print was significantly later.
Well, the print, what do we see? The printing date?
Yeah, it was in month 10 or something, if I remember correctly.
The year before it was released. So this is
listed date. Yeah,
10/23.
Yeah.
79, but version 4 of BASIC didn't come out until 1980.
Right. Yeah, would be interesting to see indeed.
It's another little interesting. This is not a rare or uncommon little book, but John has some handwritten notes in here. A note to his dad: if you build this circuit, we can hook my KIM video display up directly to the KIM1. So this is a schematic for connecting the current loop outputs, serial outputs on the KIM1 to a RS-232. Little surprises like that in here. He also had a lot of stuff from Atari. Here's one. This is a tape from CES Chicago in 1983 of Alan Alda announcing that he was going to be a spokesperson for Atari. I should mention that some of this other stuff you'll find here on archive.org. So if you wanted to listen to that, that's up on archive.org. Not Commodore related, but still interesting.
Very much so.
The adding machine, which is behind me here. A lot of people are familiar with the 202, but this actually isn't a 202. This is a 402. So you'll see it's a little bit different. I can't really see what my camera is seeing, so let me.
Yeah, we're seeing the adding machine.
So this is a 402 instead of a 202. I don't have a power cord for it.
Between the 202 and the 402.
I don't know. I haven't really collected these before, but there are definitely noticeable differences here, and buttons are different and so forth.
Yeah.
They use the same power cord, which is a sort of a unique thing that you can't find anymore.
Yeah. They always come without those, or most of the time. You're lucky if you have one with them, indeed.
And of course, this Commodore 64 was in the box. This Magic Voice cartridge was in the box. This is a, it's not a silver label, but it is a Rev A board. It's a 5-pin video.
Oh, yeah.
Rev A board in there.
Yeah.
The Sparkle Bug board.
Sparkle Bug board, exactly.
I
believe it has the fixes in it.
You can see it with the kernel, yeah, if the kernel is updated.
Kernel was the fix.
Yeah.
Actually, the character ROM was that and a capacitor if you were going to fix it, but it was a lot easier for us to swap the boards out.
Yeah.
Yeah.
Well, you're right, the character ROM, man. The version 2 of the character ROM would fix it.
Yep.
So in the box was a 110.
Huh.
Commodore 64 CPM cartridge.
Wow. Get up early to make that thing go.
And let me switch this here.
Oh,
yeah.
So the unique thing about this keyboard is it's never been used. It still has the plastic
Wheels on it.
overlays on the keys.
Nice.
Yep.
And the 2001, let me switch to here. Obviously, there was a 2001 in there that is in excellent condition. You guys saw that at
PCF
West recently. Some stuff from Atari. And then
All the badges.
really interesting stuff, or at least interesting to me. I don't know how much interest you guys might have in this stuff, but there's a button.
Oh wow.
So that is from the
giveaways for the different exhibitions they must have gone to.
Yeah, this is from January '78 CES. Commodore
Penthouse key.
hired a Penthouse pet to work their booth for them. And if you went over to see the Commodore pet and meet the Penthouse pet, you got one of these buttons. This is from World of Commodore 1983.
Wow.
Here's one from the 1977 National Computer Conference.
Yeah, NTC.
If you look up a picture of Chuck Peddle, you'll find one of him standing next to the wooden prototype wearing the badge just like that.
Oh, there's a few.
The second West Coast Computer Fair, not the first one. So this would have been the 78 one. Winter CES from 79. So we're getting late here. This is a 78 exhibitor badge. This is the NCC for 82. CES, what year is that? Have to look, I can't tell what year that is.
Well, it's got to be after 84.
Yeah. Here's one that wasn't even his. This one is for Sumiko Nagahama, Commodore Business Machine, Santa Clara, for a Comdex show. So really the oldest one I have, it's only 77 really, or the NCC. I didn't get the 77 CES, just the 78 Winter CES. WestCon, something called Computer Mania in Boston in August of 77. Interface West, November 77. So these, I guess he was just going to toss.
Right.
Threw them in the bag or threw them in the box. So we have all these.
What are
Here
those? Yeah, what is that?
Well, it looks like a calculator, but it is and it isn't.
Oh.
It's the auto dialer.
Where is it? It's right here.
Is that a DTMF dialer?
Yeah, and it says on the back, it says 8K resistor added, DTMF dialer, and I can only imagine that the 6.8K resistor that was added was in order to either correct the tones or get the ones that you shouldn't normally have.
That is awesome.
Yeah, you can program a phone book in here and then just use it to auto dial your frequently used, but that's an Atari thing, so we won't talk too much about that. Put these away here. Anybody have any questions? We're pretty much almost out of time.
So had he been just collecting this in in boxes and came across it while cleaning out his house, or was this already sitting kind of like?
He was. Let me switch here. So he and his wife split their time between Santa Cruz and Japan.
Okay.
And they came back from Japan that year to find the house had been broken into and a lot of stuff had been stolen.
Yikes.
And they went through his filing cabinets and destroyed, took, or otherwise ruined a bunch of photographs and old papers and stuff. And I think they were planning on moving anyway, but in any case, he's moving, they're going through stuff, trying to pack things up and clean things out. And he just decided this stuff he didn't want to bring with him.
Okay, that makes sense. Yeah. Did he keep anything?
So there's that 2001.
Yeah, there it is.
Really good shape. Big 1541, some books, you know, and so forth. So, yeah, I'm sure there's a lot of stuff he kept. Let me switch back to here and show you some stuff that really isn't related, but we're going through stuff in a workshop, and he just sort of said, "Here, take this and take this." One of them was, you know, boxes of parts. And there was some Commodore chips in there.
Yeah.
But there was also a helium neon laser that he had built this project, and he just said, "Here, take this."
Random stuff. Yeah.
Yeah.
So what's the status of John at this moment in time? Is he still with us? Is he?
I think they're living full time in Japan now. I don't know.
And are you still in contact with him at all, or?
Yeah, he's on Facebook in at least one group that I'm in.
Okay.
He'll answer questions in there every once in a while.
Okay.
There was some political buttons in there.
Oh, right. Yeah, being California, to be expected.
Right.
So, of course, you've done a fantastic job, as you always do with all of your stuff, and people that haven't kind of seen you, you take great pride in making really good documentation, taking really good pictures as well, often used in reference when we're trying to fix something or otherwise. But you kind of like the library for everything, everything pet. Is there anything that you had hoped to see in there that you know he'd been involved in that he may not even have had himself anymore?
I know there was some things that he doesn't have anymore. I think he used to have a floppy drive for his pet, but that may have gotten stolen when they broke into his house, or he just didn't have it anymore. He didn't have a VIC-20 to my knowledge. I assume he might have owned one at one point, probably got rid of it years ago.
Okay.
Yeah.
But as far as documentation or otherwise missing links or anything.
Oh yeah, there was one place I found a serial number for the pet that he used to own, the Chicklet pet, not the -N that I got from him, but he apparently used to own a Chicklet pet, and it was serial number 3.
Oh wow!
Wow.
I found that it was written in a book. Something his dad had written, noted the serial number of the pet that he had, and I don't know if he owned it or if he just had it and had to give it back when he left Commodore.
Okay.
The serial number 3 is unaccounted for.
Oh, makes sense.
Got the same little weird serial number. It's a 001003 instead of 0003.
Right.
Okay.
So serial number 1 we know just has 6 digits as well instead of 7.
Okay. So okay. Hey, how about his Atari artifacts? Because obviously you went to Atari afterwards. Did he have those at the moment in time as well and offer them up to you, or was it really what he gave you was just a combination of
in the box?
Okay.
They were just in the box. There's an Atari engineering notebook, which
Okay.
I thought, well, this is going to be interesting. There could be some really interesting things in there, right?
Right.
There was some notes from one meeting.
Yeah.
And then that's it. The rest of it's blank.
That's it.
Well, like
he
a
was
true
mostly
engineer.
He was mostly a figurehead for them, I think, in the end.
Say again?
He was mostly a figurehead for them in the end, eh?
I don't know.
Yeah, he was
I'm not
engineer.
sure how much he contributed to that.
Right.
Carl Morris, who wrote this book, I guess,
yeah,
dedicated it to John. It was in the box.
Oh, very nice.
I'm not really an Atari head. One of the stipulations when I got this from John is, I made him an offer, and And when he accepted the offer, he said, I'm going to go ahead and accept that offer because I know you'll take good care of this stuff and you're not going to just throw it up on eBay right away. So I haven't sold anything, even if it's stuff that I just don't find that interesting or collectible for myself.
Yeah.
I might eventually let go of some of this stuff, but
Yeah, at this moment in time, you're fulfilling the promise you made. If
Yep.
you will.
And you're sharing, which
yeah,
is,
sure,
which is
yeah.
great.
So
Yeah.
links are in the channel there. I haven't looked at Discord to see if there's been any
In there.
questions.
Well, Chuck, I think that printed listing, obviously, that deserves to be recompiled. That's
Let
just,
me,
back in the day, we had the magazines, and we would just be with two persons, one reading up, the other one typing, and then at the end you'd blame each other for not having it work.
Right. Yeah.
I hope we don't need to go through that anymore. But otherwise, I propose Michael and Michael, because they have the same names. Maybe them two can do it. One reads up, the other
put a
one.
link to the scans.
Oh, fantastic! Well,
so
that's awesome. That's awesome. So, Michael, you know what to do. Start working on it. Typing.
Start typing. Oh.
So,
well, you can OCR it. OCR in these old printouts can sometimes be tricky, but
maybe or not. I'll leave that to them. That to me, the strategy has been set.
In fact, one of these files is too big, and it's actually scanned in full color with. So you can take the images and process them or whatever. And this folder contains all the raw images.
Yeah.
So it's all there. Not just the PDFs, but the raw images, if you wanted to process those yourself, are in there.
Right. Very cool.
Oh yeah, I just realized I'm not showing you guys that.
That's okay. Oh.
So a question that came in here, you saw the Riot 3 in the listing there. Is there a Riot 2 in the listing as well? Or in the collection, sorry, in the collection?
There is a Riot listing in the collection.
Yeah, there was a Riot 03 there, yeah. And an 02.
Yeah, 2 and 3 are in here.
Okay.
I think, yeah, here we go. But these are already out there. There's nothing unique or unknown about these. There's the 6530-02.
Yeah.
And the 03.
Well, wait. So do those have the? Obviously, I'm interested for my reason.
Of
I'm
course,
curious.
of course. Do they have the logic in it?
Yeah, that's
Yeah.
well. Actually,
Oh.
I have this logic already down. This is what they use in the disk drive and the chem, right?
Yeah, and I found these exact printouts scanned elsewhere on the internet. So
Yeah, it might be worth checking though.
Yeah, I'll take a look. I mean,
Yeah.
I figure mine out the old school way of testing, but I'd be interested to see what those are because they made when my discovery of the Riot. Like the two different companies that made those, there was 47 versions that I've found. And
and they're all programmed with different select logic, right? High, low.
Yeah. So you've got a programmable gate array for how they work internally, and then you've got your RAM and your ROM and all that, and so they're all different from each other. And so people try to swap, a Commodore disk drive Riot into a Chem 1. It's not going to work. And just like there's a slew of Australian pinball machines that use that. Who knew, right?
Yeah.
And then also the gambling machines, like slot machine, they used it for that as well. So, but yeah, I found manufacturers, both of them. I found some documentation for each of them how it all works, and so you have to basically have the original schematic and figure out what they were trying to do, and then work backwards from that. So,
so Chuck, perhaps you can link the 02 and 03 once you have a moment in your channel as well for people to take a peek at that.
Yeah, I'd like to see it myself.
Good.
Cool. Well, thank you for sharing everything. We really appreciate it.
Yeah, Chuck, and to a broader perspective as well. Chuck, on Facebook, you're one of the most helpful people around when it comes to pet. You really become an authority on that level with always quick helping in and answering the same question for the 50 millionth time with the same patience as you did with the first one. And then documentation, just the way you're organized, we always are in awe of every video call we do. Oh, Chuck is going to pull up this page again and show us a picture of something. It's just really you know, just cool to see someone that's just that dedicated and so organized with that. It's always a pleasure.
Definitely.
Okay.
Chuck,
All right.
thanks.
Thank you. I appreciate it. Check out the Discord channel that Chuck's got in there for all the documentation and stuff. And so Yuri, I guess we're gonna chat for a bit.
We are we? Are we gonna switch? Let me pull the.
Yeah, it says
What do we got?
3D printing parts with
Okay,
Yuri.
so we're gonna pick up for SolidWorks. So meanwhile, I've had several people PM me saying that they really appreciated this section that we went through.
Huh.
So I guess we have no choice but picking up where we left.
Okay. Well, we will talk about we'll finish up this design, at least one half of the case, so we can, and then I want to talk about printing this, because you and I have been down the road to hell.
Yes, I'm back.
And back. So people that are into 3D printing now, if you've got a 3D printer in the last couple of years, you have no idea what torture it has been. Well, I got my first one, the very first Ultimaker, that was a wood kit. So was it 2010 or 11 or something like that?
There's no good memories to that. You know, certain things where you went through hell.
Yeah.
You look back at them and only the good things stick. If I look back at these old, there's really nothing good of early days 3D printing that I can recall.
Well, the only good I remember ever is getting a not a bunch, but a really good successful print. That is it. Yeah, one time.
One time.
One in a row, as we call it.
Totally. And it was completely random. It was
right. That's what I'm saying.
Because I started including weather, you know, live in California like yourself.
Sure. Oh, yeah.
Maybe it was that position of the moon.
Right. The alignment of the planets. Yeah.
Anything. Could be literally anything.
Yeah, I got to the point I go out and wax one side of my car and sacrifice a chicken, and I would hope it would come out at that point. And you know, there was no rhyme or reason. So, but if you're into 3D printing now, or you want to get into 3D printing now, it's a cakewalk, because you've had 10 plus years of time for the technology to evolve from somebody's basement to what we have now today. We can actually go out and buy a 3D printer that works right out of the box.
Right, which is just completely amazing. Absolutely completely amazing.
So on that line, when we're creating parts in CAD, we're looking to create things certain ways that the 3D printer will work best at. So we were talking originally about what side do you want to print on, for your part, if you want to have a texture. And we didn't have texture back then. Our texture was tape or whatever was on your bed back in the day. So now we've got textured surfaces you can make and some neat things like that. So let me where we left off at. Let's go and see.
SolidWorks. We were looking at a locking mechanism to make sure that they wouldn't be shifting.
Okay, right, but we have not finished the top of the case. We need to do our ribbing. That's what we were doing.
Yes,
so let me go and real quick and share this screen. Where are you? Okay. Nope, that's not the one I wanted. Cancel. Okay, we'll try this again. How about we find, there it is. Okay. My screens are swapped on here. There we go.
Yep.
Okay, so this is the way we left off at. So we decided this is the top of the case because the top side of the case has the screw coming from the back side of the case and here, and we made this so that it's actually conical with a taper. So the screw will tie it up. We had this little thing that Yuri wanted here to increase the durability of it.
3D prints. Yeah.
Right. So we're kind of at the point now we need to figure out where we want to do like some ribbing. So what we would do, we're going to draw on top of the surface of it. This is one neat thing about SolidWorks. It's got this great feature called a wrap. And so it's a projection of your lines. So for ribbing, we want to have like a recessed rib. And then you have like ones that are raised, but they're not really raised. So basically they're the same height as the regular surface.
Yeah.
You just have a cut in it. So what I do for things like this, I literally just like throwing down a rectangle of any size, and then that way you can go back and you can make it out however big you want.
Yeah.
So let's say we want to do a rib width of what? Maybe 2 millimeters. So it's like
Take a look
that.
at it.
Okay.
Yeah,
And
2
then
millimeters. 2 millimeters is plenty.
okay, so how this works, it's a projection, which is a wrap, is how they call it. So what we're going to do in SolidWorks is we're going to say we want this line, this rectangle, to wrap around the case. So we
Right.
want to be able to cut the side of this. We want to be able to cut this.
Yeah, on the rounding.
The rounded part all the way across here, rounded part in here.
Yeah.
And so to do that, we literally are just going to position this wherever we want to. So if we want to make this like an exact science, because this will move anywhere you want here.
Right.
But we can do like let's say, well, first of all, we want to make sure this extends past the cartridge on our wrap, because if we don't wrap it far enough, it'll be like right here.
It will stop there. Yeah.
Yeah. So this is the only thing that's difficult to do with a half of a case. It's a lot easier to do with a whole entire case before you cut it. Because the whole case, you could actually wrap clear around the entire unit.
So let's pause there for a second then.
Okay.
That really comes back to what you said previously, is you may want to actually do the cutting of the case at the very, very end. First, do the complete exterior design, if you will.
Mm-hmm.
And
now the situation there is, if you're going to have something like a recessed layer in here,
right,
can you cut the case all the way around and still get that? So you have to think about that ahead of time too.
Mm-hmm.
So the whole conceptual thing about, how are this going to be designed and what's the easiest way for you to do it? Because like I've said before, there's a million ways to skin a cat here.
Right.
So let me go back to normalized this. And let's say we want to do, we want to reference the height of this.
Okay.
To
and you want
be,
to do, let's say 17 out or 15 out or
well,
something.
let's do 8 millimeters.
Yeah.
That's what the original case is 8
Okay.
millimeters from here. So, okay. So now what we could do, we know that this
is this now 8 millimeters to the heart, or where is this 8 millimeters that you put in here now?
From the edge of the case to the
edge.
to
Okay.
the start of the rib.
Yeah, got it.
Okay. So another thing we want to do is, we know this is going to wrap around, and we know the case is 10 millimeters thick.
Yes.
So there's no way with this to say from here, this little edge here to here as collinear, because it's in space and it's going to wrap. So there's no way for SolidWorks to know that's what you want to do. So we have to make sure that this wrap is long enough.
Yeah.
And in this particular case, we can make it clear out to here. As long as it's long enough to extend it,
Okay.
that's fine.
So it can go into air.
Sure, it can go into space. But what I like to do though is that it drives me nuts not to have something in here. And let me show you a neat little trick about SolidWorks here. So I'm going to do this 10. Okay. So that's definitely going to be past it.
Yeah.
And then you can, if you want to, make things equal.
Okay.
So if you wanted to go from here to here and make it equal, it is possible to do an equal symbol.
Yeah, equal the calculation of the two parts that you're trying to wrap.
Right. So,
yeah.
But a lot of times I just do this because, it's I can see it visually, because when you show equals, it doesn't show you the dimension. It just says it's equal when you click on it.
Yeah.
Okay. So what will we do now to make another rib? There's 6 ribs on the stock one. So what we could do is we could draw another one. We could just create another thing and, go through the whole process again.
Yeah.
Or we could do this, which is neat. You simply highlight it and then Control C for a copy, and then Control V to paste. And then you can paste it in, and then at that point you could go and try to position this. And so you can say this is a good time to use those equals and such. So I can say that this, if I can click on this, and this are going to be equal, and then magically this width becomes 2 millimeters all by itself.
Okay.
So you can do that. There's a much easier way to do 6 ribs though, and it's a little bit of practice to get this to, so that you understand how this works. So I highlight this.
Yeah.
I go to linear sketch pattern.
Okay.
And I want to go in the Y direction.
Yeah.
So I'm going to set the X to be
1. You can do a repeat already.
Yeah, do 1, and I'm going to set this one to 6,
Yeah.
and it's going the wrong direction. So
So you
I'll
click that
flip
icon
it.
on the left. I
Yep.
can already see, and then
So
you can,
now we've got 6 of
let me
now we
guess,
need
you
to
can do
figure
the
out
spacing now as well.
right, but now what spacing between each one of them do we want?
Yeah.
So 2 millimeters would be too little.
So 3 by the looks of it.
So we can do 3. That might be too little.
Yeah, maybe 4.
4. So now we're getting closer to this.
yeah.
So we could do 4 or 5. I don't remember what the stock one is, but let's just say it's 5 because that's close enough anyway. So at this point, it basically has made a copy. It's called the linear sketch pattern. It's made a pattern of this. And if I just say yes, then it automatically draws all of them in for me.
Magic.
So yeah, it's a lot easier to do it this way if you can do something that's uniform like this.
Right.
And so this little button at the top here, it says normal to. This gives you the ability to, so that it's absolutely straight up and down. Otherwise, you can get like a slight tilt to it, and then you're going to get these lines that aren't straight. They're like little jaggies, you know.
Okay.
And now, one of the things that I always do that I didn't do in this yet is in SolidWorks, you can go to options, and then of course they're on the wrong page here. And you go into document properties and you can set your units to be metric and how precision you want. Do you want them to be like 10.00? So this is a 2-digit accuracy. You can do 3, 4, 5, 10, whatever you want.
Yeah.
But I also go usually into image quality. And for my computer, I just turn all these to full blast. And the reason why is that when you're done, what you see on the screen for curves is like really round. Otherwise, you're going to get like a hexagon out of this when you zoom in on it. But it really depends on the speed of your computer, of how fast your computer is.
Yeah.
Okay, so let's do this. We do a selection, and we will do an insert and feature and wrap. And this is the face we want to wrap on. This is
And
the
now you
face we wanna
basically
wrap on.
select all of the wrap items.
Yep. So
Okay.
I'm going to face this
Yeah.
and this and this.
Yeah.
And so now I'm going to be projecting this around the corners
Right.
of this. And then I say, okay. And
Holy moly.
now we've got ribbing. Oh, I forgot to actually set the depth. So the depth is set at 0.5 millimeters, which is fine. That's like a half a millimeter. So now you can see that we've made a ribbing.
Yeah.
Pretty easily too.
That's awesome.
So, and if you don't like the spacing, you can go back into your,
Can you
your
make
sketch.
it back to 4, for instance? You've got 5 now. How difficult would that be to go from the 5 that you got right now to 4?
Whoops, I'm in the wrong sketch. We go to here. We go to edit the sketch. I'm in edit. So you see a little, if you can see this, the corner here, it says 6 right there.
Yes.
There you go. So this is supposed to let you select how many there are. I actually have not tried actually doing this. Let's see. There we go.
Right.
Yeah, you can do it from here.
So
See-
if you go 4, I'm looking here, it's 4 of them normally.
Oh, okay. So the case I've got here is 1, 2, 3, 4, 5, 6. I have 6 on this
Okay,
case.
fine. Yeah, it's just anyway. I wanted to see how easy it would be to go up. and
Yeah,
down, but
so
that's
just go
super
back to your
easy
edit your
then.
sketch, and then
Yeah.
you can just select who you want.
Yeah, that's fantastic.
So the reason why there's 6 on this particular one is the fact that there's the recess in here.
Oh, the recess is there. Okay.
Yeah, so what we're
well,
gonna do here, we'll put the recess in real quick and I'll show you how it's pretty simple. So remember, we need to draw on the surface. That's the tallest one, really. I mean, we could actually draw on this surface and do the recess, which is fine, or we could draw on this one.
Right.
Actually, we'll just draw on this one so it stays the same. So remember that the way SolidWorks works is that if you were to change the depth of this, the
Yeah.
recess would follow it. So in this particular case, you would want to do it at the same depth as this is. So we'll sketch on that particular one. So we will go to make a sketch. And then we're going to do any kind of an arbitrary thing here.
Okay.
So we know that we're going to make this width 55. That's what the stock
Yeah,
one is.
55 millimeters.
Right.
Okay.
So here's one of the cases like this is offset, right? It's not in the
Right.
center here. So
Right.
one of the things about SolidWorks is that if you hold cursor over a line and float, it'll show you the center point.
Okay.
So you can see right here is the center
Yeah.
point. So if I click that and then I control click our origin,
Yeah.
you can actually do an adjustment here. You can see all this. But if you do, let's see, is it shift click as well? No, I'm gonna have to do a reference on it. What I normally do always anyway is I end up doing this regardless, just because it's a lot easier for me to understand what's going on. I simply divide it in half. And then it's a lot easier to do things like this where I can do a coincident and now it snaps to the center.
Right.
So that's my reference line. That's the construction line we talked about
Yeah,
before.
makes sense.
So again, getting this up and down, it's a lot easier if you are able to, do a center line. So you're going to figure out where your center is. And so I've done the same thing.
Again, which is a line that you'll only, it's that construction line that you spoke
Right.
previously.
So this lets you do the ability to adjust like how far you want this to be down
Right.
or up from center. So if we want to say from the top of the case to here, the center of this, we want it to be 20 or whatever.
Yeah.
And then we also need to
So
be
now we have a 55 by 20.
Well, 55 by 20 to the center. We
Yeah.
haven't set the height of this
I'm sorry,
yet.
55 by 20 off from top.
Yes. So this,
55 by 20 off from top.
so if we want to set this to be, I think it's this 12, I think it is, or 14, something like that. So actually it's more than that. Was it? Let me look at my, let me mic this. So, you know, a micrometer is a good thing to have, obviously. So this is 13.
Okay.
So now that we have this sketched out, and we can kind of see it, we could go to extrude cut. And then we don't want to go obviously that deep.
No.
We want to go basically maybe 0.5.
Mm-hmm.
Or since we're actually on the same level as the
Oh yeah, you want to have it on the same plane.
like let's flip the other direction then. So we'll do extrude cut. Whoops. There we go. We're going to flip the direction. So we don't care how tall it goes this way. And so now we've cut this out, which doesn't look great because we didn't match up the ribbing and stuff, but it gives you an idea of what we're doing. If you wanted to go a little deeper than that, you could actually go deeper if you wanted to on purpose, or change the plane which you're on or whatever. And one neat thing too about SolidWorks I like is, so let's say that you didn't want to put it on this indented plane, the cut plane. You're like, man, I meant to draw that on the other level. I meant to draw it on here instead. You can actually go to the sketch and it pops up this menu and you can select edit sketch plane. And then you can pick what plane that actually would be on.
So you can now flip it over. Yeah.
Yep. So I'm gonna select this one.
Yeah.
And of course it's going to error out because in fact, I'll move the error window over here. Because you've got a problem because of then you can go back to here. And then I can adjust this so that it goes this direction.
And then it would. Yeah.
And then at 0.5.
Yeah.
Because that's the height or the depth that we used. And now it gives you the exact same thing. So there's a million ways of doing this. So, and then also we've noticed something as well. So we didn't make a very good guess on our ribbing and where they need to go.
No,
we didn't really
not at all,
measure it.
no.
So we have this little edge right here, obviously that should be not existing. It should be cut through if we're going to do this. So if we want to add a border to this, let's say we want to make a window inside of here. We can just add a new sketch on top of that and do another extrude. So let's do it real quick. Let's say we want to edge.
Like an outline?
Yeah, we could do an outline if you wanted to.
Yeah, let's do an outline.
Okay, so this is obviously not going to look great because of this.
No, but
so there's an outline. So a neat thing about SolidWorks too, let's just draw two rectangles like this and we'll call it done. Okay. So I did two rectangles because you've got two rectangles, one's inside of the other. When you do your extrude, we'll do let's do a 1 millimeter extrude, and we'll just do this blind so we don't see what's going to happen until I click this.
Mhm.
So now it's automatically made
Yeah.
the entire thing for you.
Yeah.
If you wanted it rounded, which you probably would want to keep the aesthetics for the rest of the stuff, right?
Yeah.
There's an easy thing to do as well. And so we go into here and see this little gadget up here. It's called
Yeah.
Sketch Fillet,
Yeah.
which acts like a regular fillet like this is,
Yeah.
but for a sketch. And so if
Okay.
you click aside and click aside, and then you click on your Sketch Fillet, and set something that you can actually do, let's do a 2 millimeter. Okay, pick and pick. Where is my Sketch Fillet? There.
Yeah. there
So
you
now
go.
it shows you what it's going to look like. And so if you click the other corner, you
Yeah.
can see it's going to
Yeah,
select
so you
it,
can just do it for all 4 now, right?
all 4 corners, and let's do this one as
All
well.
8 now, yeah.
And then of course you can adjust the size of the fillets. Let's say if you wanted at 1.4 millimeters, you can see they all change. Anything that's selected, you can change. And then you say, okay. And then since you did that in the sketch and you already had the feature done, it automatically sends it off to the feature to get done as well.
Yeah. Yeah, fantastic.
So you can see there's not a whole lot involved. I think the biggest process, first of all, you have to understand this, the X, Y, and Z axis for everything, the planes. Now, for example, Joeri, so we built this from the top down view, right?
Right.
So we went from the top down.
Right.
I could have built this from, let's see,
Bottom up or
I could have built it from this profile.
Yeah.
And basically you would draw out this and you would extrude it to be long at that point, and then you'd have to go in and make this wall.
Yeah.
And so, and then any kind of corner you'd have to change. So there's a lot of different ways to do it. The easiest way for me to understand, I think for most people probably as well, is take a big solid block and whittle it down.
Right.
So if you wanted to add something to the top of this, you know, like a door or a lens or whatever, just add it on top of it. And you can build on top of build.
Carve it and then carve it out from that. Yeah.
Right. So if you want to put like a sight glass in here, let's just do real quick. We'll sketch onto this like what am I doing? Oh, I'm in a sketch. Okay. We'll here, and we'll just do this.
Sight glass so we can see the EEPROM.
Yeah, well, exactly. So we'll do a little, actually, let's build this up for whatever reason, because we want to.
Yeah.
And we're going to build it up like this. That's fine. And we're going to draft this. And so we're going to make it a pyramid.
Yep.
Okay. Or if you've got a 3D printer and you can get away with doing this, you can make it like that. In fact, let's try that just for the fun of it. Okay. And then if you wanted to cut a window into this, we're going, actually, let's do this. And since we made a circle, we can actually use our center reference here and say this is going to be vertical to that. So it makes it perfectly in line. We didn't do that with our triangle or our rectangle, by the way, but
do you typically do that step by step, or do you at the end, once you've built it up, you kind of center it all?
No, I do it step by step because I know what I'm doing. And unless there's some reason I need this float where I can actually need to position something.
Right.
And so we'll talk about that a little bit. That's a little more advanced SolidWorks, because let's say, for example, you've got a circuit board that's going to be in here. And let's say you did your KiCad project. You can import a step file of your circuit board into KiCad. From KiCad.
And so you can basically do a fit, and you can exactly position this.
Yeah. So what you can do is
creating here.
You
on
can
the
edit
right spot, so you could see the component that you want to make visible.
Yeah, you could edit the entire part together. So you do this called an assembly. So you're going to put this piece along with your bottom piece along with your circuit board into an assembly. And then you can click on like holes in the circuit board that might match your standoff here. It'll reference everything, and SolidWorks will snap everything into place for you. So if you need something that floats around, you could just do something like this. Like, say if our sight glass for whatever reason was off center,
Yeah.
and there was no reference on the board.
Yeah.
It'd be a little easier probably just to not do it initially. Otherwise, what you have to do is you have to go back and you have to remove it from the reference point.
Right.
So, which you can do, which is, it's not hard to do. So for example, like this is locked in place, but when you click on it, you can see there's a little symbol here that
Yeah.
shows vertical point.
Yeah.
If I click that and hit delete, it'll remove it. And
Right.
at that point, then I'm free to move this again.
Yeah.
And you can also notice one thing too, as I move this around, SolidWorks is smart enough to know where dead center is. You notice it snaps the
Yeah.
line for you.
Yeah, it snaps it. Yeah.
So you can let go of it and that snaps to it as well. So it's another way of doing that. So now it's only limited to, once you do that, to the vertical movement, if you want to allow that.
Got it.
Okay, so let's go in, let's do our little sight glass, peekaboo hole here. We'll do an extrude cut. And let's say we want to go through all.
Yeah.
So it's going to go through. Now you got to be careful doing this, because if you're in assembly and you say go through all, it means everything in your assembly.
Oh my
go through
goodness, it would go through the three
circuit boards, through everything.
as
Yeah.
well.
I mean,
yeah.
yeah,
Got it,
which
got it.
which
So you
may
gotta
not be a
careful.
problem for you when you print the part, but it's a problem when you go to look at for reference. Like,
Right,
wow, what's
right,
going
makes
on?
sense.
So here's our hole that we did, which we could print this part on a 3D printer
Yep.
because you can do this on a 3D printer.
Yeah.
This
no
would
problem.
never work in a real mold because you would never get this part out of the mold.
Right.
It's stuck in there.
Yeah.
So and we could add our lips. So basically, if you wanted to have an interlocking lip for the case, you would make one side recessed and the other side in not recessed.
Okay.
Basically, it's a extrusion.
Yeah.
So for example, let's see, we want to do, let's go to here. We don't need a full lip, really. You don't need to have it wrap all the way around the case unless you've got
Right.
some real critical reason to do that. I mean, this is a Commodore 64 case. It doesn't being watertight sealed or anything. So in that case, what you can do, again, you can do this, where you can like sketch like this on here and then move everything down here. But another option too is if you know the line you're going to use, SolidWorks will highlight it for you, and then you can just click it, and then it'll actually attach it directly. So it's actually stuck already collinear to this line, to this part of the chassis. And at that point, we can go do a smart dimension, and we can say this is going to be 40 millimeters wide, and we can do this. I think we can still do this. Yep, vertical. So now I've made this perfectly symmetrical to this. And so, we didn't make the lip width, which we need to do. So we need to say the lip's going to be 1 millimeter. That's fine. It's a 2 millimeter. It's half the width of it. And so we have this line, and then we want to extrude it, which means we're going to pull it out away.
Yeah.
You notice most of everything you do in here really is either a cut or an extrusion.
Yes.
And so we want to set this to be a
extrude indeed. Yeah.
a blind amount. So we want to say, okay, we want this to, how deep do you want your tang to fit into the other side of the case? So if we want to do like a 1.5 millimeter lip, we can do that. And so now we've got, and notice that SolidWorks makes this all contiguous.
Yes.
And you have that option actually in here. You can say, specify that to merge result. Otherwise, it'll show you a defined line. So if I say, don't make it merged, it'll actually show it's a separate piece.
Okay.
And the reason why you might want to do that is if you make it a separate piece, you could actually draft this like this direction or that direction on this line. Otherwise, it's going to try to draft the entire surface together. So that differentiates the surface, this one from this one.
So Jim, let's connect this up to 3D printing for a second as well. Huh?
Exactly. That's what we're talking about here.
Yeah, because you're making this one now, which means you do the inverse for the other side.
Correct. You do a notch. Yep.
Yeah, the notch indeed.
Mm-hmm.
Now, from a spacing point of view, specifically for 3D printing, how close do you space this?
Do the notch itself? So
exactly, because you could fill. You have a 2 millimeter. It's a 2 millimeter ridge that you've got.
Okay, let's do this real quick. This is the best way to show you this. Is that we're going to go and do we're going to do the assembly for it, and so we're going to add our parts in here. So we're going to say insert components, existing components, and we're going to do the we're going to do the bottom and the top, and actually, whoops, I don't want to do that. I want to do, let me try that again. Insert components, existing. Let's do the top.
I think Shago makes a good comment in the chat as well. He says, make sure when you enter a value anywhere in a dialogue, make it a habit to hit tab, so that SolidWorks then will process the number before you click.
Yeah, tab. You can hit return as well. You can double click. There's a lot of ways you can do that.
Yeah.
So here's what I did. I added the top of the case, and here's the bottom of the case.
Right.
Okay, I just throw them in free space.
Yeah.
So the first one you add is always fixed in space. And so if you go into here, you can actually make it float. So now I can move this around anywhere. And this one moves around anyway. So now we're going back to our design principles again. We don't want this actually floating in space. We want some kind of a reference, because look where this is compared to the front plane.
Right.
And look where it is compared to the top plane.
We want this to sit flat in this case.
Yeah, so what we would like to do is we want to say that the top plane, which is this one, we want to make the bottom of this case equal to this
Is it
plane.
the bottom of the case or the little ridge that we made?
Well, that's the thing we're going to talk about here.
Oh, got it.
Okay, so we want the bottom of the case to be to this. So I usually don't do that at all at first, because I would like to always see my cases so I can lift them off from each other.
Okay.
And so what I end up doing always first is I'll do your top case, and I will say the front plane and this front plane, I will make them coincident to each other.
Got it.
And then the right plane, and then the right plane of the case. So the right plane here is the world space, our floating space.
Yeah.
And then this is the actual plane for the object that we're importing. And so same thing, I'll do a right plane and a right plane, and then make it coincident. So at this point now, this will only move in this direction. I can't move it left, right at all.
Right.
So it all goes up and down in space. So I'll do the same thing for the other one. I'll open up the tree and I'll do the front plane to the front plane, and I'll make it coincident. And I will go to the right plane and the right plane and coincident. So magically now, if you take a look at these, they're aligned like this. Okay. Yeah. So usually what you would do is you got to pick one of the two cases typically to be stuck, because otherwise you can move them both around.
Right.
So in my case, since the bottom of the case really is the one that I always try to stick. Usually actually what I do, if there's a circuit board in here, I always stick the circuit board, and then I adjust the cases around it.
Kind of snaps into the circuit board.
Correct, at that point. So in this case here, what I'm going to do is I'll just right click here, and remember what it said float, you can say fixed, and now that it's fixed. So this, when you go grab it, it doesn't move around. This one you can move around. Okay, so here's a nifty thing about SolidWorks as well. So we were talking about this issue where now you've got to put this in here. You've got to have a slot in here, right?
Yeah.
Of course, we haven't even cut the face of this one out or shelled it yet, the other side yet. So as we know with a 3D printer, the problem printing it this way is you're going to have support mechanisms all the way around this.
Right.
Which is okay as long as you have enough clearance where it's not going to be a problem. So you're right, Joeri. When I'm doing resin printing, my clearance tolerance is like super tight because it can hold those tightness. Right. But in our FDM, so if we want to do a slot, let's just cut this slot in here for the fun of it. So we'll go to the other half of the case. Here's our bottom of our case, right? And so our slot we did should be here.
Yeah.
And let's just go verify that we probably put the thing on the wrong side, didn't we? No, we put it on the right side. Okay. We don't want it on this side of the case. We want it on the inside so you don't see it.
Yeah.
I just want to make sure.
Yeah.
Another one of those design consideration things too. Otherwise, you would be able to see your slot exposed into here. Okay, so let's do a real quick sketch on here. So we know that we want to, so this we can't really attach to the edge here because it would be stuck to it. We don't want that. So we know that this is going to be 1 millimeter, and this is going to be 2 millimeters.
Yeah.
With our slot Actually, no, it was the other way around. No, it's 1 millimeter. And then what is our width of this?
The round, it goes.
No, we
to-
made it 1 as well, right?
Yes. And on the other one, yes.
Yeah, so our slot's 1 and 1,
Yes.
and then our width is, we made it 40.
Yeah.
So we're gonna make this 40. I'm making everything 1-to-1 tolerance. So I
Right,
mean, there's
right,
no clearance at all. And so here, and then I need to go find my reference point here. Except I hate when I do that. I need to click on this. There. So once that's selected, I can make this vertical, and that's done. Okay, so this is our slot that we did, and now we can go do an extrude cut, and we know we made the other one 1.5 millimeters. So that is an exact copy of our slot for the other side. And if we go to our assembly, we should be able to see that we made a slot that this actually fits into.
Yeah.
And if we make this transparent, which we can do with this option, and we make this one transparent. So now, whoops, actually I hit it. That wasn't what I wanted. Transparency. Okay, so it's going to be a little hard to see probably on the monitor here. I'll pull this up. So here's our 2 slots, our slot and our extension.
Yeah.
So if we drag this, which is cool, we can just grab a hold of this and drag this down.
Right.
And we can see that they line up perfectly. And if you were to do this, which is this surface here,
yeah,
these are called mating. So that surface we want to mate to this surface.
Yeah.
And once we have options for selecting for our mates, so I'll show you. We've got this to pick a surface. So you can see it pops up this little window here. You can also right click and then click mates. It'll pop up another window as well. Okay. So if we do coincident to here, what it's going to do is it's going to join those 2 together. It's going to lock them together.
Okay.
And at that point, now they are joined together. And when I try to drag this, I can't drag it. So they're physically together. But we can look and see that our slot indeed does match our extrusion perfectly.
Yeah.
Which would be great if life worked this way.
That would be fantastic.
Right, but that's not the case. So because with a resin printer, you can get away with
much. You
can get away really almost with doing this, but I always had clearance anyway. So you have your choice at this point. So let me unlock this so that we can move this around. Let me put these back so that they're more visible. There is one thing in SolidWorks too that's handy and I'll show you in a bit. It's called interference checking. So SolidWorks has the ability, once you join things together, to go and look to see if there's anything that's touching.
Okay.
So if you've got, like, let's say for example, this extrusion was 5 millimeters wider than your slot, and you snapped it in place, it would show you that there's a problem.
Okay. Yeah.
This is great.
It'll show you in a different color or something.
Right, shows you in red, bright red. So in this case, if we checked it right now, it would show no problem at all because there's a 0 clearance, which is considered okay. You could actually set a clearance tolerance in it as well, but 0 is what I normally use just to see how close things are. So Joeri, in this case, so what do? We have one of 2 choices. Either we make the slot larger or we reduce the size of the tang that sticks down. Okay. So what do you think we should do?
I maybe make the slot a little bit larger.
Okay, so we can do that. So we'll go back to the bottom piece, and we'll go back to our slot here, and we open up in the tree. It shows you where you've done your feature. Inside of the feature is your sketch. So then you simply edit the sketch. So we're back to what we were here before, where we had a 1 millimeter offset and a 1 millimeter slot. So if we make this slot 2 millimeters, then we know that this side of it is going to be perfect.
Right.
And this will actually touch this side here.
Right.
And then the width-wise, if we made this, 41, then we're going to have clearance on both sides because when we made this particular piece here, we made it in reference to the origin. Right. So it's going to widen the whole thing uniformly on both sides. So what we probably should do is we're going to need clearance in front and clearance in back and clearance on the sides. So I would do this for a resin printer. I would go to 41 on a resin printer. I'd probably do 1 millimeter clearance. For an FDM printer, I probably do 2 or 3, maybe 3. Let's
Okay.
do for this. Well, actually, for this width, it's hard to say because every resin printer is different. I mean, every FDM printer is different. Let's just say it's 2. So that's 1 millimeter per side, because from reference to center. And so if we stayed with that theme, we're going to adjust this so that our reference from the top, we need to subtract a little bit. How much do you want to subtract for this for clearance? Like we do 0.5. By the way, notice in here, I've got what the original value was, minus 0.5.
Yeah.
And if you click on this, it'll actually adjust it for you. So 0.5. So that's not very thick wall right here. So maybe that is a little bit too much. So let's do like 0.7 as the final.
Yeah.
And then for the width here, we need to make this twice. We need to add twice whatever we did here difference. So we need to see like 0.6. And so that should give us our slot to be uniformly correct all the way around. It'll be a little bit wider because we went 1 and 1 and we went, 0.3. So let's go back and look at our assembly again. And so indeed, the slot does look a lot wider.
Yeah.
And so let's go and mate this to here. And so they're connected together. And we'll make this transparent. And we'll make this one transparent. And let's see if I can zoom in far enough. Okay, so you can really see now.
Yep.
What we've done here. We've obviously it's much wider this way.
Yeah. Yeah.
And the width wise here, we look good on both sides. There's space.
Yeah.
But what we didn't take care of is the length of the
depth.
tank.
Yeah.
The depth. But we didn't take care of that. So let's go and go back to actually. I'll put these back. Whoops. He needs to pick some point that's hollow. Okay, we'll go back to which one was that? That was the bottom one. So let's make it deeper in the slot. And we did that here on our extrude cut. So remember, this is where we actually set the depth of our thing. So if we want to go, it really doesn't matter how deep this goes, as long as it's enough to go clearance.
Right, it just needs to be more than.
So if we do it uniformly, we'll add 0.3 to that. So now it's 1.8.
Yeah.
And now we go back to the assembly. Now we can see, in fact, we do have clearance in here between the bottom of our tang and the bottom of our slot here.
Yep.
So this would all work just fine for an FDM printer. Everything's peachy. The only thing that'd be better actually than this would be if we went into our top. And I always do this with of course, this is a habit for doing stuff for injection molding. Yeah. But notice this is straight down.
Yeah.
It'd be better if this was tapered in a little bit. And
and it's interesting because on the chat we see some people kind of say, "Oh, this is how I do," and indeed that from a tolerance, a bit of a conical shape to it, so it kind of tapers.
Right. So what you could do actually, if you didn't want to change your slot at all, you could just do this simple trick. You turn on the draft. And then you can set the degrees of draft. Let's say you set it at, 10 degrees is a lot, but you can see it's angled in.
Yeah.
So that, and that's also,
so that's a real nice trick actually, because.
Yeah, so that's angled in here. The only problem with this is that if you don't have a wide enough slot at the top here, when they meet, it'll start mushing. And you won't get a full seal. So you do need to make your slot a little bit bigger just to make sure you don't have that issue.
So to that point, I think that is going to be very dependent then as well on the quality of the FDM printer that you've got.
Correct.
For some printers, this will be a huge issue. For others, that tolerance may be just enough, so it becomes a real nice tight.
Right. So I really like a 2-degree draft on things like this. It's going to give you a little bit more clearance in here, but 2 degrees is not a ton. But it's enough where 2 degrees is enough to get out of a mold.
Right. So
you're going to see there's let me normalize this here. You can use the cursor keys to rotate your thing around back and forth. And so once you've got positioned here. Now it's a lot easier to see. There's a little bit of an angle here. And so it's not a lot, but there's enough angle here. It makes it easier. So when you're putting down your plastic parts together, obviously if you got something that's beveled, it's a much easier fit than trying to do an edge to edge connection.
Yeah, very much so.
So this basically in a nutshell is how you design something, and it's not a lot of work. I think the most work always for me is the conceptual part. I mean, what's this going to look like when I'm done, and what might be the easiest way to do this? And then for the media you're going to use, are you going to use injection molding? You're going to use an FDM printer? You're going to use a resin printer? Or, what do you want it to do? Obviously, we don't want to have a sight glass in here, but
maybe, but it could be a nice for an LED, for instance. That would be
sure. I feel like
LED. I really like what you said. Hey, you could import your PCB output in this, and then you can exactly fit where a reset button comes or where.
So let me show you an example of that. So I actually imported this from my regular one, and this is the Y Modem 2 product that I've been working on forever. And you're going to see.
That's a great example with the LED and the.
Oh yeah, this has everything that we just did. Literally. Okay, so let me move this tree over a little bit. Okay, so this is the Y Modem case, and so if I hide this, I'll just hide the whole thing. There's my circuit board.
There it is. Yeah.
So this is the circuit board I did in KiCad. And I just exported this as a step file, and imported it into SolidWorks as a step file, and it became its own entity. In fact, it's called board. And then I actually made the OLED a separate unit because I want to be able to adjust the height of the OLED.
Okay, yeah, the placement of that one, because
when you make it in KiCad, it's fixed at whatever you've got there. Yeah. So if you need to move something spatially, like a display or a switch or something like that, then you're going to have to make it a separate part and import the part that way. Just like I did the screws, there are separate parts too. And so you can see the screws are. So when you are doing, let me go back and unhide the case here, show the components. Okay, make this transparent. That'll make it easier to see. If you want to align this top case to the board, what you ended up doing is you would select, like I always select the pass-throughs, the conical pieces. So like your screw hole, and then on your circuit board itself, you've got this part of it. So if you pick the case, let me see here, if I can grab grab the case, and I say edit component. So now I can edit this component, except that I have the transparency turned off. Force transparency. Okay, I guess it doesn't like this. There's some little quirks in SolidWorks. Sometimes it drives me bonkers. Like sometimes, like it was already in transparent mode, so when you go into this mode, it switches the other direction.
Right. Yeah.
But you would go to edit component, and then you can select on the board hole, and you can select on your cone, and then you can say tangent or concentric. Like, so if you say concentric, it'll automatically snap your case hole to the board hole. So everything's aligned.
Yeah.
So everything's aligned at that point. So it makes your positioning really easy. So for example, like I said before, that in the free space, I made the board itself.
The board being the non-movable part.
Correct. And then everything moves around that. And you can see the same thing here. So what I've done is, like, here's the right plane. And if you look at the board itself, actually, what is that? That is that's the case upper. Let's go look at the board. Board, right plane. And then here's our right plane here in the free space, and they're the same. So they're equal to each other. Same thing with the top and the rights. And then depending on what you want to do as far as your center line goes, a lot of times I'll just split the circuit board in half, or like I think in this case, I split the connector in half as far as the center line for the whole thing, because that's the center of the whole board.
Right.
But the ribbing, if you look at the ribbing, how that was done, I do it open.
A similar setup, eh?
Yep. And notice I spent most of the time actually like screw holes, champers, upper ribs, lower ribs.
Yeah.
And it's the same exact thing that I just did. And these are projected around the corner or
Yeah.
actually up to this point here.
Yeah.
And then because this is a design for injection molding, you have to remember that you've got to get it out of the mold. So you have to taper everything so you can get it
Everything
out,
to make it easier and
get
not,
out of the mold. So you can see that these are actually tapered so they'll pull out of the mold correctly.
Yeah.
So, and then on the inside, I mean, some of these are things a little more elaborate. You know, we've got the way the standoffs work.
Right.
You can see actually on this one, I did do a full lip all the way around.
Yeah.
For this. And let me exit back out of here to the Y modem. I think I have the other pieces of the model in here too. So let's make this non-transparent. And I think I'm hiding. Yeah. So I made a module for this that plugs into the Y modem.
Yeah.
And so I'll just show that component. And I'm not sure why it's, well, that's awfully weird why it's doing this. This must be a SolidWorks goof, actually. It normally doesn't do this. Let me try opening this module. Yeah, here's the module by itself. So this actually plugs into the Y modem. This has a speaker and audio out input, an audio output, or a video input, or a video output, depending on what you want to use it for.
Right.
So it's kind of a nifty thing. Let me actually turn this back off as well, so I can see. So this one I made slots in it, and there's actually, I'll just hide this. Actually, might be easier. So this is a speaker cone I made. So this is a surface mounted speaker, and actually this is a 3D printed part.
A horn,
It's
yeah, like a horn.
it's a horn, yeah, exactly, for amplifying the sound. So go back to the Y modem case. Oh, so that's back to normal for whatever reason. So occasionally it does that. So in this particular thing, what I did too is that simply connecting with a connector is going to be a no-go, because the thing's going to flop around.
Right.
So what I ended up doing, I designed a little snap in place circuit board. It's called the bridge, and
you just
so,
basically click that on.
Yeah, it's a PCB.
A friction fit PCB.
Yeah, and yeah, basically, and I made these so that they don't flange outward, but they are really tight tolerance.
Right.
And so they snap in place.
Right.
And so that actually holds pieces together. But this basically entails everything that we talked about. It's done the exact same way. Importing the circuit board, you fix it in place, you create the case around it, case halves, and then you import the case halves over top of your circuit board, and you can start locking your holes in place. Now, an interesting thing too, when you're doing let me move, actually, let me look at the bottom case here. This is a little more interesting anyway. So when you're designing your hole placement, you don't know where the holes go initially.
Right.
So I designed them in free space. I just put them out here in the middle of the case in place. I'll do like all 4 of them. And then I'll do the extrusion with the hole and the whole 9 yards. And I know it's got to be this tall or whatever. Maybe I don't even know it's this tall. I just designed it to some height.
Yeah.
And then I will go in that overhead view, edit component, and I will select the circuit board's hole to this hole. And it will,
then you snap them, and
it snaps right into place automatically.
Right.
And then if I look from a side profile in the main model, and so I'll make this transparent, so I can look at the height wise what my clearance needs to be to the board. So this little tank, you can see it's actually like a feathery looking, like dithered. That means that means it's touching. It's 100% touching.
Okay.
So maybe this was not quite tall enough, and so now it lets me to actually select the top side of this.
Oh, and then you
to the bottom side of this, and I can snap them together, and it automatically makes it the right height.
Yeah.
And so if that later on, because SolidWorks is super smart, if you decide that you want to extend the length of this case, you don't have to go back and fix anything, because it automatically does it. Kind of like what we saw with doing collinear selection in the sketch lines.
Right.
If you want to change something, not a big deal. You can change it. And trust me, like on this, I made this wider, taller, shorter. I constantly change this thing while I was designing it. So
I really like how with this cartridge design that we started, all of the concepts that you see here, indeed, we used.
Right. Yeah. So like the cutting of this. So how do you get this kind of like this little step like this?
Right.
We'll go take a look at the top of this.
Oh, we can look at the lens, the lens thing that we just did.
Like this here, you mean?
Yeah.
Yeah, let's go.
Yeah.
Let's open this up. Okay, so it's flat on the side because we know the OLED needs to sit flat against this. And so let's go take a look at where we did that. So if you're in the tree over here, you simply move your mouse over top of it. It'll actually highlight what's going on the board as well. So you can see like it'll do your fillets get highlighted as you move down. So if you don't know where your thing is, you can actually just simply move your thing across it.
There it was. Yeah.
A lot of times you can just click this though, it'll select it in the tree.
Oh, super.
Yeah, so like this is the chamfer for here. I called my display bezel so I know where it is.
Right.
And so here's the sketch. And you can see that the sketch is above here.
Yeah.
And so this is the actual hole. And when I did the bezel, when I did the chamfer, actually, let me change the chamfer. It gives you an idea of what we're doing here. Let's make the chamfer 0.005. So there. So the chamfer I did, now you can see it's just a little tiny edge here.
Yep.
And so if you do a large chamfer, besides this hole here, you could actually widen the whole entire hole out as a result of that. And so I kept widening it out until I got to the point where the viewable area inside of the OLED, the area that you physically see, and there's a black border inside the OLED as well. And so I, however, I liked it how it looked. So I ended up doing, it's like you can do Control Z and you can like roll back and undo your stuff. So a lot of times when you undo though, it does this little thing saying, hey, you made all these draft changes, now you got to go and fix them all. So if I roll to the end, it'll tell me which one's bad. So I still have a bad draft and I can go and, oh, it's one of these. Yeah, so it's sometimes things are so tight tolerance in here that you have to fudge with this a little bit to get this to actually work. For your drafts, but that doesn't matter for this particular project. But you can see, so it widened out with our chamfer. But the stepwise, so in the tree, you can literally grab an item or select a set of items, like go from here to here, and then I can say suppress, and every single thing is gone.
All the modifications done to basic design.
Yes. So now we can go backwards. We can suppress this one. So now you can see the holes, the full size. So now you get an idea of what's going on. So there's a recess here.
Yeah.
And so
it comes back to exactly what you said. I just build on top of that, and then I'll start cutting it away. It's almost like wood carving, if you will.
It's exactly like wood carving. So I'll suppress this one, which is the hole we did. I'll suppress the shell, and this is what we start with is this recess. So if I suppress this, you get an idea. So that's what we started with. This is what I started with. Like I said, okay, the case has to fit over a circuit board that's going to be X by Y. And I may not even know that. In fact, I didn't know that when I did this because I changed the width of the board like 5 times. So because I did everything built in reference to something else, when you change the base reference size of something, it automatically changes everything associated with it. So it makes building very easy. If I hadn't done that, I have to go back and change every single piece individually to match, which is time consuming, obviously. So do unsuppress here. So you can see in what I did here is that in my sketch, I just made 2 blocks, and you can see I did it in the air. I didn't actually, because I knew I'm never making the case this big. So I just did it in the air so that it's going to be this and this, and these are identical. This is 0.8 inches, 0.8 inches. And this is in English, not metric, by the way, which I do everything myself for English. And so I said, that's good. So I could have made the recess a different depth. I can make it a different width very easily just by changing that, and magically everything changes with it. So that's our depth. And then we noticed that like before there's no shelling. So the next step was to shell. So I unsuppress this, and then magically I've got a shell. Notice how smart SolidWorks is. It actually shells your step you did. So it does the entire thing for you. And like I said, if you adjust the depth of anything or the wall thickness of this, everything changes automatically if you build it with that in mind. So then I've got my display bezel, and then the chamfer for this display bezel, and then the switch hole for the switch over here. And then there's a fillet because I wanted to make it pretty. And then there's a light pipe hole. So because there's a light pipe in this.
Yeah.
And I think there's a slight, yeah, there is. There's actually a slight bevel in here, a conical piece in here with tapered. That way the light pipe, because this particular light pipe actually fits on the top side down.
Okay.
So it shoves
Oh, so
inward,
it nicely gets snugged
snugs in place. Yep, it goes on top of that. If it'd been the other direction, then I would have gone the other way.
Yeah.
And done it from the inside to make it easier. Cutout opening is what? Oh, what is that one? Oh, it's here. So again, like we ran into the problem with the wall. So when you shell something, it shells just the entire perimeter. So it has a wall here,
Yeah.
but I needed to cut this out for the user port connector.
Right.
So I did that. And then you can add fillets whenever you want to. I try to pretty much add fillets all the time to make things pretty as I go.
Yeah.
So that's like a fillet I added. I added
Yeah.
all the fillets for here.
Yeah, I think that fillet piece is a very interesting piece to just start adding very quickly to make whatever you make look so much more professional quickly.
Yeah, it makes it really nice.
Yeah.
And it's not nice for FDM printers though, because this takes a lot of work for the printer to do, and they're not always perfect. If you got a great FDM printer, it's great.
As a matter of fact, it's interesting with certain designs, it comes out really horrible indeed.
It does.
Yeah.
So sometimes you want to take this fillet, you might make it smaller, so
Yeah.
it's not so more pronounced, and sometimes you need to make it larger,
Yeah.
so it's less pronounced for that.
Yeah.
So here's our ribbing that I did, and here's the lower ribbing. I made them separate because it's a lot easier to work with if we want to move them around.
Right.
And light pipe recess, which I probably should have done before. And one thing you can do with SolidWorks is you can actually take something from your tree and you can drag it up to it. So like this is going to appear after.
So
the fact.
and that's actually a really nice point, because that way it kind of looks more natural, as if you would have thought of it right at the
Yes.
start. This is how you would have designed it.
Now, the only exception to that is if you're doing some kind of a like this reference and you reference it somewhere else lower, you can't drag it back up top again, because no longer is that going to be a reference after in time wise. So this is a timetable, basically. The tree is the order of things in construction. So if you reference something from before, you may not be able to move it at that point. But in
Yeah.
this case, since I created the hole first, I can move it. For example, so I got the switch hole fillet. I can move this anywhere I want to, but obviously I
Right.
can't put it above the switch hole.
Right.
Because it's
Can I ask you,
referencing the
there's
hole.
an interesting. So it's fun. There's one of the members. He's a machinist. I think he said.
Mhm.
So he's got a lot of experience with this as well. And what you get to see, and you started off with that as well. There's so many different ways to get to these things.
Oh
and
yeah, there's
very,
so many
very
ways to build
depending on
it.
your style. What I like, he made a comment which I want to get back to the tree that you just discussed and
Mhm.
moving. He said, I typically do the fillet and chamfer at the very end.
Yep,
So,
and you can
because
drag
the-
all these if you want to at the
yeah,
end.
you
and
can
do-
drag those all kind of to that's interesting. indeed.
Yes, you can drag them down because they appeared after the original in
Right.
time with a reference
Right.
to. But like this fillet here, I can move it all the way up to like here where the shell is, and I can't move it past.
Yeah,
main.
it already knows what the earliest point in time is. that
Yeah.
you can do this.
So if you've not created that part of it yet, you can't add a fillet to it.
Yeah.
So it knows that.
Yeah.
Let's see what this lip is. And of course, when you click on, any of these things, if they're not, active yet, you can still see where they came from.
Right.
So you have an
I
idea.
think this is where the
Here's my lip.
progression in
That's
the
what that was.
software- The progression in the software has made humongous steps in the past 10, 20 years as well.
Oh, yeah. Yeah, for sure. So this is reference to the cassette or cutout.
Yeah.
So this is, and it's interesting too. So I'll point out something here. When you click on this cassette cutout, there's reference to a bunch of numbers and stuff you can see here, and like a degree of draft and all these things in here. This is in reference to whatever this was referenced off of, which happens to be the circuit board.
Okay.
So like what I was showing before, you can, when you've got it all assembled together, you can say edit component, click on this, and you're going to reference parts anywhere else in the sketch.
Yeah.
And so you're not going to be referencing anything in this particular sketch or this particular part of the case, referencing somewhere else in the domain, which happens to be the circuit board in this place. Let's once press that. So the reason why you do that is that this measurements that you saw, they had to be correct for whatever the circuit board was. We have no idea in space where this has to go. I need a reference point. So I reference the circuit board itself to say, hey, I need it to be this wide. I need it to be, in this position. And so it makes it perfect at that point. Let's do an aux cutout, the same thing. So this cutout is on this side. And the, whatever this is, the post. So here's our post.
Yeah.
And the center of the post, the dead center Pete, I actually referenced to the center of each one of the holes in the circuit board. And then the screw holes can be either referenced from that or from this. And I always try to reference everything from what you're working on and not something else as much as possible. So in that case, I reference these posts to the circuit board, and everything after that, like the screw hole, is referenced to the post itself. That way, if you change something here, it makes it a lot easier. And if you were to change the circuit board, it may mess up
You
things.
can just you just move it around as a whole.
Yeah.
As a whole
Yeah, I'd
unit.
rather have, if I move this whole entire post assembly, I don't have to worry about trying to move, this
Right.
hole and the post.
Right.
So this is referenced to the post.
Yeah.
And the screw hole chamfer, the same thing. Obviously, your chamfer. So this is a trick I always do. After
The
years
chamfer
of
is
learning.
nice for the placement, so the screw will find its route.
Yes. Otherwise, who knows what's going to happen with
Yeah.
it? Yeah, just little things like this.
So the other interesting thing is, I know you use the larger SolidWorks as well for your commercial use.
Yeah.
But do you still like? I know that the commercial version, for instance, has the what do you call it? The thread option, for instance.
Yeah, the toolbox for threads for
Yeah.
tools.
Do you actually use that a lot, or is that
No. It's funny when it first came out, it's like 2007 or 2008. It had a real basic one. So as I progressed, later on when I got newer seats, I would use toolbox a little bit, and then some things like really improved, I use them, but I find that I don't even use that stuff anymore, really, because pretty much I'm not doing a functional PowerPoint presentation where I have to unscrew a screw for a video.
So they typically just these go in with self-tapping countersunks or whatever it may be.
I like it. So like for this example here, I'll show you what I did for this. Actually, let me undo all this, otherwise it's going to not show up in the. We'll ignore. I don't know why SolidWorks doesn't like that particular thing. Let's go to here. Close. Okay, so these screws I use are actually not even threaded.
Okay.
They're just straight pieces of material that go through, because I don't really care. And I have a toolbox with tools and things that you can pull. Like I don't even lock these down either. Notice I can turn this.
Yeah.
So I can spin this around and around, so I don't lock it around. Only thing it's locked to is it's locked concentric to the circuit board hole, and then it's locked to the face of the unit itself here, the inside of here. And so you'll see. So this is a recess pad I did for rubber feet.
Yeah, rubber feet. Yeah.
Yeah, so it makes it a little easier that you don't worry about gouging up things. I did it also because of this mechanism here.
Yeah.
But so the screw, you can pull this out. So besides all of this, we're mating things together where we snap the case together. We snapped like this connector to here. I didn't actually snap this all the way. So I snapped it just basically to one plane, which is why it pulls out. And when you start snapping things, they're called mates. So you're mating things together. So if you go to the very bottom of the tree, you'll see a thing called mates.
Yeah.
And if you open that up, then you see all of your mates that are connected together. And if you move your mouse over them, you can see everything that's mated.
Yeah.
Together through here. And so like your mates here, like the module. So this screw, I don't have the screw in here apparently. So this is the surface I would mate, and I would mate it to the other half of the screw, which would be the inside edge of the screw. And as soon as you say concentric to it, it snaps in place.
Yeah, it snaps
actually,
in place.
or coincidence if this case. So you actually do two of them. You would do one for concentric to the hole, and then you do one coincidence to the top of this. That way it snaps. And then if you don't, you can actually lock this so it doesn't move around if you don't want it to move. But there's interesting things you can do also with SolidWorks, like with pivot points and setting end stops and stuff. So when I did the PET model, because I did that 2001 PET, I took my original 2001s, I've got one of my 6, and I made a 100% scale model of it.
Mhm.
And I made a functional hinge for the 2 halves.
Yeah.
And I set in SolidWorks the hinge point and the max of degrees. So it won't open any further and it won't close any further. So I've got it set to exactly where, you know, it needs to be. And I can lift it up and down. I can put the kickstand in place and stuff like that. But that's about the extent of the stuff that I ever need. Like literally, I'm not doing PowerPoint presentations where you need to unscrew something.
Right.
If you want to do something like look inside, which is really handy sometimes, I will do that for diagrams and stuff. So there's the top of here is called the section view, and you
Okay.
can click on it, and then you can decide what
Oh, very
plane
nice.
what
Yeah.
plane you want to use,
Very, very nice. Yep.
and then you can drag
Top
this,
view, yeah, very nice.
and then so you can go the other direction. You can do
Yeah.
X, Y, and Z for this, which is super handy if you want to look at like tolerance. If
And
you want to know.
and again, this is in the $99 version. It's just unbelievable that you can do this stuff.
Right. So here's a good example we just did, Joeri. So here's the tolerance I left in
Yeah.
here.
Yeah.
And this is a
Oh, yeah.
one-to-one mate here. So I didn't have any tolerance. Whoops. Let me go back to that. I didn't have any tolerance on the internal. Let me go back to this view because that was a neat thing to show. Wow. There. Okay.
Yeah.
So there's no tolerance between the case halves here
No.
up, but
So
I did have
flat, it's flat, but left, right, you have. a
yeah,
little
but the lip I did.
Yeah.
Just so we got a little bit of tolerance in there because
Yeah.
you know plastic squishes and all that. And so, but it's really great for checking tolerances for like your LEDs, your switches. Like if I go a little bit further this way, I could cut the switch in half.
Yeah. Oh, and you can see the side by side.
Yeah, so you can see exactly what's going on
Yeah.
if your tolerance is here.
Yeah, it's got a like 0.5 millimeter tolerance or something.
Yeah, to make sure. And so, like I said, what you can do as well in SolidWorks is, let me exit out of this, is go into, let's pick something. Actually, let's pick the whole sketch. And we'll go into Tools and Options. Actually, no, lied. Tools, Evaluate, Interference Detection. And then you can tell it to calculate the interference. And now it's going to show you every single thing in there that has some kind of interference and the value of what that interference would be if it's set a certain level. So for example, here's a good example. Here's my circuit board.
Mhm.
And so I have it actually, well, it looks like I've got it recessed actually. Oh no, the corner. Oh, it's off. Interesting. So my circuit board's wrong or the case is wrong. One of the two. What is it? It's the circuit board. So I got the circuit board is actually the wrong fillet. So it actually is interfering with the case design. That's good to know. I didn't know that before. So you can step through every single one of your things like this is off too. So whatever this happens to be, oh, the pen, well, it doesn't make sense. I mean, it doesn't matter if they're here, but pens are off. Everything that's off, it will actually show you that there's a collision with another surface that you may not want. And you can literally just go through with your cursor up and down. You can go through every single one of them and you can select it to ignore too. So if you know like your tolerance here, I just did like I made a 0-0 tolerance here apparently, which is not good or a negative because of the draft. If I say that's okay, I don't care. I can tell it choose to ignore that. So from here on out, when I do interference check, it ignores it. But it's a really good way to determine if you've made a goof before, like I just found with my PCB. So that PCB I designed, I need to make these corners more rounded because they are going to interfere with the snapping of the plastic.
But this one will be, oh yeah, you can see it
You
there.
can see it,
Yeah,
yep.
Yeah. So it needs to be rounded in much more in order to fit.
Yep.
Yeah. That is amazing.
So
Jim, we've taken some time from the next one, which would have been you and us in any case. So
right.
I want to say, do we want to round this off? Do we want to switch?
Yeah,
what is,
let's go ahead and just, I mean, I'll leave this running in the background, but I'll switch between you and I here.
Yeah.
Basically, yeah, so now we're at the 3D printing part of this whole thing of how you would print this. And it kind of goes to this whole thing of, you know, do you print it standing up and down? Do you print it flat? Do you print it at an angle? How do you print this? And the FDM answer is radically different than the SLA or the resin printing
Right.
difference. So
let's do a bit of basic on that then. And Jim, before we do that, we had on 3 p.m. our time, I think we were supposed to switch to modern disk archiving. Are we going to move that out? What are we going to do with that?
yeah, we can get rid of it if you want.
We can okay. So
Yeah, that's
we'll
fine.
continue this. I think
We'll
there's
review.
quite
Yeah,
a
this
few
is.
people-
I think this is far more important, really.
I think so too. I actually think that if people can start making their own cartridge, or let's say a case for a piece of product that they made, or so many of these prints, PCBs that people have bought, they could start doing some of that, or
Oh,
even,
Let me tell you one thing real quick about SolidWorks Maker Edition.
Yeah.
So they have a maker community. So when you save your files, you can save them to your cloud, you can save them to your PC, and you can also share everything on the cloud.
Okay.
So it's kind of like the GitHub of CAD for SolidWorks.
Oh,
And there are, I would imagine, hundreds of thousands now.
Right.
When I got the very first week of SolidWorks when they went to the Maker Edition, just so I could look and see what was going on with it. I've not looked at anything since then because I don't
Right.
use this version, ever really.
Right.
But there is a community that everybody shares all their designs.
Okay.
So you may find a cartridge for 64 or something already there that you like, and then you can just grab it and you can go import it into your SolidWorks, make your changes, output your STL file, which is something we need to talk about too, STL files and stuff.
Yeah.
And then, so it's a really nifty part of the SolidWorks Maker is the fact that you can
that's a good
share your
point to bring
designs.
up. So 3D printing. Let's first of all, many will have a 3D printer already. Some of them don't. And some of them will say, okay, now I've seen the SolidWorks thing. I'm kind of getting enthusiastic about this. I may try this out, follow along with Jim on the YouTube. I can get there. And if I can get to that point, I get more confidence that I can make something myself. And therefore I can start looking out in the market to buy myself something. Two technologies now much more broadly available. 3D printer, like we know with the filament, and then the SLA printers. The person hasn't got anything yet. What are they going to buy? The SLA one or the 3D printer? You've got both in many different ones.
Yeah, I have many of each. I don't know. I mean, you don't have an SLA.
I don't have an SLA.
So you know
I've looked at
FDM.
an SLA. Now I've got luck. I'm lucky because I've got good friends with SLA.
Right. So let's talk about the difference between the material types. I think that really is probably going to be the deciding factor for some people. So with an FDM, which is what fused deposit material, that's an FDM stone. We use plastic. And it's funny, if you're old school weed whacker for your lawn, you have the nylon filament that comes out. It's the exact same looking thing, really, is what it is. It's just a thin strand of plastic. And if you're familiar with a hot glue gun, how those work, it's exactly what a 3D printer is. It basically it pushes in, the certain depth, and then it moves if you were a hot glue gun person, you could actually design a cartridge, a hot glue gun, if you could be perfect for it.
Yeah.
And it's the same thing how that all works. Let's talk about like environment and toxicity of things. So with a 3D printer, you really need to be in an open space because not so much anymore, but like you and I'm surprised we're not dead.
Terrible. And you would know immediately. You would know within 5 minutes of printing that you want to be up all night because your head would be exploding.
Yeah, it's so the smell and the fumes is really bad. Now it's much better than it used to be, but it's not good for you to breathe. So you should have it in an open environment.
Yeah.
So that's one thing to consider. With the resin printers, it's a whole new level of toxic waste, and not something I recommend for anybody that has severe allergies. You need to have 99% isopropyl alcohol to do the cleaning, which you might have a problem with. The smell is atrocious. The resin is better now, but the isopropyl is really strong. And so you have to have it either in a hood or in a room that you're never going to go into, or for a while air's out, window open. And that's another thing too. Resin is cured with UV light. So if you have a window open in your room and you open up your tank, which has got a UV shield on it, you could solidify your entire tank because of your window sunlight.
Oh, yeah,
so you got to remember things like that. You don't want to do that. So for me, I mean, it's kind of funny. I don't know what I want to start with now because the quality out of a resin printer is so much better
It's
than the
really good.
FDM. It's insane. It's like getting a injection molded part. In fact, when I make prototypes of things, I make them on the resin printer, and I know that the factory is going to make them exactly the same way in the mold. So that they're perfect. I did the keycaps that way as well. I mean, I've done everything for the UAV industry for years this way. And so, of course, back in the day, SLA was like $1,200 for a little piece that you could, you know, it was expensive back then to get somebody to do it. So FDM,
think
I don't
one
know.
of the
What would you think? I think FDM really, because it's a much easier, it's a little bit cheaper, I think maybe, definitely cheaper.
I think if you put to the side the history of 3D printing,
yes,
that we had to go through, it was terrible. It needed a lot of work to start. And I think people today would easily confused as an SLA printer is set up and go, which is not the case. Even from a design consideration, operating it, cleaning it, getting it all done, it definitely needs skill as well to operate that.
It does, but once you get it down to a science, then it's fine.
Then it's fine.
It's quick. But with like the FDM printers nowadays, like if you were to buy a Creality Ender or Prusa that you've got or anything else, they work right out of the box.
Yeah, they're fantastic. So so if you kind of look at that, and if you're willing, I've got 2 processors here. Those are expensive. I don't know what they are these days, $1,000, $1,500 or so. They're pretty expensive. You can do the mini, that's cheaper, especially for what you'd be making for your Commodore stuff and all. That the mini would work totally fine. They're good. I think PLA Plus and PET G are materials that are a lot easier now to work with these printers as well. More reliable results as far as toxic measures, much different from ABS and all the other horrible stuff we had in the beginning.
Right. Oh, and another thing too, in the very beginning, you know, we only had PLA.
Right.
And PLA is made of like corn, like a cornstarch material. It's like biodegradable and stuff.
Beginning.
Yeah, and it was, and you would actually throw it in water and it would ruin it, type of thing, you know.
Yeah.
So things have changed much better. But remember back in the day, with PLA being the only thing available, there was no such thing as a heated bed either.
No.
And so I would get a printer with a heated bed. So I'm looking at Amazon right now, and you could buy like
I think indeed, if you would look at something, get a heated bed, I would say get auto leveling. Don't even think of anything that isn't auto leveling anymore.
It's true. Yeah, because but you can look like on Amazon, you can buy, you know, Creality printers are as low as like $184.
That's a nice starting printer indeed.
Yeah, but like you said, Joeri, auto bed leveling is so let's explain what that does and why you need it.
Yes. Well,
so aluminum, as it heats, warps.
Yeah.
So if you have a heated bed, it's going to warp. Aluminum from the factory is warped. And usually you put a glass sheet or something on top of your heated bed anyway, or your bed in general. Everything is warped. There's no such thing as a flat piece of anything.
No.
Not even glass.
No.
You know, it's not flat. It looks good, looks flat. But when you start measuring from corner to corner and different spots, you're going to have low spots and stuff everywhere. And so the auto bed leveling, it does point analysis of it. It takes a little bit of time before each one of your prints, but it automatically adjusts your mesh so that it accounts for every little problem in your bed.
Yeah.
And
it just makes it a lot. It makes it a lot easier. I think it's a big investment. Now there's other options these days as well. JLC PCB, you ordered for thousands of dollars of everything and anything that they've been offering.
Right.
And the quality it's incredible. Huh? It's
incredible.
Yeah.
In fact, I've got. I happen to have a giant box of JLC PC. Oh, in fact, I had. Let's see, resin. Oh, here's a good example. Okay, so this was made in my resin printer, in my Saturn, Saturn.
Oh, people may recognize that. That's clearly a keyboard stand.
Yeah, this is for the 64C. Actually, this is for the ICS 64 version of it, and this is the one that JLC PCB made.
Yeah.
And it's hard to get this to focus. It is better quality than what my 50 micron resin printer does. And these are really inexpensive, and it's a great material. And nowadays, so this was when we started doing this a few months ago, maybe 6 months ago, we saw it. since then they've added like 6 different types of plastic, and you can actually get it done in sintered metal now. So if I wanted to make this in metal, I can order it in metal.
Yeah.
So if you don't mind waiting and you don't really want to get into a 3D printer and you don't mind paying, every single part and shipping and all that stuff, you can go that route. I'll tell you what, once you get into 3D printing though, it's gonna be cheaper to buy a printer.
It is, and that's the thing as well, because you'll start printing quite a bit. But if you're gonna buy one of these devices, do yourself a favor, buy a good one. Buy a good one. Buy one that everybody else has already got, and don't buy one. I'm a strong believer in that. I know there's people that are different. If you buy a printer that already needs 10 modifications before you can print, and basically you're spending the first 500 hours of your printer in printing mods for your printer, maybe you should have gotten a different printer.
Yeah, that's especially nowadays. After all we went through, of course, you got a Pressa now that that's new. I mean, new to you. It's not one of your old built ones like I have old built ones.
It's just such an incredible difference, and just the hours spent in the early days of 3D printer. But there was not much of an alternative. It was very expensive. It was very, very finicky.
Yeah.
And I lost years of my life going through it. I would definitely, if I would have known the future, I would have not gone through it again.
I would have waited.
Yeah, I would have waited as well. Yeah, I would have waited,
because you think about it, things back then were expensive too. So I got that Ultimaker kit.
Oh,
and either
very, very
2010 or 11, and it was like $1,400 for like a wood kit.
Yeah.
Now this is wood sides. It's got plastic and metal parts on the inside, but the problem with wood is that wood compresses, and so every X number of days you have to retighten, because otherwise the whole thing would just twist. So that was one more issue with stuff. And of course, it's your gantry, because it's the way that's done with the XY axis at the top. Those are actually bolted in the side of the wood, and so as your wood moves, your gantry changes. And so that's where this whole bed leveling thing was a real nightmare, because from print to print, your bed could change its level.
Yeah. But I do agree with you. Once you've got a 3D printer, and once you and especially now, and now you've had some of the basics. I've gotten some of the basic SolidWorks. You're going to start doing things yourself. Yeah, that's going to be an expensive one if you're going to send it all to JLC PCB for them to do it.
Yeah,
you might be better off putting this on your Black Friday or your Christmas list coming up.
Right, and things are so cheap now. I mean, compared to what we were. I mean, literally, I'm looking at look at Amazon. There's so many.
A lot cheaper as well. Filaments much more expensive.
So for the Ultimaker, there was a 3mm filament. First of all, not 1.75, so a lot less precision in it, and it was like $80 a roll, a spool for a small spool. And now you can get 1.75 for somewhere $9-10 for a spool.
You get Hatchbox via Amazon, brought to your house the next day in every color under the sunshine.
And the neat thing too is that since the beginning of time, they've changed the material types that you can print with. So you can print with bamboo, you can print with gold, you can print with carbon fiber, you can print with TPU, which is rubber. So all these different medias that you can print with. Now that's one thing you cannot do with a resin printer. We have carbon for strong, and we've got crystal clear and stuff, and you can put glitter in resin if you want to make it pretty, but you can't, and there is a sort of workable TPU style, but we don't have a lot of exotic materials like you can get with, I mean, literally you can print in bamboo and sand it. I mean, with an FDM printer.
How about colors on SLA? What does that look like today?
Every color in the rainbow, because you can mix colors, and so what they do, you can actually get like a clear and then or a white, and then you can actually put drops of dye.
So you do,
and you can mix your own colors. So but there's a slew of colors you can get. And anybody's out there, if you're interested in resin printing and you want to get into it, I've been through every type of resin known to mankind, and so I highly recommend Soraya Tech. It's the best resin I have found, and they make smoked, transparent, and a clear. They make different densities of clear, so it's hard or brittle or pliable. The blacks are great, but that's the best resin I've seen so far. But I've gone through, I think I got 60-liter bottles I've gone through total of
Wow.
all the different resins.
Wow.
So it's quite a bit of resin
Oh,
printing.
you
I've
were
done.
early on this game again as well, because you have various.
Yeah, because I've got a monoprice, Mini, Pro, and then I've got the Mars, and with, of course, you can't leave anything alone. So the Mars came with an original gantry piece up and down that had a single linear rail. So I went to dual linear rails. I mean, you got to modify everything, right, just to make it perfect. And
Yeah.
so
So
then,
that's the stage still, eh? So for SLA printers, I think it's very much still a stage of heavy user mods to get it to be semi-perfect.
well, no, actually the Saturn, when the Saturn came out,
So the Saturn is, you see that as kind of like
Yeah.
the generation where.
yep. So
where we're
everything
at
after
now
the
is
Saturn, the Frozon has their version of it. I mean, there's a
Yeah.
lot of different companies that have it. And so what you want is dual linear rails. It's a
Right.
must.
Right.
And then you know, if you got a tank filler, it's great. The new machines are, well, they started out with a very small resolution, small size display,
Right.
because with how resin printing works is really very slick. Basically, it's an LCD.
Right.
Underneath of it is a UV bulb.
Yeah.
Okay. And what is displayed on the LCD is a image of every single layer. So it's a, imagine it's a JPEG or a GIF picture of every single layer. And the slicer builds every single layer. And what happens is the build plate goes down into the resin and sits flush against the display. And there's a piece of plastic called an FEP that separates it, so it doesn't actually stick to the display. And then it exposes that image for X number of seconds, shuts off a light, and then raises it up, and it actually rips it free from the FEP. It goes, and you hear
Yeah.
like a little pop noise,
Yeah.
and then it pushes it back down to the next layer height, and then does the process for the next image. And it does that over and over and over and over again, and builds the entire thing backwards from what an FDM does. It does it this way instead of the other way. So that whole process is, for speed wise, it is super fast for resin, because the fact that it's doing an entire plate in one layer at a time. Where
Which is
FDM,
an important thing, eh? Which is an important thing, because whether you put one item on the plate or you build the entire plate full with
Full,
duplicates of your item,
same amount of
it will
time.
take the exam, and that's something really different in concept compared to a 3D printer.
Yeah, to the FDM. So because FDM, you got to draw each one of them out.
Yeah.
Basically, it has to do that. So that's the fundamental difference between those, as far as how the construction works on them. And so the resin quality really matters for that. So you want to have a good quality resin that will rip from the FEP, and there's all kinds of things you got to deal with. But once you tackled all that, then it's great. But still, yeah, the whole FDM, that's probably just a much better way to go for a beginner, really. I think you won't be too ingrained of how it works, because one thing on FDM, that the rule of thumb is you try to use as little supports as possible, because you got to break them off.
Yeah. Yeah.
And you
That's
can
a lot
see
of
them.
extra work, a lot of
So it's a
manual
lot of
work.
extra work, but it also, you got to be able to cut off, and you got to sand if you want to get rid of the mark or whatever you want to do. With a SLA style printer,
Right.
like these, you want to have as many supports as possible.
Right. Right.
So, because if you don't, you'll have something like this, which is a display like this. It's a front display.
Yeah.
If you don't have enough supports in here, what'll happen is that it'll end up doing this. It'll twist when it comes out, because it's ripping that thing up. Literally, there's a lot of force that has to pull up, and so you make sure that your displays, you've got a big flat plate with all your support mechanisms in here. And then another hot tip on this too is, when do you actually cure this? Because these don't come out fully cured. They come out partially cured. And so do you cure the part after you pull the support off of it, rinse it and then cure it? Or do you cure it beforehand? Well, it really depends on what you're doing. So if it's something like this, I always cure it as much as possible first, because I don't want this warping during the curing process. And so there's a lot of considerations for that. So FDM wise, I mean, let's talk about surfaces.
And let's talk about FDM. So let's make the assumption, because the vast majority of people are going to be FDM, either because they have one or they're about to obtain one. I think it's still going to be a vast majority. So let's talk a little bit about that, and let's keep the cartridge in mind, for instance,
Okay.
because we kind of know how we're going to print that. So obviously, we export out of SolidWorks.
It's an
Most
STL
likely
file.
an STL file,
Mhm.
which is the base import that we're going to have.
Right.
So we've determined, and I'll just use this case, that we're going to print it this way. We're going to print it with the hollow
Let me
part
spotlight you. There you go.
Yeah.
Okay.
this way, not this way, but we're going to print it this way. I think that's what we said we would do. And the reason for that is because we wanted to have a nice flat surface for a sticky label that we want to put on later.
Right. Now let's explain why that would not work the other way.
Sure, and I think that's an important one indeed, because the placement is actually the first thing. If you wouldn't do that, this area here would look disastrous. It would, because it is off. It's off the build plate. So you would either have how deep did we do it? 1 millimeter or 2 millimeter deep? I think it was.
Well, 0.5 millimeter. That one's a really shallow one.
0.5 millimeter.
Yeah.
You
So
can't put a support on that. You can't clean that up.
right. It'd be garbage.
Yeah, because you're basically printing in the air. That's what you're doing, and you can't print in the air because remember, it's. I really liked your example of the hot glue.
Yeah.
You're basically laying down hot glue. The hot glue wants to go down. Gravity will pull it down, so it's going to look. It's going to look terrible. You're never going to get a nice flat surface. So we're going to have to do it this way. Now, from a temperature point of view, so first of all, we're going to assume that you're going to have a bed that's a heated bed, and the reason for that is in the old days, and there's like been epic wars on this. You can have glass, and you can have glue sticks, and you can
tape,
painter's tape. Okay, if you got a printer like that, I'm sorry to say, that's a last generation printer.
Yeah, you don't need that stuff anymore at all.
That you don't need any of that. I would actually argue that if you've got a printer today, I'll get one here. You get one of these type of sheets.
Yep.
Flexible sheet. I think is it still called PEI or
yeah, PEI. Yep.
Yeah, PEI. This material can be heated up, and the way you would write your G code is you would have your printer heat the bed up first, and then do the auto leveling. Because remember what Jim said already, you're going to have all this warping going on and all. You're basically going to pre-warp everything. You're going to heat all of the component up, and then you're going to do your auto leveling. That's an important piece. These surfaces you can get in different materials as well. You can get them like really smooth, like glass, or you can have them with a little bit, in this case, like a little bit of a texture. Again, think about what you're designing, what faces up, what faces down, and that may or may not make a difference here. So, but given that we're going to print it coming out like this, it doesn't really matter that this is not that this is a textured surface. Now, I only print PLA Plus and PETG really, because especially if you talk about components like this, I think this is. Got a look here. It's probably PLA Plus, maybe PETG. Typically, heat settings on the side of the spools. I'm standardized on one brand. I don't know about you, Jim. Are you standardized mostly these days, or?
Hatchbox and a couple of other ones that do that. Yeah, I've got. I mentioned that. Yeah, but once you find one that works, it's always good to try to stick with
that. Whenever you get one that really works, buy that in bulk.
Yeah.
and so in my case, Hatchbox temperature settings are typically kind of like a range on the side. You're gonna have to play with that a little bit, and unfortunately, for every change that you make in filament, you're going to have to kind of readjust that base layer. And I think you should do yourself a favor. Always do a base layer test first. If that base layer test is not good, don't even start printing. Just don't do that. If the base layer test is good and it looks nicely squeezed and it looks consistent, you're going to be good to go. But if you're not, then forget about it. Now, supports, Jim.
Mm-hmm.
Many, few, different type. What are you slicing with? I'm
Yeah.
a Prusa slicer myself.
Yeah, so we talk slicing as well. So I use Simplify 3D. It's a
Okay.
paid package.
Yeah,
It's
paid package, very
150
famous.
bucks. I've used this for years because I've not looked at Cura or anything else since, back in the early days of Cura. So I'm sure they're probably much better, but Simplify 3D was like the best you could get, and it
Right.
generated the neatest thing. Let me pop up, where is this at? Come on, let me share my screen real quick. Okay. So this is Simplify 3D, and
Yeah.
this is a part that I imported in here. And
Oh, I
you might
recognize that one.
recognize what this part
I
is.
recognize that. That's the Batman TV.
Yeah. So this is a faceplate. So this is a case here. If you had a nice textured finish, you could print this down like this, and you're going to get a nice finish around this whole entire thing. It'll look cool.
Yeah.
If you didn't want to do this, like if you wanted to have supports for some reason, this thing, you just simply flip it upside down, and I can say, where is the place surface on the bed? So this surface. So I flipped it upside down. And so now what's going to happen is there's going to have to be support mechanisms underneath of here, because like what Joeri was saying, you can't print into thin air because you're going to get just strings
Right.
of things in here. So this process here, let's see, prepare to print. And this will actually, I don't like the way they do the mouse on this program, by the way, it's horrible. This will actually show you the supports it's going to build. See these little
The
little
zigzag
lines,
lines.
the zigzag lines. So this support is going to build for your thing to make sure that it comes out okay. So there is the ability with an FDM, because it's stringy on purpose, I mean, that's how it works, is that you can pass quickly over this, and it actually builds a little bridge as it goes over top of each one of these when you're starting to build your top layers. So if I do this, let's do this. So this is going to show me how it's going to build it. So it's going to build basically all these little layers here, and then it starts building things up as it goes. And you can see it's building a whole bunch of support mechanisms, and then it'll start at some point building the top layers, and then it'll start stringing over top of them. So literally it's like running a hot glue gun fast over a mesh, and then it will actually adhere to all those, and then the next layer squishes down, and then it finalizes itself, and that's how it works. So when you're all done with this, you would flip it upside down, and you would grab a pair of pliers, like needle nose, and you twist one end, and these pull out like little strips.
Yeah.
They're really convenient how it works. And then in the inside of here, we don't care what it looks like because it's not exposed. So like we were saying in the beginning, is that you need to figure out what do you want to look pretty and what don't you care about, because there's got to be some parts of the 3D print that are not going to look great. It's like when you flip this upside down and look at it, you're going to see that where the strings are ripped out, there's going to be, residual plastic there.
Right.
So, but this is where your surface really comes in handy for like the Batman TV. So Joeri needed something modified on this. I forgot what it was, but modified it for
Yeah, for a little mini TV,
Yeah.
mini TV that plays classic.
So for slicers, Cura is free, and it's probably just as good now. I've not literally looked at it in probably 5 or 6 years, probably.
No, I think it's got a lot. It's got a lot of features in it. Most of them which you don't use if you go with the standard ones. The heat setting, the temperature setting for your filament that you're going to use for your particular printer, that's an important one to get down. To make sure that you've got that, and then the first layer printing and adhesion. If you got those two going, let's talk about speed a little bit. So
Okay.
FDM printing is slow. And when you think slow, don't think about your grandma. Think about your grandma in a queue somewhere. It is really, really slow. You trying to optimize for speed, really, it's not going to make much of a difference. Truly, it's like even if it shaves 30 minutes of a 2.5-hour job, it is typically not worth it. If you do it slow, your prints will come up much nicer. And not only that, once you start picking them up and start pulling on them, it will actually stay intact.
Right. So layer separation if you don't have enough
Layer
heat.
separation issues that you would otherwise see is typically just because you run too fast, and surely you can try and see.
So hold that up to the camera so you can see the layer lines.
I don't think
You can see them. Oh, yeah, there you go. So this is the side profile layer lines. You can see the little layers in there. And so if you don't have proper adhesion between your layers, that will pull off like an accordion. It's gonna come apart and shred. Yeah. And so that part's great. And
yeah, in this case, I've got to give it to Prusa. They typically print really well on either
Right.
side.
So that recess you have there, what depth is that? Because that printed okay.
So this is not a recess. So I changed this one. I changed this
Ah.
one to not have the recess. So I tricked.
Gotcha. Okay.
I actually made that flat and only made the border a
Right.
recess.
So you give it the appearance it has a recess.
Exactly.
Yep.
Exactly. So that's again, when we spoke about design considerations, that's
Mhm.
one of the design considerations that you can make as well. You know, you want to think about how you want this to come out, because I wanted the texture, because this texture now looks really like, this looks factory. If you look at it,
Right.
it's something that was made professionally somewhere else. So to me, that was an important consideration.
So yeah, the bottom of your case there, it doesn't have the
It does
recess
not.
or whatever. And so you flip that over and show the camera your bottom part there. Let me spotlight this.
So this is the bottom piece.
So you can see that you've got a little bit of ribs, but those
Yeah.
printed okay. Yeah, that turned
Inside
out
print.
super nice. You can see you got lips around in the whole 9 yards. So, but by printing it face down like that,
Yeah.
you're able to build nice, side walls and then the lip around there
Right.
without
Right.
any problem. Whereas if you printed it face down,
Right.
you would have the support mechanism like I showed you in this, where the support things, and you can rip those off as long as they're long enough to rip off
Yeah.
easily.
Yeah.
Otherwise, you've got to trim them.
Yeah.
The X-Acto blade or something like this.
Yeah.
And so it's so much to consider when you're doing it.
But I think looking back over looking at the current machine quality that's available, if you would go out in the market now, temperature setting, first layer setting,
Yep,
slow it down.
Yep.
And then you're really done. All of these, I would not go and do a whole, with the current generation of printers, don't do a whole bunch of new parts. The SLA printers that Jim has, he is still on that's one generation behind still, maybe even 2 generations of where it could be. I call that still a partially experimental.
Right. So like on the SLAs, we started out with like a 1K resolution, then went to a 2K.
Right.
I have a 4K. Now they have an 8K.
Right.
And so I don't think they're gonna be higher than that. But now the build plates are getting bigger and bigger.
The build plates are getting bigger.
Yeah.
I think the whole mechanical construction has a lot.
Oh yeah, it's like a tank now. Yeah, so you don't get any kind of movement. Yeah, it's much better.
First ones were just fiddly and I think that's with 3D printers. You're at a better space now, but you're gonna have to slow them down, and you got to be, because of that weight that you've got with the print head. Of course, if you're gonna start doing things faster, there's gonna be torsion in that.
You get resonant vibration. So if you look on YouTube, you'll see a lot of videos about people saying the exact same thing you're saying. Slow it down because it gets rid of the vibration as your head's moving across. And in some cases, it's hard to slow down because you really need a little bit faster speed to get the bridging to work correctly. And so there's ways around that as well. And one thing that's gotten much better in all the slicers is the fact that if you think of how a hot glue gun works, let's say you're doing a hot glue, you're pushing down on it a certain exact same tension on your glue gun. And when you get to the corner and you got to stop and then move, what happens in that corner? You get excess glue right there because you've got to stop and then make the turn. So it's not a rounded turn. So you physically have to stop and then turn.
Right.
And so the new slicers now, they take that into account, and where they will actually back off the pressure right as you get to the corner and then turn and then go.
Right.
So you don't have that problem that we've experienced before. And that's where like case halves don't fit together correctly because you've got inside of their extra resin or FDM material.
And I think that's the other thing indeed. If you want to start having things snap together, like the case that we've been designing. This one, I don't want to push it together now, because while it has it used to have a setup for a screw, it actually doesn't need, in this case, doesn't even need it anymore. It's just got something that will center it. It will center it to the hole.
Oh yeah, yeah. So it's got a pen.
And then it will just click. It will click fit, and it is tight. It is done. You don't have to do anything anymore. You will have to actually force it to come open. Most of the time, you're not going to achieve that with a 3D printer. So hence that mechanical connection with a screw is typically the best solution. As we've been seeing Jim design and teach us how to do that normally. So I would always go that route from a safety point of view, or an STL.
Yeah, you get it apart when you're done.
Right. Yeah. Especially if you make stuff yourself, you want to be able to take it apart.
Yeah, like, oh man, I flashed the wrong EEPROM code.
Right. Right. Again.
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 The third time this week.
Exactly. And I think the other thing where you really want to do yourself a favor, find a brand that works well for you.
Yeah.
Find a color that you like, dial your printer in for that, document all of that, save it in a config file, whatever, and then buy a bulk of that and stick to that.
Yeah. So let's talk real quick about requirements for handling the filament and storing filament. And because that's a problem depending where you live, really.
Yeah. Yeah.
So the humidity affects the filament.
Yeah.
And so what you really want to do is try to store the filament in like a Tupperware container, some kind of container that's sealable, and throw some of those packets of the silicate in there. And
keep them in there. Keep them sealed as long as possible. The other
Yeah.
thing that I've seen people do that works really well, you have these vacuum seal bags, and you have
True.
the ones where you need the machine for food storage, but you also have the ones that you can use your vacuum cleaner.
Oh, right.
You just put them on and you
Yep.
seal them tight that way. Works really well. Put in some of these dry whatever those are called, and use a good sealable container indeed.
Right. Otherwise, what you're going to be doing is you're going to hear popcorn popping.
Yeah. If you
While
hear
you-
that, you know you got a problem. If
Yeah.
and actually that's a good point. If you've never heard that, you're unknown to that, you're okay. If that's what you typically hear when you're 3D printing with a spool that's been open, you will want to start looking at your storage method.
Yeah. So people in Florida or high humidity environments, what happens is that the filament starts absorbing water, and as it starts going through and heating up, basically the water boils off inside of the filament, and it starts making all these popping noises, and you get a really bad print for one. That's unusable print.
Yeah.
So there's a lot of things out there like dryers you can get for them all, but I found that I'm lucky I'm in Arizona, so our humidity here is like 11% anyway. But I know that if you simply just put them in a container, you don't have the problem. That's the
Right.
easiest way to deal with it. And you're going to put them away somewhere anyway. You don't want to have them like laying around everywhere. So just get a container of some kind that can hold, a bunch of different spools and
Right.
your favorite colors. As far as brands go, I've got Cartesian, which is the XY style. Okay.
Yeah.
There's also a Delta printer, which we didn't even talk about,
Yeah.
which I think is kind of on the way out anyway. I don't think
Yeah.
there's too much to a Delta. Delta was basically a round platform with an arm that came down and it did this all by itself,
Yeah.
up and down. And they're neat to watch, but the accuracy is not nearly as good as a Cartesian setup where you've got rail assembly. I've got Creality, a CRS 10 Pro, CRS 10S, and I've got Turnigy, and I got a couple small ones that are in boxes still never even built.
I think the
And-
Creality was probably the first printer, high quality, affordable.
Yeah.
Printer. A
Yep.
lot of people have that one. I think a lot of people are still using that one. Very, very happy with them. Good community of support as well.
Yep.
That really that was a step up from the average printer. I think there's a lot of Voron right now, and a lot of people like the Voron type of model at this moment in time.
Right.
Um,
I have a company that I use all the time. I've never talked to the guy, so he's got no clue that I'm even doing this at all. But if there's a website, it's called th3dstudio.com. and they have upgrades for all different printers. And so I love my CR10S, and I didn't want to get rid of it, but I wanted auto bed leveling that worked. And so they actually have a kit you can get that just bolts on that gives you auto bed leveling. They have the plates that we showed, and so our plates are magnetic. We didn't discuss that.
Yeah.
So
Oh, that's true. Yeah.
Yeah, so the beds are magnetic. So you put a
Yeah.
big magnetic sheet down, and then on top of that, you can you put down these plates that we've got, and you can pull them off.
Yeah.
And so the neat thing about that is that we can pull them off, set them away to have be cooling while we put the next one on, and then
Yeah.
another plate. And
Yeah.
then of course the plates are flexible, so they pop off. I mean, once they're cool, you can literally just twist it and or flex it.
Which is another
pop it off.
important thing. Eh? Remember, you always had prints that you couldn't get off the bed anymore. You had to
Chisel them.
use tools to get them off. That's,
Yeah, that was the thing
that
with,
time is all gone. There's no need.
so we went from can't stick it all to can't get it off the bed.
Yeah.
I mean, there was no happy
Absolutely,
medium.
Yeah. And Pat G, good luck trying to get that off your bed.
Yeah, so that's a big happy medium we need to be between there, and basically the flexible plates really solve that, because at that point we can flex and pull them off the bed no problem, because you really want that level of adhesion if you can get it.
Yeah.
And the only way to get them off at that point is to be able to flex the surface, and you can't flex glass, obviously. But anyway, so th3dstudios.com is a great place to go. YouTube obviously has a million videos, but the problem with it on YouTube is you get everybody's opinions on what they've done, and not too many helpful ones. There's a couple of guys on there with like millions and millions of views. There's a guy I think in Australia, or I think it's Australia or New Zealand. He's super sharp, and he knows what he's doing, and he's got some good videos on certain things as well. Same thing with the resin video printers. There's Uncle Jesse does a bunch of stuff that's pretty good, but there's a lot of opinions on everything, and no a lot of proof of anything.
Right.
Experimentation obviously is the way to learn anything.
Yeah.
And so if you experiment with your designs, experiment with your printers, it's kind of like how we learn coding and stuff on the Commodore.
I think so too. The other thing that is a really good strategy for all of this, and C. Bernard had a great comment on that. He said he trades prints for pints.
There you go.
He's got a mate that's got a printer, and he just has to send those are the best friends to have. Double up on those friends, because there are people that spend their lifetime tweaking and fiddling with their printers, and their printer has become the main hobby, not the output of that thing.
Right. Yeah.
Those are, because that's the unfortunate thing. I can't go back to that time. I really I've splurged on the Prusa. I've got 2 Prusas here. I just looked it up. If you build it yourself, it's going to be what, $800. If you have a one that's put together, it's $1,100. I wouldn't go back anymore. I just, it works.
Yeah, so I'm looking at
so you take that in consideration. Is it going to be the project to the project, and if that is fun for you, great, go and do that. If that's like, no, I'm mostly focused on actually getting good prints out, then this is where you want to go. I think people are starting to offer international service of print for pints.
So I'm looking at like Amazon right now. So a Creality CR10, which I've got. This is version 3, which is newer than mine, and it has a direct drive, which I added to mine, which I had to add. Silent motherboard. So one of the things that we learned really early on is that stepper motors make noise.
Oh my goodness.
Especially on turns, on corners and stuff, and arcs, they go. So we learned early on that there's actually driver chips you can use that make them quiet. So they make no noise whatsoever. A Meanwell power supply instead of the regular power supply. It's a build volume of 300 by 300 by 400. It's $454.
Oh, that's
from
fantastic.
Reality. So that's
fantastic.
so. And I think the Pro is $563 for the Pro, and that has all the same stuff with the BL Touch auto bed leveling and the whole 9 yards.
Oh, it's even got a BL Touch. That's which is the auto bed leveling. That's fantastic.
So what I have for mine that I got from 3D Studios was a optical, or actually it's not optical. It's a sensor. It's a capacitive sensor. And so it basically senses where the plate is in your board, and there's no touching. There's a lot of like the BL Touch is actually a pinpoint that touches your bed. And this other one uses a electronic device to sense how far away it is. Both work fine. But But yeah, literally it's so inexpensive now and so much better now, but do yourself a favor and get one that you can afford. So whatever you can afford in your budget, up that a little bit because you're going to want it. You're going to want all these features and
Right.
less headache for sure.
Right.
Otherwise you can buy a $100 printer and $500 worth of aspirin for your headaches.
At least. At least. I really do think this is one of those items where I wish I had skipped it.
Yeah,
I just
me
had
too.
skipped that entire thing and
Yeah.
just and I frankly that's even made me very hesitant to even go into SLA.
Right.
Right now I can do the print for pints on this one because
Sure.
it really needs one more generation. I feel like.
Yeah, unfortunately for me, I needed, something where I didn't go and spend, $1,200 to get a sample made.
Right.
One sample of one part and the
Yeah,
resolution
I think
needed.
for someone like yourself,
Yeah.
you got to be on this cutting edge. This is an enormous cut in cost for you to operate your business by being able to do some of this, both in time as well as expense.
Right. Yeah. Yeah. Time for sure, because you're sending something off. It might be a week before you get it back anyway.
Yeah, even if you do it local,
Right.
And I think that's important. So anyway, Jim, I think the whole SolidWorks thing, I think we're going to get more questions on that. It's
well, I got a lot last year, so I kind of wanted to, rehash this a little bit, and so that's cool.
I think with the live event next year, we're going to just have to put it to practice. We're going to have just put something on the screen and say
that'd be awesome. We'll build
a
few things. I liked it. The challenge of that. It's like, okay, reproduce this, foot or like a 1702 monitor door or whatever you want to do.
And it is all this type of stuff. You in the past have made SX64 the
end caps that we did last year. Yeah.
Remember the piece on the top as well that typically breaks off. You've reproduced some of that.
Yep.
That little door is going to start breaking off the SX64.
Oh, right.
There's so many smaller items that if you could do this, the cases, these inside of the breadbone cases, all these posts are breaking. Nice solution for that, to model that you can just glue in, and then you can, make a solid closed case again. You've shown already your custom mount for the keyboard.
Right, the rails I did. Yeah, well, actually I showed that last night when we were playing around. So that's a good example. What you can do, like for the keycap campaign, the bling board.
That's a great one. Yeah.
So for the bling board, which is after the keycap campaign, I'm doing this is a whole replacement keyboard. So the mech board that's out has this done on metal. So I actually 3D printed this part and I actually printed it in two parts, and then I just resin glued them together because resin's cool. That you just basically slide them together with some liquid resin and you hit it with a UV flashlight, and now it's done. So this was one idea which I abandoned because you can't get the switches out once you solder them in. And I went to this idea where we've got basically two rails that bolt to a circuit board. And so this is, this is a pretty simple little thing that I designed with, with SolidWorks. It's so I've got a model of the 64 and, the model of the cases and stuff. And I was able to build the entire computer and then, insert this in. So I know clearances of everything. But yeah, it's just something you can print yourself. And again, I printed this in two pieces and just glued them together. Well, resin printed sort of together.
That's awesome.
I did it in FDM to start with.
And that looks pretty good as well.
Yeah, not too bad. Yeah, it's this FDM.
That looks pretty good. Yeah.
So it gives you an idea. Obviously not as good as the quality you get out of the resin, because as far as tolerance goes, you can see that's like, and the surface is like smooth. That's the difference. The surface is smooth, whereas you've got layer lines with this.
Right.
You can see.
Right. Yeah, you can see the difference there.
Yeah.
Hey, so Jim, we're at 4. What is it? 4:10.
Yeah, we're basically done. We're having a conversation about our event.
What do you want to? Let's close the event, because I think the CRX discussion we'll do on the Discord with the open channel for people to pop in. To get the opportunity there.
Yep, we can do that.
How about you closing this event?
Okay. See ya.
I thought you had like a whole like
Oh,
wise
no,
word.
no, no. I just, well, thanks to everybody. Obviously, there's a lot of people involved in this. This is our third virtual one.
Yeah,
And
this
so,
one, you know, the panic room has been more, I don't know what the panic room has been, but it's not been panic.
no, it's well, it's good news, bad news. It's, you know, good news that we've perfected this, bad that we've had to, obviously. So I'm looking forward to next year. We have a live event, and we're going to keep a virtual component of this. If we just throw a camera in the corner of the room or something, so people can see what we're doing, and then have them presentations, you know, be on as well.
Right.
I know Saj would love to have a live Bitscape event.
Yeah,
That would be crazy.
Yeah, I think it would be fantastic to.
I don't know if we have to go to Miami or if we can like get them to go to Vegas or whatever, someplace in the US. We'll figure it out. But I'm hoping that we won't have an issue for next year. But there's a lot of people involved. So let's go down the list of people.
Oh, you're gonna miss people.
Well,
it's always, that's so risky.
Yeah, well,
you're gonna do it.
And I'll say, and others.
There's nothing that's risky enough for you not to try out.
Right, that's right.
Don't press this button.
Okay, so we've got the people that are behind the scenes are involved. Sajtron, obviously, and DJ Sajtron, he's our buddy, did the Bitscape, which was phenomenal again. And let's see, we have Michael, and we've got Jim Happel, of course, who did the presentation. Radolfo, who did the PiStorm thing today and did the little intro videos for us for various things.
Yeah.
David Yaud, who was part of the 8-Bit Symphony and buddies with Chris Abbott. He didn't present a thing this year, except he did the intro for that whole thing. It was amazing. So he helps behind the scenes as well. Chris Sakula, which is kind of a new member to our little clique. He did, you know, the Romulator and such. Who else we got to thank here, Joeri?
We got Nick, we need to thank Nick and Ken.
Yep. Oh, absolutely. Yeah, my buddies from the past. Yeah.
Yeah.
So Nick.
We gotta thank Gideon, Frank, Mr. Zimmerman, Commodore Man, Chuck, obviously, Mike as bit fixer, and then obviously Electric Gypsy, Wagner, Ray, Manta, Sitman, Mibri, Little Skill, Fast Loaders. Who else are we forgetting? We are forgetting more people. This is like, I shouldn't.
Oh, Chuck Hutchins.
Chuck,
okay, got Chuck.
Chuck, yeah.
Okay, I'm kind of going through a list of our people here so you can see, and then and then spouses.
All of the spouses, mostly.
All the spouses.
Mostly those. We're gonna make that a special segment.
Yeah.
A cut point here. Chuck, help us with a cut point. We are thanking our spouses.
That's right. Because
without them, none of this would have happened.
That's true. Absolutely true. And my wife is amazing for all this stuff. So she actually goes to the shows and stuff and helps. And so she hasn't kicked me out yet.
It would be a delight to have her back in the live version.
Oh, yeah. Yeah, she actually likes to go. So that's a bonus for me. You know, I don't have to try to convince her. Yeah. So thanks to you, Joeri. You know, for being MC and with me. And, you know, it's been quite a trek.
Thanks to all the attendees and their participation and their, you know, we've had quite a few people either cheer on or come in with suggestions or otherwise. So thanks a lot for everybody that.
Thanks. Let's see, Jack Trammell, Jim Butterfield, Jim Sachs. See, anybody that was associated with, you know, Commodore in general, they made it part of history. So shout out to all those guys.
Absolutely.
Shout out to other Commodore events, the guys that put on their events too. I know we've got a friend of ours right now having an event, and where's Zarko having his event right now?
Well, I think they just closed up, but we're gonna share the link to a video that he made for us there as well.
So what countries?
They're out in Bosnia.
Okay.
So they've had their event there, so that's great too. They've been great part of the CRX event as well. This time, of course, they had their own event, which was a live event running in parallel. We'll share a video on that one as well. I think I think with that, we've got most of them covered. So I think what we'll want to do when just before we close off here in the Discord, guys, if you go on the bottom left of the Discord, you see something called voice channels, and there's something called CRX video chat. We invite everybody that's on now into that room. We can all pick up a live dialogue together there. That will not be streamed. It will not go to YouTube. It will stay with us. It's not recorded or anything. So we invite everybody to join that. Don't be shy. Don't be shy, whether it's, you know, introvert, extrovert, whether your native tongue is English or otherwise.
If you don't want to be on video, you can just be on audio. Too.
Yeah, just join there and let's continue the fun there for a little bit.
Yeah, sounds good. All right, well, I guess on that note, we will see you next year.
Jim,
Hopefully
thank
not
you
like
for
this.
organizing yet again. I know you put
Yeah.
countless hours into this with great pride, and you know, and sharing all of that knowledge that's in that big head of yours freely with everybody. Now, much appreciated.
Yeah,
You know,
thank
a lot of people
you.
a lot of people have learned over the years a lot from you, and you continue to give freely back to the entire community. Kudos to you, man.
Oh, thanks. I appreciate it. Yeah, it's I enjoy doing it. So, you know, it's
That's
it's one of those
obvious and
things.
clear.
Yeah, I enjoy doing it.
Thanks
Okay.
a lot, Jim.
Thanks. All right. Well, guys, I guess with that, we're going to switch back to Slay Radio while I do the transition of the ending the video, and we will see you in 2023.